someone else who loves me like you used to. Sometimes we're not ourselves. There's no one I can turn to. And I know all the feelings that we shared are in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. We're moving on. We're moving on. I know times are
morning. Hey, the morning session presentation, can we have it copied to the laptop here? So we can save the time. If we can copy the presentations of the morning session, we can save our time. Thank you.
We are scheduled to start the first session, and um, for the first session, there are 3 more presentations to be loaded. So if the presenters are among the audience, I request them to load the presentation. I'll read out the name. Pralay Ranjan Behera, Subal Raul, Ramkumar Sugmar. If they are among you, kindly load the presentations. Then we can start the session at time. Thank you. Welcome to the 7th International Jellyfish Bloom Symposium. So let's begin the introductory talk. So I welcome Dr. Mike Dawson and Dr. Bijay Kumar to give a brief introduction and also overview of the symposium as well as a welcome talk. Please, around the chair.
Good morning to all. Welcome back and to the beginning of JVS 7, the presentations. And before we begin, I would like to give you some of the overview of the 3 days program. And those who are presenting in the afternoon may kindly load your presentations during the lunch break. And for tomorrow's presentation also, after the during the tea break, you can give so that they will upload it here. And we are also going online, and I'll share you the YouTube link. And you cannot directly join, but you can watch the YouTube link. In the WhatsApp group, I'll share the YouTube link so that you can watch the program on live. And after the seminar, all the presentations will be recorded and uploaded, and then you can see the presentations later as well. And this is the program. And the sessions, we have all the sessions in this hall itself. And today afternoon by 5 o'clock, and you can opt for the tour. And one is to the Varkala beach, and the second is the Lulu Mall, which is one of the largest mall in Trivandrum. And you can choose, and then accordingly we will have a bus starting from here. And you can come back from the beach or from the mall at 9:30. You will be taken back to Kovalam. And those who are staying in UDS can, the vehicle will go there. And for the other people, we will drop you at specific points, not at every hotel, but at a very close point in the main road. Okay, so that option is there. And unfortunately, we have a very poor Wi-Fi connectivity here. You have to excuse us with that because there is no other way. Probably by tomorrow, we'll try to get another Wi-Fi connection specifically for that, for this. And the tomorrow's program will be, and poster sessions will be only tomorrow. And there are specifically 2 themes in each day. That means on 23rd and 24th. And we will fix the abstract name in the board. And you can fix your posters in the respective places. Okay. And the poster places are on the right and left side corridors. And wherever you see the abstract name, you can fix the poster here. And one more thing, few people have requested us to print the posters. And they can verify that in the registration counter. And those who have given earlier, the print is ready. And those who wanted to give the poster for printing, give it during the tea break so that we can get it printed. Okay. And these are some of the general things. And on the right is the dining hall. Okay. And after the tea break, you will have a tea counter permanently there. So that means those who are staying back, you can have the tea at any point of time. And we will be giving you lunch on all the days. And on the last day, there will be a gala dinner. And in the last day, after the session, there will be memorial presentations as well. And tomorrow morning, 8:30, we will have the online presentations, poster presentations, and Mike will explain that to you. And if you have any specific, and I understand that some of you are not getting the emails in your regarding the program, and kindly give the emails in the registration desk so that I'll add it in the general group and you will get the publications. And those who have not received the abstracts, again we will be sending you the soft copy. So these are in general, and tomorrow by 5 o'clock, by 6 o'clock evening, we will have a cultural program. And this cultural program is basically the traditional age-old art form of Kerala. It's called Kathakali. And Kathakali is one of the world-famous traditional art form with a very, very long tradition. And that is actually performed by a scientist. And he's a scientist working in tropical botanical garden. And there are almost 9 different characters appearing here. And I'm requesting you not to miss that, because that will be a very exclusive experience for all of you. And there will be English introduction, and then there will be a performance. Okay, after that we'll have a high tea as well. And tomorrow we have a public lecture by Mark, that is in the capital, within the city, and that means we will be going there for the public lecture and the press meet. That's a parallel event. And 24th, there will be a parallel event on the jellyfish fisheries and livelihood in India. That will be in the conference hall upstairs. And then those who are interested can also visit the craft bazaar here. This is one of the state-of-the-art bazaar, the craft bazaar market. There are 14 stalls, and where the traditional craft people will be making the crafts, and you can buy it and you can see it. So this is a very unique place where you can see the crafts. And there is also a spice village within the campus where you can buy these spices as well. So these are in general about the program. And if you have any issue regarding any matter, please contact any one of us or in the registration desk, and we'll try to solve that. Okay, sorry for any kind of inconveniences. And now I request Mike to continue with the general directions on the symposium.
All right, thanks, Biju. Hi, everybody. Welcome, welcome, welcome. All right, so we're gonna have a few Q&As. Well, we're gonna have like this quick information session at the beginning of today and tomorrow. So if you have any questions, let us know, right? And as Biju says, let us know. We'll try to fix it as soon as possible, as best we can. Sorry? No, so I'm just going to read from it. That's perfect. Thanks. Okay. So, as Biju mentioned, uploading your talks, if you can do that down here at latest the break before you speak, that will help us. There's no need to name your PowerPoint or PDF in any particular way. If you bring it down here, the team will number it and put it in order for you. Due to half dozen or so last-minute cancellations, we revised the schedule slightly. So we have, you should be able to download that online, the latest version. Mostly we think we've emailed it to you already, but if you've not received the full booklet, again, as Biju says, let the registration desk know, and we will try to get all the information to you as soon as possible. What it did mean is that all of the 5-minute slots were rescheduled for 10 minutes. We've let most people know. Most people have accepted that, but essentially it's going to allow us to have 8-minute talks and a couple of minutes questions. So a little bit more discussion, which is a good thing. That's why we're all here. If you're given a 15-minute talk, then there's a timer on the front. It will give you a beep at 12 minutes, another at 13, and we'd ask that you kind of wrap up as soon as possible after that. We'll usher you off the stage at 15 so that we can stay on time as much as possible. During the ceremony last night, you'll have seen this was presented to me. What I'm going to do is I'm going to leave it on the registration desk, and I would invite everybody to sign it by your abstract name, right? And then we'll try to do something with that at the end. All right. If you're a if you're a chair for a session, thank you, right? Your main job will be essentially master of ceremonies, timekeeper, to introduce speaker, and then to usher them off at the end. If you're a co-chair, also thank you. Your main job is to evaluate the presentations, right? We have like a little score sheet for that. If you have any questions, let us know. And yeah, okay. And then final one is we will be looking by the meeting's end a volunteer to host the next Jellyfish Bloom Symposium, right? So think about it. Ask us any questions. Shin, Kylie, Mark are here as prior hosts. Biju and myself will be happy to answer any questions. It's actually kind of like a neat experience. So I can only recommend it enough. Okay, so with that, I'd like to welcome Sergio Stampar as the chair of the current session. And Sergio is going to introduce our first speaker, our first plenary. All right, thank you.
Good morning, everyone. My name is Sergio Stampar. I'm an associate professor at São Paulo State University, and a real pleasure to be a chair in the first section of 70 Jellyfish Bloom Symposium here in Kerala. So the main topic of this session is human jelly interactions. That's really important because it's a topic with several connections to non-academic world, especially when everyday problems are addressed in research. We will have many presentations along these lines this morning. To start, we will have our first plenary lecture. Professor Jamil Javidpur from the Department of Biology of the University of Southern Denmark will give us a lecture on the interaction of jellyfish and human action activities. Professor Jamili has extensive experience on the topic, being one of the main references currently in the complex relationship between jellyfish and human activities. Professor Jamil has been the coordinator of Horizon 2020 Project Go Jelly, co-inventor of several patent stuffs, and winner of an innovation prize about a really important flow to vortex stuff. So I ask for Professor Jamil to join us.
So we have these three lovely seats over here, right? So you're to take one of them. And I'd like to also welcome and then our co-chairs for this session to also come up to the stage, Dr. Grinson George and S.M. Rafi.
So, should I play or will it be played? Yes. It's not on the full. Okay, I'm there. So, Namaskaram, Kerala, ladies and gentlemen. That's truly an honor to be standing before you at the 7th International Jellyfish Symposium. And you can hear I'm a little bit excited, and I have to confess that is not an easy job to talk about jellyfish and presenting things in a room full of experts. So I feel like a jellyfish in the sea of expertise here. But let's go and explore and dive into complexities of interplay between jellyfish and human. And it works. That's perfect. I think the first interaction between jellyfish and human happens maybe when our ancestors saw a jellyfish, a creature outside, ran back home, and wanted to describe this thing. Thank you. Either by using words or maybe pantomimes. That is my imagination. And that is maybe interesting to look at different terms giving to one thing in a kind of cultural context. Some languages may have a specific significance for jellyfish, and others maybe simply borrow the term from other languages. And here I listed some. The common name we are using as jellyfish is referring to the English word combining jelly and fish together, But most of European-based languages were using term from Greek mythology, like Medusa. It is like from Russian language down to Spain. There are similarity here, maybe the dialect changes. But if you go to and explore other nations, like Asian one, you will see fully different context given to jellyfish. I'm Persian German, and we use the term bride of the sea for a jellyfish. In Indian, we listened yesterday that it is called Huchi. I hope I'm right, Biju? The Indian term? And in Chinese, they call it mother of water, as I understood, and I hope I'm right. Yes? And in Japan, also giving the moon seas. I hope I'm right. If not, just approach me later. That is the result of Google. Blame Google. But the oldest known capture of jellyfish in human history might start also when they started to draw jellyfish and use art in describing what they saw. Maybe one of the oldest examples is the rock cave in Argentina. We might not agree about the accuracy of seeing jellyfish on this cave, but that might be an indication of early human encounter with jellyfish. I hope we get more caves coming out of water in future with creatures like jellyfish. Knowledge from the sea comes from seagoing people and fishermen mainly. Although there were creatures like jellyfish without economic meaning or value, but still this folk biology formed a part of local population knowledge that is reflected also in different languages, as I mentioned before. It also rooted in local knowledge, like in South Sweden. Line recorded the local name of Brännvabbel to Cyanea, which is the they claim that when they get cyanea in their nets, they bring it back and they let it drying on their nets, and they use cyanea for a powder to sneeze. Also, other folk named them differently. Moon jelly, for example, in Skagen, was named because its arrival was at the same time when eel fish arrived to their harbor. And that is why they call it eelvabbel. Other nations, like Portuguese, also named the fishermen named Portuguese man o' war because the perception was different when they saw this floating jellyfish around. That's quite a nice science to go and dive into different meaning given to different things. Faroe Island people calling jellyfish whales vomit. It's still not very clear if there is any taxonomic differentiation between what they saw as whale vomit to jellyfish, similar things that they saw, but there are some association that you can pick up from the literature. Have been used as to forecast weather in I think that was also Faroe Island, where they could predict how it might be in the next day if they see some aggregation of jellyfish coming to the coast. that was really interesting for me to see, okay, whatever we're talking about jellyfish bloom was existing in this folk biology centuries before. It's not about just jellyfish and biology and maybe the creature that people saw. Jellyfish also rooted in the story of people. For example, there is a story saying, and it was said by Line's student, that a local villager, I call it Hans maybe, was tricked to believe that jellyfish is good to heal his scabies. The poor man used the cyanea to clean himself, and you can imagine he was yelling in pain and going naked out and crying. So it might seem crude, but there are also pleasant stories related to jellyfish. For example, that is also very interesting. In 19th centuries, in Faroe Island, younger men sprinkled dried and ground jellyfish on dance floor as a local love charm to attract younger women. Like this. In early 16th centuries, we can read from medical books things about jellyfish and relationship between application of jellyfish in medical use. For example, jellyfish was used as a healing elixir to cleanse dead body parts. Beyond medical use, there were also applications in using jellyfish to eliminate bug pests. It was named as rat bread, in which they mixed jellyfish venoms with bread and fed rats with this. And I don't know how effective it was, but it was used before. People and fishermen were using jellyfish slime to lubricate wheels, or also use it on their boats to facilitate movement of devices and machines. So you see, applications of jellyfish is nothing new and nothing maybe innovative, and it goes back to, and rooted to our history. But I think as a scientist, we should know who. So it is difficult to name someone who started understanding jellyfish biology. But to me, although Carl Linne started using binomial nomenclature system to list species, but it was Ernst Haeckel, a German biologist, who dedicated a great work to describing different types of jellyfish, and all of us know his painting, and we are excited when we see this, and I see some of tattoos similar to what you can see in his book. However, I have to say that although Haeckel is a prominent name for taxonomy in general, but we should be aware that he was one of the promoters of scientific racism and a supporter of social Darwinism. I'm saying that because I realized it was not clear to many of the youngers who were discovering just one part of the history, and we should be aware of both sides when we are exploring and diving into the history. But don't we think that our view to jellyfish bloom, and jellyfish ecology is a little bit biased by having many Western literature talking about that? I believe it is, because the very first evidence of using jellyfish goes back to 700 years before the Qin dynasty in China, where a philosopher described how to use jellyfish, and he provided some recepts to apply jellyfish. But I can't imagine that someone would offer and provide something to be utilized without understanding what is the sky, so what is the seasonality, when I can harvest, what is the reproduction, eggs are interesting, or umbrella. So it has been some science involved in jellyfish understanding and ecology. And that is why you see that in East Asia, we have much diverse application of jellyfish. When I visited China and my Chinese colleagues, they thought I'm there just only to test jellyfish. So we were provided by different type of jellyfish as sushi, as a salad, in a warm dish like noodle, or as a main course. It is believed that jellyfish has low caloric value and is good for your health, although there is still less science to back up. And that is also how it is connected to the traditional fishery existing in East Asia. There are fishermen who are going out with this type of simply designed boats. They take jellyfish one by one by a net, by a hand net, bring it back directly to the site when they have in local fishery villages, or they build this huge ponds, they call it ponds, huge aquaculture site next to the sea, which is not too deep. It's 1.5, 2 meters deep. And then they try to have a multi-trophic aquaculture, including jellyfish. So when the demand increases, then the market goes beyond borders. And that is what we see also, how jellyfish fishery in the world is increasing. Data goes back to Luca's paper. And I'm sure if someone should update the data, there will be much more. And you see that East Asian also exploring other areas of the world, going to the Pacific and Atlantic side as well. Nations also come without any self-application or need to use jellyfish are also coming to this market. So here is a graph showing that, so maybe this one, showing how trawl fishery is now taking cannonball, a pure harvest, I would call it, from the US coast. That's amazing to see how huge is the harvest, but the challenge is to have a supply chain already ready, because we are talking about kind of fragile creatures, and so they are treated. Different parts are taken apart because different parts have different monetary values. So the tentacle, as I understood, is more expensive than the umbrella. And then, so what they do, they wash it and dehydrate jellyfish immediately by putting them in salt boxes like here, and then they get ready for transport back to China or East Asia. So, and that is what they called a $1 million fishery. So that was a suggestion to think about why not adapting our existing fishery to something that the fishermen could benefit more. So in the season where there is a traditional fishery like this one, so they go for fishery, and then off the season, which is the case in many areas, they also change to jellyfish fishery. But climate change is ongoing. habitat, we are damaging many habitats, and the figure here shows how opportunistic jellyfish might benefit from all these ongoing changes. I have to say something which is very important. When we are talking about jellyfish utilization or fishery, we should know that jellyfish in general refers to a group of more than 1,000 species. Here, we should talk about what kind of species we are talking. So don't read me wrong. So I'm talking about opportunistic jellyfish that might also benefit from changes, mismanagements that we have in the world. And that is a trend that you see worldwide. You know all that we still do not have robust data to support it, but that is a trend. And I can see from the area where I'm coming, and when I go and sample jellyfish in fjords, it is like a soup. So there are good examples supporting this increased trend of jellyfish worldwide. And with increase of their biomass, it is also connected to social and economic changes. I believe I can't go to the next one, no. Because here I want to show you what is the extent of jellyfish damage that we're talking. So I just keep it here as a non-presenter mode. So here is a desaline site in Israel, where it was filled by jellyfish, they call it attacked. And then once jellyfish go into the site, they have to close everything and then clean it. And it takes them maybe a week, and which also brings or has a huge economical damage to the industry. So, back. And altogether, I think, brought us to see an increase of attention from a scientific community into jellyfish. My last picture that I showed with the jellyfish in the circle food web indicates that some years ago, 40 years ago, jellyfish were seen as the dead end of the food web, which is not the case nowadays. But as you see here, from 2026, 2010, there is a huge increase in putting money to understand jellyfish ecology. I think one part is because of the demand is increasing and the awareness of many Western countries on this possibility, but on the other hand, we also shift the view to the importance of jellyfish for marine food web. I had a look to existing patents of the last 5 years, and surprisingly, you see many new patents coming. Also here, I don't have the years, but that is in the last 5 years, and it increased as well. Besides some patents that were dealing with collagen extraction and use of jellyfish, many patents came from China. They are still a master of filing a patent. But there are also fiction involved in that era, I would call. I show you here one patent from the US back to 2014, which described a very innovative chrysalis to cultivate jellyfish. But we know from the work of Wolf Greve in 1968, when he described the same thing. So patent agencies should do a better job in claiming their rights. altogether brought us as a consortium, and I'm talking on behalf of 16 different partners, to think about all these caveats and possibilities and issues related to jellyfish bloom into a project that we named it Go Jelly. In Go Jelly, we wanted to understand if we can think of applications from surplus biomass of jellyfish in using in biotech innovation like cosmetic, nutraceuticals, or medical branch, or using jellyfish slime to filter nanoplastic, or using jellyfish as fertilizers and feed and food. The project was mainly European, but we had also China as a partner in that project, and we were working with industry hand in hand. I don't want to talk about my project, but I just wanted to say that it was really trying to start from the ecology of blooms going up to the technical readiness level of 6, 7, which was a challenge, talking to different type of stakeholders. But we made good progress here. So here is the demonstration of our jellyfish filter that was used in wastewater management. Unfortunately, our Israeli partners couldn't come, but I hope they still are able to present their work online. So we had industry in which they use jellyfish combination with algae to think of a fertilizer. We had an industry putting jellyfish collagen in their cosmetic products. And also Antonella, who is going to talk after me, did a great job to provide recipes of jellyfish for Western style food and application. So we had flow to vortex as a cage, that innovative cage, which was tested, yes, on Madeira. So the cage that you see here inside the fishery cage has the diameter of 2 meters, the length of 3.5 meters, big enough for the first prototype to be tested for jellyfish aquaculture. We also produced huge amount of knowledge, like bringing the students on board, publishing children book, using drones and high tech to spot jellyfish and predict jellyfish. We also made our Jelly Spotter app for the Baltic North Sea area and asked people to spot jellyfish. And we use this data to make a matrix model and make the first prediction of jellyfish bloom in the Baltic Sea. Data are still on the way to be published. And here is the movie from my colleague from Norway showing their kind of jellyfish fishery practices, and you see Periphylla here coming on board with this huge amount. So we also made a jellyfish Go Jelly a stakeholder game in which we played scenarios for people who never heard about, and let them playing to understand what is the sustainability and sustainable fishery and jellyfish bloom. And you can also play if you like. It doesn't take long. But with all of these other actions, other creativities also came into the play. Here, I hope, oh no, I can't. So that was, okay, so it was a YouTube song, singing, oh yes, it is there. sorry to watch this. Could you skip that? I don't have. Okay, if you don't touch it, I can then. But if we do it together, yes, and the song. I hope I have time. If not, it doesn't matter. So you can have a look to this YouTube channel, which is a kind of cozy, cool song that those ladies are playing. It's okay. Good. So I don't have sound here. Oh, okay. Good. If we touch it together, yes, very good. Or this very interesting product, which is a shoe and a dress made by Jellyfish. So you can call it Jellyfish skin. I found that really interesting, actually. The artist comes from Netherlands, and she made her own process to make a very solid material from jellyfish. Or in robotic tech, now we have a jellyfish robotic, which was used to transport drugs in your body. The demonstration here shows a mini robot of 5 millimeter, but they are now making 1 millimeter small jellyfish that they inject into the blood and then could use it to transport drug for a specific type of, for example, cancer. With all that, and I think our journey just has scratched the surface of innovation, and I'm excited to see what future brings. But we should also think that this all has no limitless resource and opportunities. So that we should be aware when we are talking about biomass of any kind, they are limited, and we should learn from the past to not mismanage again and do the same mistake we did with fish. And 2 minutes. Okay, so that's all. What I want to advocate is to think about, I see here 7 minutes. No, okay. A sustainable use of jellyfish, and I ask everyone who is in support of sustainable data collection and use and utilization of jellyfish to please sign this petition. You can also ask me and approach me to share the link with you, and we hope to get, first of all, the very first baseline to go on for the future use of jellyfish. Thank you very much.
Thank you, Jamil. It's really nice, really nice. So we have time for 1 or 2 questions. Someone?
Okay. No question is also a question.
So, thank you, Jamil, for your talk.
Thank you.
So, now we are continuing our talks. Now it's time for Antonella Leone.
Hey, so just one more quick announcement.
terms of student awards, some folk I think didn't let the registration know that they might be interested in being considered for award, but they are. So what we're going to ask people to do is, if you're a student, you're interested in being considered for the award, just kind of like come up through this way, let the chairs, co-chairs of the session know that you're interested in being considered for award, and then they'll like evaluate you for it. Okay. So if you're interested, as a student interested in an award, come up this way, let them know to evaluate first. Thanks.
This. Okay. Yes, sir. Thank you.
So, yeah. So Professor Mike Dawson will give a gift for Jamlin as a thank for. Thank you again, Emily. So now, in fact, Antonella will speak about the jellyfish blooms in Mediterranean Sea, a potential source of functional novel food. Antonella, thank you.
Thank you. Good morning, everyone. Please, can you start my presentation? Okay, thank you. I will talk about jellyfish bloom in the Mediterranean Sea as a potential source of functional food, not only food, but functional food. First of all, I would like to show you the situation in my place. This is a video filmed by the BBC that show the situation in the place where are usually sampling in Ginosa Marina in the south of Italy. You can see Rhizostoma pulma, a large number of big Rhizostoma pulma, very large in size, and that was our target species for developing novel food from jellyfish. This is our usual sampling day. You can see that the jellyfish bloom very near to the coastal zone. Rhizostoma pulma is not the only species that blooms bloom in Mediterranean Sea. We have also Aurelia, Cotyloryza tuberculata, and also non-native species such as Ropilema nomadica in the Israeli coast, and Cassiopeia andromeda in the Malta and Italian coast. Our work is directed in two main topics: to develop jellyfish-based novel food and to extract bioactive compounds from jellyfish. Indeed, we studied the composition and the nutrition, biochemical, nutraceutical properties of some Mediterranean jellyfish species for their potential exploitation as a source of novel food and bioactive compounds, mainly nutraceuticals compounds. Indeed, we developed, in the framework of the Jelly project, we developed a new procedure for processing jellyfish with new processing that we patented. The new process is without the use of alum, which is toxic, and use instead of alum salts, aluminium salts, calcium salts, organic salts. This process was patented, and also we patented some prototypes of jellyfish derived food products, such as mousse, seasoning, and meringue based on jellyfish as a main ingredient. Our question now in this presentation is, are jellyfish-derived food also functional food? What means what functional foods? Functional foods are foods that have a potentially positive effect on human health behind their content of macronutrients like proteins, lipids, carbohydrates. They can content other components that can be beneficial for the health, human health, and the benefit may be some chemopreventive components because they may protect against the development of chronic disease, for example. So we started to study the composition of some rhizostome from Mediterranean Sea, such as Aurelia, Rhizostoma pulmo, Cotyloryza tuberculata, and the non-native species Cassiopeia andromeda. We found that, is usual, that you know that the dry weight of jellyfish is very low, between 2 to 10%, but this dry weight is composed mainly of inorganic salts and organic matter. The organic matter is composed mainly of insoluble and soluble proteins and non-protein components such as lipids, carbohydrates, and pigments. Among insoluble proteins, the main protein is collagen. Collagen is a very interesting protein because have many biotechnological uses, for example, in medical fields, in food industry, and also in cosmetics. We found that collagen isolated and fractionated from Rhizostoma pulmo have a strong antioxidant activity in vitro and in cell culture, and we found that the low molecular weight fraction of collagen, hydrolyzed collagen, have a very, very high antioxidant activity. Peptides from this fraction were also demonstrated to have a cytotoxic, not cytotoxic effect on normal human cells, such as keratinocytes, and they provide also protective effect against oxidative stress in the same cell cultures. Another question was if peptides from jellyfish can be similar to other dietary antioxidants and biopeptides that can play a role in the so-called oxy-inflammaging. The oxy-inflammaging is a process that is the result of the interplay between oxidative stress and inflammatory stress that in human cells lead to the many chronic diseases based on oxy-inflammation instead. So we found that peptides we identified in the pepsin and collagenase hydrolyzed jellyfish from Rhizostoma pulmo, we identified some peptides with anti-inflammatory and immunomodulatory activities. Here in this table you can see several peptides, the sequences of several peptides with these recognized activities. We also found that jellyfish peptides have an immunomodulatory effect and potential anti-inflammatory activity in human macrophage, as they were able to decrease, for example, the gene expression and the synthesis of the pro-inflammatory cytokines interleukin-6, TNF-alpha, and interleukin-beta. And also they were able also to increase the gene expression of the interleukin-10 that is recognized a potent anti-inflammatory cytokines. So, talking about not protein compounds, we found that hydroalcoholic extracts from the zooxanthellated jellyfish, such as Cotyloryza tuberculata and Cassiopeia andromeda, demonstrated very high antioxidant activities. And this is due mainly to the content of zooxanthellae inside of this kind of jellyfish that increases the biodiversity of the jellyfish species, because they contain a lot of bioactive compounds. Indeed, we identified several non-protein compounds in such hydroalcoholic extracts, such as phenol compounds, fatty acids, mainly long-chain fatty acids with very interesting biological activity, and pigments such as pyridinine, beta-carotene, and so on. All that compounds have a known antioxidant activity and many biological activity on human cells. We already demonstrated that Cotyledonidea tuberculata extracts have a cytotoxic effect on breast cancer cells, MCF7, and we also identified the action mechanism at the basis of this cytotoxic effect. That was the effect on cell-cell communication based on gap junction intercellular communication. Now, we also demonstrated that extracts from the non-native Mediterranean jellyfish Cassiopeia andromeda have anti-proliferative effect on two breast cancer model, the non-invasive MCF7 cells and the highly invasive MD-MDA231 cells. They also have this cytotoxic effect based on the pro-apoptotic effect on both cell line, and also we identified the mechanism of action underlying this action, which is again based on the the transient increase of cell-cell communication. Last but not least, we are working now on jellyfish as bioactive biomaterial for edible electronics, but this is still a work in progress in collaboration with Serbian group. And as conclusion, we can consider also further studies on different jellyfish species and on processed jellyfish for food are still needed. We can conclude that the biomass of some Mediterranean jellyfish that have already proven to be safe as food can be considered functional food, and this is in line with the Asian tradition, mainly Chinese tradition, that consider jellyfish in food therapy and in the traditional pharmacopoeia. Of course, we need still to develop fishery and processing at not industrial but low level, but to have functional food, novel food in Europe, because the regulation of European countries still not allowed the jellyfish as food because it is not traditional food, but we can consider jellyfish as a source of new, novel, functional food. Thank you.
Thank you, Antonella. Time for questions. We have time. Or down.
Thank you so much. Thank you for that very interesting talk. I was wondering if you have tested jellyfish as an actual food item. It seems like you've done a lot of cell line research, but have you done any research looking at the effects of jellyfish consumption on, for example, mice or rats, to see if these same effects are reported, and is that necessary to actually call something a functional food? Thank you.
Not yet, not yet. The in vivo studies are still not considered. You can, we focused on Rhizostoma pulmo because it's already considered edible in other countries, in 30 countries as compared to Europe. And our aim is to jump that kind of studies, except for the allergenicity studies, because that point is really important for human health. The allergenicity studies still need to be done, and to me that is the focal point for these following studies.
More question there.
Thank you very much for a very interesting talk, Antonella. I have a question. So it's astonishing that you get good results with calcium-based salts to get rid of the water in the jellies. I wonder, why has it always been salts, aluminium-based salts, that they used for drying jellyfish before? Because we know about the toxic and non-healthy impacts on humans. Do you have any ideas? I mean, is it giving worse results if you use calcium compared to aluminium salts, or what is the difference? Why are you the first to actually revolutionize this dehydration process of jellyfish?
We eliminated completely the aluminium because the levels that of aluminium in the products already in the market, mainly from Asian countries, have a level of aluminium higher than the level allowed in Europe, because China increased the allowed level just for that products. So we needed to completely eliminate aluminium because the focus is one health. So the health of human and the health of environment, but the health of human pass through the elimination of all toxic compounds.
We have time for one or two questions. Over there.
Nice talk indeed. Did I understand correctly that hydroalcoholic extracts were mainly products of endosymbiotic algae? Do you consider that these endosymbionts that you can find, Symbiodinium, you can find also free-living, can contain similar compounds?
Yes, the main compounds we identified, such as pigments, are from Symbiodinum, of course, because jellyfish is an animal that cannot produce pigments. But I think that the symbiosis per se can produce different compounds than the single Symbiodinum in culture. So the wool holobiont, composed from jellyfish tissue and Symbiodinum or other macroalgae, can interact to produce more component or in different amounts than the single component. So it is the holobiont the source. And we have to work on the holobiont when, for example, we try to cultivate in aquaria. We have to try to increase the good compounds on the holobiont as a wool.
Thank you, Antonella. Again, thank you again. So now we're listening to Pralaya Hajan Beheira about talking about emergent commercial fishery of catostilid, jellyfish, Crambonella, and Andalii from the western Bay of Bengal.
Good morning to all. I am here to deliver a talk on emerging commercial jellyfish fisheries on catostylid jellyfish, Crambonella anandali from Western Bay of Bengal. As you know, the jellyfish is the marine drifters. constitute one of the important component in marine ecosystems. And it has both positive and negative aspects on the marine ecosystems. If you see the jellyfish fisheries all over the world, as per the report by FAO, Sophia 2022, jellyfish production in world oceans from the capture fishery, only 2 species, Rhophilema species and stomach cannonball jellyfish, their contribution is more. And as far as aquaculture is concerned, the red jellyfish, Rhophilema esculentum, that contributed from 0.5 million tons in 2005. That has been increased to 0.9 million tons in 2020. This indicates the importance of jellyfish fishery throughout the world. And globally, it has been seen that more than 20 nations that involved in harvesting and processing of jellyfish. And almost 38 species of jellyfish have been consumed by humans. And China is one of the dominant producers of and consumers of the jellyfish and contributing more than 60% of total jellyfish production throughout the world. And consumption of the jellyfish mostly popular in Southeast Asian country. Due to demand in the Southeast Asian country and Asian countries, jellyfish fisheries are expanding throughout the world. And if you see the report published by FAO in 2022, they have, in that report, they have given more emphasis focusing on the inclusion of low trophic aquatic animals, including the jellyfish, in order to meet the sustainable development goals by 2023 and beyond. So, with context to Indian scenario, if you see the jellyfish fisheries began in the year 1980, and that time the fishery started, only main purpose was for exporting the processed jellyfish to the Asian countries. And first jellyfish fishery developed along the Indian coastal states in southeast coast of India. And that time that process of jellyfish mostly on rhizostoma species. Then in India, if you see in Indian coast, only 4 dominant species, Cremorina anandali, Rhophilema hispidum, Catastellus perigi, and Cremorina orsini, the most dominant contribute to the active jellyfish fishery in all along the Indian coast. And if you see the only the body parts like your oral arms, mostly they are processed and they to export to the Southeast Asian country. And as far as consumption is concerned, there is no consumption in India. And if you see the only Cremorina anandali, that is a catastellar jellyfish, if you see the distribution pattern, that is endemic to the Eastern Indian Oceans. And that species is considered as important fishery commodity because the processed body parts like oral arms and umbrella, they mostly have good demands in export markets. And if you see in Indian scenario, that scientific information on the fisheries, then economics and harvesting procedures of the Cremorina anandali that are lacking. So my main objective of the study to document the jellyfish fisheries and the economics and harvesting and processing procedure, and to whether the jellyfish fisheries is beneficial to the small scale fishers along the coast of east coast of India. So that is the main objective of the study. The study has been carried out along the east coast of India, mostly one coastal state is Andhra Pradesh, that is located in the central east coast of India, and study duration from 2017 to 2019. We have collected the details data regarding the fishing crafts, fishing gear involved for harvesting the jellyfish, fishing operation, fishing season, and details data regarding the landings of the oral arms and total jellyfish landing, their value, everything, all data we have collected. And data collection, the methodology followed based on the questionnaire survey and random sampling methods. And we have also collected the economics of the harvesting of jellyfish. Regarding operational cost and return analysis of catching the jellyfish by fishing crafts, also we have collected the data. And the results, if you see the jellyfish fishing, if you see the mostly the motorized fishing crafts, mostly used to harvest the jellyfish, the Cameroon and Anandali in inshore coastal waters. Fishermen, they venture into the sea in early mornings and they do fishing, operate the gill nets, mostly locally that known as Poluswala. They operate that gill net at a water depth around 10 to 40 meters. In each fishing operation, each haul, they kept the gill net inside the water around 1 to 2 hours. And if you see the fishing seasons along the east coast of India for Cameroon and Anandali, it was found that during the month of March to July. And if you see the inside the sea, fishermen, they after catching that species in gill net, they remove the bale parts, only the oral arms. The oral arms along with the oral disc, they used to bring to the seashores and they used to sell to the local traders. Then after that, the processing happened. This is the estimated landings and valuations during the period 2017 to 2019. If you see 8 different locations, the jellyfish fishery dominate along the coast of Andhra Pradesh in western Bay of Bengal. If you see in 2019, only one place, that is Opada, that total estimated landings of the overall arms, that was around 1,241 tons. Whereas in 2018, 8 places are active jellyfish fishery of that particular species was there. In 2017, only 6 places. And total jellyfish production for that particular species for 3 years, it was estimated around 55,000, more than 55,000 tons. And estimated amount of oral arms was more than 16,000 tons. And if you see the value of the oral arms, in 2019 it was at 1,020 lakh tons, whereas 2018 it was the total value of the estimated value of the oral arms landed at 9,982 lakh rupees. Then if you see the month-wise variation of the jellyfish landings in 2017 to 2019, if you see jellyfish started in the month of March and ended in July. If you see the 2018, 2019 and 2017, in the month of June, most dominant fisheries was observed. And 2018 average monthly jellyfish landing was highest, it was around 8,318 tons. Whereas 2019 it was lowest, it was around 310 tons. If you see the economics of harvesting the jellyfish by motorized fishing crafts, if the average operational cost includes the input cost, fuel consumption, fuel cost, and repair maintenance, other charges. Among these, crew wages that is, constitute more of operational cost. This average crew wages per fishing trip, it was around 2,752 rupees. And average cost return analysis per fishing trip, if you see, total average operating cost, it was around 3,527 rupees. With a gross revenue, there was 6,271 rupees. And a net operating income per fishing trip, it was around 2,744 rupees. In each trip, the catch rate was 191 kg. If you see the range of the catch per fishing trip, you see per boat, it was around 160 to 220 kg per trips. And labor productivity, if you see the labor productivity in terms of 30, that indicates that these jellyfish fisheries along the coast is beneficial for small scale fisher. And the price of the overall arms per kg, it varies from 10 rupees to 38 rupees per kg. And average price, it was around 29 rupees per kg. And if you see that 2017 and 2018, the price was high at 38 rupees, but 2019, the price drastically reduced. It was around 10 rupees per kg of. And this is the processing, packaging, exporting of oral arms, how the local trader or processors are doing the different steps they followed. Along the coast of Andhra Pradesh, east coast of India, in 2017, 18, 19, total 12 processing units was established. All processing units are temporary. It means during the jellyfish season, they operate their processing plants. Once jellyfish fishing season over, then they are closed. And here you can, the 5 major steps are involved for processing the oral arms of the jellyfish. First is cleaning They used to do oral arms clean in a circular tanks containing seawater. They used to keep the oral arms seawater with a salinity of 25-50 for a duration of 2 hours. Once the cleaning over, they remove to separate tanks for salt soaking or salt mixing. Here you can see they used to add 50 kg of common salt per ton of oral arms. And here they add alums, the potassium aluminum sulfate, 2 kg per tons of oral arms. In the previous speaker, they told that alum that is not good for health. But here that way of processing, that a traditional way of processing they used to do, followed. Then steps 3 also same process, the soaking or salt mixing process. Then depending on the size, they used to do their grading different, grade 1, grade 2, grade 3s. Then finally they used to pack in 20-liter buckets that constitute 16 kg of the processed oral arms with a 3 liters salt water and 1 kg of common salt. After that, they used to export to the China. This is the different steps of processing and packaging export of the oral arms along the coast. And some of the issues and challenges for jellyfish fishery of the particular species along that region is one is the fluctuation in demand in export market and price set by the processor and trader. You can see the price in 2017-18, it was around 38 rupees per kg of the oral arms. But in 2019, due to the ban in China, that due to the ban in China, import ban, the price drastically reduced to 10 rupees. So that 2019 and 2021, that jellyfish processing and fisheries totally stopped along that regions. And one of the major issues that closed fishing season. Actually, in east coast of India, if you see 15th April to 15th June, generally observed as a closed fishing seasons. During that period, the government of India declared as a closed fishing season to allow the juvenile stock fishes to and brood stock to do breeding in that particular season. So, but jellyfish swarms mostly happen during that period in summer, during the month of March to July. So this is one of the issues. So that fishermen are not allowed, mostly motorized craft, not allowed to venture into the sea to catch that jellyfish. So this is one of the issue. Then another seasonal interannual variation of the jellyfish swarms of that particular species. And another issue is that once you harvest the, okay, just one minute. Then processing, if the processing method, here the processor followed the traditional way of processing, and mostly they are using the alums. Level of alums, that is one of the bad for our health. Then another one, discarding the umbrella and bell. So they are not using whole body parts, only the oral arms they are using. So if the umbrella, if they can use, then this will be give more benefit to the small scale fisher. Then the conclusion, here you can see the jellyfish mass swarming mostly happening in summer month, in the month of March to July, which led to targeted jellyfish fisheries, and oral arm mostly processing happened here, and total estimated landing of the oral arm 16,555 tons. And seasonal jellyfish fisheries provide additional income to the fishermen during summer seasons, and targeted fishery of the species assumed to market defense. And further studies on life cycle growth and feedings are needed to understand the biology and ecology of the species. Thank you.
Thank you. Thank you very much, Pralaya. Time for one quick question. Yeah. Risman? There. Over there.
Hi, Pralaya. Very interesting presentation. Now, me from Southeast Asia, we do eat jellyfish. Now, I'm just wondering, in India, is it a culture to eat jellyfish?
There is no tradition of consumption of jellyfish in India.
Not yet. So, thank you, Pralaya. We have that. So, now we have Hannah Brolo to talk about the development of short-term wormful jellyfish forecast model for the salmon aquaculture industry.
Hi everyone, thank you for having me here. My name's Hannah and I'm from University College Cork in Ireland, and today I'm here to talk to you about Jelly Forecast, a short-term harmful jellyfish forecast for the salmon aquaculture industry, and this project has been co-supervised by Dr. Tom Doyle and Dr. Damien Haberlin. So why do we want to forecast harmful jellyfish? Well, we've heard a little bit today about aquaculture of jellyfish, jellyfish fisheries. Of course, traditionally there's a lot of aquaculture of finfish, so salmon aquaculture. And as you can see here from a couple of newspaper clips, jellyfish can actually be quite detrimental to this industry. They can cause kind of different mortality events and also some low-grade morbidities as well. There's a couple of different species that are problematic, such as the one here on the top, which is Pelagia noctiluca. Typically a more Mediterranean species, but we do see it in Ireland, particularly in the north. So in Northern Ireland, back in 2007, there was actually a really large fish kill there. Initially, numbers were over 140,000 salmon that were killed, but the total, after about a week, it was over 250,000. So essentially, the whole farm was wiped out in one go. And we also have other harmful species, such as the siphonophore Muggy atlantica, which is the species that I'll be concentrating on here today. This has been implicated in fish kills, not only in Ireland, but also in places like Norway, where over 100,000 salmon were killed at one time. So to look at where we are for this study, so we're in Southwest Ireland, and we're concentrating on the bays in Southwest Ireland, particularly Bantry Bay, and I've pointed out where the salmon farm, or one of the salmon farms that I have sampled at, is present. This bay has a long history of not just finfish aquaculture, but also shellfish aquaculture, and that's actually what kind of piqued our interest in it initially. Harmful algal blooms have been a problem here for many years as well, and there's been a long history of needing different mitigation measures to try and combat this for shellfish producers in particular. And also something that's interesting about this bay, the wind in Southwest Ireland, the prevailing wind is southwesterlies, and the bay is actually axially aligned to this wind pattern. So there's quite an interesting circulation that happens here during the summer months, and we'll kind of get into that more a little bit now. So in Bantry Bay, under kind of what we call normal conditions, typically we have a southwesterly wind blowing, which is aligned to the bay, as we saw on the last slide. That kind of pushes that top layer of warmer water up towards the head of the bay. So this is all happening during the summer months, so when there's been a lot of solar heating, the water column is stratified, so we have our thermocline there in the middle, and then we have our cold, denser water here on the bottom. So this is our typical conditions, and you have your offshore waters that's outside the bay. And then what happens is you get a relaxation, or sometimes a reversal of the wind pattern. So you might get a northeasterly or a strong easterly wind blowing, and that will actually be blowing almost directly out of the bay. And that's pushing that top layer of water back out, pulling in the bottom kind of cold, denser water, and shallowing the thermocline as well. And then what we've kind of dubbed as a flip-flop event, or what's an exchange event, I suppose, between the bay and the offshore waters, it happens then once you return to those normal conditions. So there's been a couple days of either relaxed or the opposite wind, and it reverts back to that prevailing winds. That's the main wind pattern returns, and you get an influx or kind of an exchange between the bay. I think it's up to about 70% of the bay waters become exchanged with the offshore waters, and that brings in any plankton. So what Rain et al. Had looked at with phytoplankton, we're kind of hypothesizing might be happening with harmful jellyfish blooms as well. So now how do we build on this? How do we create a forecast or a model? Well, we need to look at the correct time of year, which we've mentioned already. And that also is important for the zooplankton that are present. So Muggy atlantica occurs in Ireland not all year round. It's not a resident population. It only occurs in kind of the more summer months. So the kind of danger period, they call it, is more between June and the end of October. And you can see here just from Haberlin et al. Over the years, that's kind of typically been the case, where it's end of August, beginning of September, so almost autumn time really, where we start to see increases in the numbers of Muggia atlantica. Another thing is we need harmful gelatinous zooplankton data, so we need to go out and actually collect and ground truth this model and see what we think is happening. Is it actually happening? Is the jellyfish present? We then also need to look at wind data, so wind strength and direction. And we've from Rain et al., we've adapted their wind index that they use to try and pick out when these flip-flop or exchange events actually occur. And then along with that, we look at the fish mortalities data as well. So I'm actually doing this project in collaboration with a salmon seafood producer, Maui. So just a little bit of detail more on the methods then. So I've been going out since 2020 and taking triplicate zooplankton samples every 2 weeks. So that's over 78 different sampling dates over 4 years. The samples are collected every 2 weeks, as I said, or monthly in the winter when we know there's kind of less of the zooplankton around. You can see I'm pictured there on the top left, just beside the salmon farm. So that's actually where I sample. My station is right next to the salmon farm, approximately 100 meters away from it, just on the westward side, so towards the kind of bay side of it. And we also take environmental variables as well. We have a handheld CTD that we can take environmental variables to get our temperature and salinity and depth profile as well. And all of them collected, all the samples are collected with a 0.5 meter ring net with a 200 micron mesh and a non-reverse flow meter as well, so we can get those kind of more accurate densities of zooplankton. And just a little kind of more overview, I suppose, of what I'm looking at. I do look obviously at the harmful gelatinous, but we're also interested in all the other gelatinous zooplankton that are present. So over the 4 years, I've identified 32 different species or genera of gelatinous zooplankton from 179 samples, and that's all just within the one bay, Bantry Bay, that I showed earlier. The highest number of different species recorded are generally in August, with about 22 different species identified over the 4 years in August. And after Muggia atlantica, and we'll come back to that in a little bit on the abundance, the next most abundant hydromedusae were Lysia blondina, with a peak at one point of 977 per meter cubed, and Aglantha digitale at over 300 per meter cubed. So now to kind of look at this model that we've developed. So we're kind of calling it a hindcast model. So we've collected our data. Now we're kind of retrospectively looking at the wind patterns and the wind directions and see, can we pick out these flip-flop events and can we correlate that with the zooplankton data that we've now collected? So what we're looking for, this wind direction data, is actually our axial wind, so that wind that's blowing in or out of the bay. We're looking for when that wind either reduces to zero or goes negative, which does happen quite a lot. But what we're also looking for is the wind speed or the wind index, and when that reaches a threshold that kind of Rain et al. Had put forward as probably the most likely when there's going to be a flip-flop event or an exchange event, is when that wind speed reaches over 10 meters per second. So you can see there's about 5 events there that do kind of meet those conditions. And then we have our zooplankton data as well. Now there's a little COVID symbol there just because, so we look at that window between June and the end of October. Unfortunately, due to COVID, I wasn't able to start sampling until about the end of July, so we're just missing a little bit of data there. But we do know from looking at the historical data that generally Muggia atlantica isn't going to be present, at least not in high abundances, till later on, so end of August, beginning of September. And so we can see that there. So we have our first event, no data, but pretty confident that we won't be seeing much Muggia. Then we have our second flip event there with the blue box and lined up with the red lines there. And it goes from virtually, I think it was less than 1 per meter cubed to over 100 or over 200 per meter cubed. So there's quite a sharp sudden increase in the numbers of Atlantica. And then again, there's a second flip-flop and another jump. It had gone down and jumped up again. And you see kind of a little up and down there after that. Probably there is some kind of, in situ population growth at that point, and Muggia's been in the bay for quite a while. And then there's 2 more flip-up events later on, but we're kind of out of that period where Muggia is quite abundant, so we don't see any increases there. So 2021, we see kind of a different picture here. So in the last slide, we saw that there was a couple of flip-up events. This year, we don't see any that we really define as a definitive flip-up event. And we also see much lower numbers of Muggia atlantica, the individuals per meter cubed, reached only just above 40 per meter cubed, whereas before it had gotten to over 300 at one point. And we also can see from the way the Muggia increased, it was quite gradual, a bit more stepwise than before. There's not that sharp, sudden increase and it wasn't preceded by a flip-flop either for 2021. And we do know from that year we carried out a research cruise around the southwest coast, so outside of Bantry Bay, all around that kind of southwest coast of Ireland, and we saw pretty low numbers of mugia that year in general. And 2022 is the last year I'm going to show you. We can see that there's kind of 4 different events that we've picked out here. There's some either quite strong, actually negative axial winds, and followed by increases in the wind index to above 10 meters per second. And we see this was a bumper year for Mugia Atlantica. Initially there was nothing really happening until about mid-August, and then all of a sudden it did increase to over 2,000 per meter cubed, reached a peak at one point of 3,000 per meter cubed. And I just have a little fish symbol in there because we did see an increase in mortalities following on from that increase. And yeah, then it kind of gradually disappeared again, and once it was outside that window, the flip-flops that did occur after weren't followed by an increase. So just to summarize all those findings together, so 2020 we saw 5 exchange events, 2 of which were followed by an increase in Mugia Atlantica. 2021 there was no definite exchange event that we could pick out, but there was a gradual increase in Mugia Atlantica. In 2022 there were 4 events, and 1 was followed by that really sharp increase in Mugia Atlantica to the highest numbers that we've ever recorded in Irish coastal waters. And just a key takeaway message, I suppose, is from what we're seeing, every sudden increase in Mugia Atlantica has been preceded by an exchange event that we can see in the wind index and the axial wind data. And so, following on from this, we have successfully hindcasted some events using that same model that Rain et al. Has used for harmful algal blooms. Now we'd like to incorporate more detail, so we want to incorporate a hydrodynamic model with outputs of surface and bottom velocity flows. You can see just from this graph here, obviously the circulation that I showed you earlier is quite a simplified version of what's happening. Of course, there's little eddies here at the start of at the beginning of the bay. The circulation actually goes in a clockwise formation, so there's a lot more going on than just that simplified version, but that gives us a good proxy for the circulation in the bay. And then we want to run this in forecast mode, so eventually hope to have it potentially as an operational bulletin, much like the HAB bulletin that's available now for agriculture in Ireland. So thank you for listening. I'll take any questions.
Thank you, Hannah. Some questions? We have questions here. Yeah.
Hannah, thanks for the presentation. If I ask a couple of questions. The first question, if you do the same sampling in a place where there is no aquaculture farm, you've done it very close to the aquaculture farm. If you do the sampling in a similar place where there is no farm, is it going to affect the results of the model? What do you think? It's a hypothetical question.
So we have actually sampled not just next to the farm, but we've sampled within Bantry Bay at different points. We've done a transect actually kind of going along the bay just to look at, do we see similar numbers? Is Mugia present throughout the bay? And we did see Mugia Atlantica not just next to the farm, but actually quite a while away from it as well. So yeah.
So the results seems similar.
Yeah, exactly. Yeah.
So it's not going to be a prototype for the farm itself, but it's going to be a prototype for the jellyfish blooms. What is going to happen?
Yeah, exactly. And I didn't show it there, but there's also some other kind of species we see that co-occur with Mugia Atlantica, such as doliolids, which we know are quite an oceanic species. They appear about the same time as Mugia does as well. So we're fairly confident that it is oceanic intrusion rather than anything else. Yeah.
And it's a preceding event. What is the lead by which the event is happening?
Pardon, can you repeat that?
It's the blooms are occurring as a preceding event, like the exchange is happening.
The exchange happens in the bay, the circulation.
Lead of the presence of the bloom. So what is the difference? Like how much lag is there from the occurrence of the bloom and the event?
What was the last bit there, sorry?
What is the time lag?
Oh, the time lag.
Between the bloom and the event.
It's usually like in and around the same time or a couple of days after. Just a small bit of a lag, but a couple of days.
So the difference is 2 days.
Around that, yeah.
2 days.
Yeah.
Okay. It's surprising. Like you have taken only one variable. Like the wind is going to be the dominant variable. But in general, any organism this can have an impact. Either it is leading towards its food, or its suitable environmental condition where it can be comfortably staying.
Yeah.
So what do you think is the reason for this? Why wind is becoming a more accurate variable for the...
So for this bay in particular, this is what we're going off with Rain's model. The dominant circulation is wind, so that's kind of the best proxy we can use at the moment for circulation. Of course, temperature and different things will come into effect. And we do have environmental variables that we're going to put into that, and then hopefully looking at the hydrodynamic model, we can actually see for definite with the velocities and the flow what's actually happening. Yeah.
Thank you. All the best.
Thank you.
I have time for a quick question. Quick question here. Dougal?
Hi. Thanks for the interesting talk. When you are getting your results on the numbers of the animals, are you also looking at the sizes or their reproductive stage, or eudoxids versus the polygastric siphonophores?
Yeah, so when I do any counts, we count polygastric stage, we count the eudoxids and the other larval stages as well. So we do have we know how many of each we have, yeah.
So for things like the Eglantha or the Lizio, whatever like this, are you seeing it's like a single cohort, I guess, or do you see like mixtures of the very small ones coming in and growing in there, or any information on the size stuff that you found interesting?
For the other zooplankton, is it like Eglantha? I haven't really looked at that. I haven't measured them. We just have counts for those. So I'm not sure if there's different cohorts or not. But we think for Muggy Atlantica, there was that event that happened in 2022 where there was huge numbers, and it that bloom stayed in the bay for quite a while. We have had students looking at samples of that. From what we can see so far, they're all the same. They were initially from the same cohort. So yeah.
Hannah, I have a question.
Yeah.
You have the model is based on wind speed and direction. Have you taken out any other parameters like hydrodynamics or water quality parameters into your algorithm model?
So what I was showing there is just the wind at the moment. So every time I've taken samples, we also have taken environmental variables, and the salmon farm itself actually has recordings of temperature. So I think it's twice a day, we have temperature recordings at 5 meters depth. So the plan is to add in all those variables as well. And then the hydrodynamics are coming in, as I mentioned at the end there. So there's actually an operational model, the Bantry Bay hydrodynamic model, that's now used as part of the HAB bulletin to give warnings, advanced warnings on these kind of flip-up events or different things for HAB. So we're going to try and add that in and see, does that work for the jellyfish as well?
Yeah, that will give you a leap to you.
Definitely, yeah.
Thank you.
Thank you, Hannah. So now we have Sun Woo King talking about precautionary management of jellyfish bloom by polyp elimination. Yeah.
Good morning and namaste. Ladies and gentlemen, nice to meet you. I am Sun Kim from Korea Marine Environmental Corporation, KOM. It is a pleasure to give a presentation during the International Jellyfish Bloom Symposium. Today, I will be introducing the precautionary jellyfish polyp management program of Korea. In order to respond to jellyfish bloom, we have to understand jellyfish. To this end, survey and research are important. But that is not all. The goal is to preserve the marine ecosystem and contribute to the benefit of humanity. We didn't stop at research. We controlled the jellyfish population for sustainable marine ecosystem service. Content. Moon Jellyfish Polyp Management Program in Korea. Climate change and human activities are causing jellyfish bloom. Adult medusa are being removed to reduce jellyfish population. But there are limitations such as a lot of budget and manpower requirement. In addition, the damage occurs again to following year after the removal of the adult medusa. Moon jellyfish population increased rapidly in the polyp stage, so it is efficient to remove the polyp stage. Compared to adult medusa removal, polyp removal can do the same for only about 2% of the cost. The moon jellyfish polyp management process is in 3 stages. Explore the polyp mass habitat, finding polyp, finding hotspot, remove polyps, and post-monitoring. Explore polyps with lots of artificial structures, weak currents, and eutrophied waters first. And make a national polyp distribution map. As a diverse removes the polyps, the amount of removal is calculated by comparing before and after. And then post-monitoring population changes at each stage of life cycles and check if the polyps need to be removed again. High-pressure water jet is used to remove jellyfish polyps. Selectively use flat shovels, scrapers, and brushes depending on the substrate attached to the polyps. Substrates that can break easily, such as styrofoam, use polyp inhalers and automatic brushes to prevent secondary damages. Detailed process of polyp removal and post-monitoring method are showed in poster session, so please refer to them if you are interested. Achievement and future plan. We have had polyp managed since 2013. In this symposium, we introduced polyp removal in 2016, and in 2019, we showed adult medusa reduction achievement. Now, we have carrying out the mid-term strategy. The first strategy was successfully completed last year, and the second strategy was established through implementation evaluation and is in effect from this year. Let me briefly introduce this. As a result, the following achievements were achieved. First, we reduced the total amount of jellyfish polyps in our country, which is 4.5 billion individuals. If natural mortality is not taken into account, it is same as removing this much adult medusa. Second, as polyps decreased, the number of days of moon jellyfish warnings issued decreased. And in 2019, they were not issued nationwide. After 2020, moon jellyfish warnings have been issued in some areas. However, while the Nemophilema nomurae warnings was issued across the country, the moon jellyfish warning was suppressed to local waters. Third, polyp removal not only prevented the bloom of adult, but also resulted in the recovery of a benthic ecosystem. In the past, the area where only polyps were concentrated has been restored to various organisms returned after polyp removal. In carrying out the first plan, we get additional achievement. Deungyang Bay in Korea has been under jellyfish warnings for 8 years out of the past 10 years. We continued to remove polyps from the inside of the bay, but the warning was repeated. So we monitored the wide area search to the surrounding sea area. As a result, we found out that jellyfish come in from the outside. We also found the origin of jellyfish source. The origin has been removed for the past 2 years, and as a result, no warnings has been issued this year. We intend to apply this method to other chronic problematic waters. In consideration of the experience of carrying out the first plan and various environmental change, the second strategy has been established and operated. The primary goal of the first plan was to eliminate polyp hotspots. The second plan was established to maintain this reducing jellyfish and stable ecosystem. The goal of the second plan is to improve the health and resilience of the marine ecosystem. Let me tell you the main strategy of the second plan. First, integrated management of jellyfish polyps nationwide, combining jellyfish population and habitat environment by life cycle. A trophic light system will be created for the possibility of jellyfish damage. Red light waters will be prevented by removing polyps. In addition, by applying various monitoring methods, we will be able to predict the bloom of jellyfish better than before. Based on the monitoring and prediction, we will further increase the effectiveness of polyp removal. We will also strive to improve the resilience of the marine ecosystem. In addition, we will train citizen scientists and strengthen our domestic and international network. Please help us, please, please. Conclusion. We successfully completed the first plan, and we have made a second plan by assessed and reflecting the first plan. The national polyp reduction will be further extended by reflecting spatial information. Unexpected problem will be solved by management of origin. We will also reflect the changed conditions. The second plan is to shift the paradigm from reducing the total amount of polyps to maintain a stable ecosystem that jellyfish has been reduced. Jellyfish management capabilities will be utilized to manage other harmful marine species in the future. We will continue to exchange our achievements and method with you all. I hope This will be help improve jellyfish management and reduce trial and error in countries around the world. And I hope that share the progress of the second strategy with you at the next symposium. And as I said at the beginning, I hope that our studies come together and be used to manage jellyfish and contribute to the benefit of humanity. By the way, I'm not good at English, so if you have some questions, then please just send me the email. Thank you. Namaste. Namaste.
Thank you, Sun-Woo. And I can open for questions. No, you prefer not? Yeah. Can you put again the last slide? Last slide. Yeah.
And if you are really going to ask some questions, then after this session, then came to me. Thank you. Namaste.
Thank you so much. Thank you. So now we are moving to Alexander Yan, that will talk about the versatility method to culture different Kitnaphore species here. Oh, Alexander. Yeah, it's the last one before the tea that we have. Yeah, we have half an hour of specialty here. So, thank you, Alexander.
Yes, good morning, everyone. So I am Alexandre Jean. I am from Michael Sars Center in University of Bergen in Norway. And as you may know, Tinophore are not jellyfish, so it's good for the jellyfish conference. No, so they are comb jelly. So combs are the little iridescent structure you can see on the animals, and they use this structure to swim. And in our research group, we use Tinophore as a research model for neurology. And we study the origin of the nerve system into those animals, because there is a strong evidence of Tinophore are the earliest branches within the animal kingdom, and they have a really unique nerve system. And today I will introduce you the protocol established by Joan Soto-Angel, which is in the conference today. And I also add some modification to this protocol. At Michael Sars Center, we have a quite unique facility. We are culturing Tinophore all year long. So with that, we are able to do our research on Tinophore without depending on the abundance of animals in the sea. And this room is quite stable, and to allow me to have quite stable condition, and I can control the water temperature. I have access to natural seawater, and I can divide my breeding system in 4 different units. So with that, I can also play with different parameters. And today I will show you 3 different species we are culturing. Our main model is Neniopsis lady, but I'm also developing other species. So Neniopsis lady, we have it in culture since 2018, and we have a stable culture. So since this period, we haven't collected a new broodstock in the wild, and so it's a quite sustainable protocol. And then since last year, I start to raise as well Bolinopsis imphibidulum, and this year I start to raise now the Pleurobrachia pileus. And by raising other species than Neniopsis, it will help us to open new doors for research. And maybe Neniopsis is just one exception within the group of Tinophore, but by culturing other species, we will know that. So in this presentation, I will show you some key parameters to culture Tinophore or jellyfish in general. So which is first water management. the proper food for each species and depending of the stage of the life cycle, choosing the right aquarium, as well closing the full life cycle to have a sustainable breeding in your facility, and then also some specific requirement for each species. For the water management, so as I said before, I'm really lucky. I have access to natural seawater all year long, very stable seawater from the depths of from the fjord, and I have a salinity of 34 ppt, and with different as well temperature. But by having a continuous access to natural seawater, I can have a clean water all year long. And with that, it helped me to monitor easily my pH, my temperature, salinity, and pollution level. Because all those parameters are very important to raise ctenophore, or jellyfish in general, but you need to have the best water as you can, and to have access to very clean water is the key to start to raise your animals. Then for the foods, I am using 3 different main food sources. So I will start with Brachyneus plicatillis, which is a rotifer. So it's a small plankton around 200 microns. We can raise it easily from with the microalgae, and it's a good food to start larvae. Then as other main foods, I use Artemia salina, a very easy food because it came with dry eggs, and you just drop the eggs in the water, and within 24 hours you have live food, and ctenophore love it. And I also add copepods, mostly frozen copepods for sanitary reason, because if you use live copepods specifically from the wild, you can introduce some parasites, and parasites into a stable culture is not good, so I try to not use copepod often, but for some species, as I will show you later, it's a key alimentation. And on the last picture, you can see a ctenophore with the foods inside the gut. And why I show that? Because it's quite important to monitor, to check the quantity of food within the gut of the ctenophore, because if you overfeed them, then they will just puke everything, and then you will introduce pollution. So for all jellyfish or ctenophore, it's very important to feed them properly and to not overfeed them, otherwise we will start to have water pollution. And for the different kind of container I'm using, so initially the protocol so they were using bucket with pipette and beaker, but now we slowly move to beaker for larvae and spawning our adult, and cradle instead of bucket, because with cradle we can have a continuous water change, and then we have a better management of our water quality. But if you want to start with a very low-cost techniques, the buckets work really well, but the quality of the water management, it's a bit more tricky. But it's a very low-cost technique, so to start, it's a very good point. And now it's part of, I'm talking about the life cycle. So ctenophore are mostly holoplanktonic species. So by holoplanktonic, that means they are doing the whole life cycle in the water column. And as well, they are, as far as we know, mostly hermaphrodites. So they are both male and female at the same time. So technically, they can do, so only one specimen can do a successful reproduction. But it's always better to use several adults to avoid the self-fertilization. So for spawning, ctenophore seems to be, so the spawning of ctenophore seems to be triggered by light signal or by a photoperiod. Some species seems to spawn after a long period of exposure of light. Then you have night, and then they spawn. Others, they spawn the morning, some the afternoon. This is very specific. I will show it a bit later for the case of Neniopsis. So first, we need to isolate the adults. We place them in a beaker. So with that, we can concentrate spermatozoid and oocyte. We keep the eggs into beaker. Within 24 hours, they are able to, at 18 degrees, they are able to hatch. And then we have a tiny larvae around 300, 400 microns. So it's a good size to prey on Brachionus. And then we can keep them for a long period in beaker, or if you have a large batch and you need to grow a big number of animals, it's easier to start to place them in a little cradle, and once they're in cradle or buckets, you can complete the life cycle. And within within a month, they're able to be what we call adult with a lobed form, and it's approximately 2 to 3 centimeters, but obviously they can grow larger than that size. And in the case of Neniopsis lady, as I said, the spawning is triggered by a light cycle. So for our population, because it has been shown that different populations have they respond differently to light within the species of Neniopsis lady, they need 7 hours of darkness before spawning. So for how I can say, for an easy management of spawning, I'm automatically switching off the light of the animal facility at 2 a.m. So with that, the next morning at 9 a.m., animals are ready to spawn. So that means I can start the day, I come, I pick my animals, and then they're able to spawn. And after they spawn, like within less than an hour, I can provide the embryos to the researcher, and then they can play on the embryo, or then we can also raise the larvae for different experiments. And a small resume of the different requirements for each species. So Neniopsis lady, I forgot to mention, but it's not native from Europe. Initially it's from America, but now since approximately 20 years, it's invaded Europe and creates a huge bloom, and even up to north of Norway. And in Norway, the abundance period is, I would say, late summer to mid-fall. But in captivity, the best temperature range seems to be around 18 to 20 degrees for our strain, and with a salinity of approximately 26 degrees. And it's a shallow water species. And in the Norwegian fjord, the shallow water, so the surface water, is diluted by the continuous rain, because Norway is very famous for the heavy rain. For the main foods, I give rotifer. Rotifer seems to be the most important foods, and from juvenile to adult, and it seems to be important to give this food for maturation of adults. While for Bolinopsis, Amphibidulum, it's a bit a more sensitive species who need to be in colder water with higher salinity, and for them the key food seems to be copepods. But as I mentioned before, copepods are a bit difficult to raise, and so it's a limited factors. But it's very important for Bolinopsis to have copepods, otherwise they are not able to mature. And Pleurobrachia, so who looks like more larval of Neniopsis, but it's still quite large, can grow up to 2 centimeters, and it's very plastic for accept a wide range of temperature from 10 degrees to 20 degrees. In captivity, nature can accept a bigger range, but in facility, it's better to keep it in this range. And for salinity, the natural seawater is great, and as well, copepod seems to be a key element for maturation. But Pleurobrachia is a very challenging species because they're very, very small. Larvae are around 100 microns, so I can't feed them with rotifer as a first food. So for that, yeah, you need to find some tricks. And copepods can be a key, or using natural seawater but non-filtrated seawater. And so, yeah, at Michael Sars Center, we have a unique facility in Europe. As far as we know, it's the only facility who is able to raise Tino4 for research all year long. And currently, we have 3 different species, but I'm developing more species to address other research questions. And as well, within this facility, yeah, we are able to daily produce embryo or larvae, adults, and for researcher. So I would like to thank the people in blue who are deeply involved into the Tino4 part. So Pavel Burkhardt, my group leader, and Karina, our researcher, Eva, engineer, and Katarina, and one of our students, who is counting every day our eggs production, so thousands and thousands of eggs to optimize our production. And Joan Soto Angel was a former group of our member of our group, and now which is still at the University of Bergen, but Natural History Museum. And yeah, if you have more questions, you can find my emails or you can ask them now. Yeah.
Thank you, Alexander. Alexandre. Questions? Yeah.
Alexandra,
Yes.
nice presentation.
Thank you.
From the massive spawning, what is happening, and the larval development to the adult to the matured ones. How long is the life cycle?
So for Neniopsis, from eggs to adult, it's like 3 weeks at 18 degrees.
Okay. And the size of rotifer, it varies with the temperature, I guess. Like the type of same species, Brachionis plicatus, what we see in Indian waters will be different in size when it comes to the subtropics and to the temperate conditions.
Yes.
So do you find such anomalies during the lab work? Because you already indicated that rotifers, you have an issue with the size of the rotifers. So whether temperature is having a serious impact on the size of the rotifers which you are running in the laboratory conditions?
Yes, it could be a great opportunity, but as well, since I am alone in the animal facility, I can't raise too many strain of live food, because time management between raising the food, raising the animals, producing eggs, I need to try to keep it simple, so it's why I have only one strain of rotifer. I have 2 types of Artemia, and 2 have different size and different nutrient value, and copepods as well. I try to keep it very small, but it will be definitely a good way to go to have different size, different kind of plankton. Yeah.
Okay, thank you, Mr.
Yeah. I've seen Rebecca Helm. Yeah.
Oh, that's
No, sorry, no, I don't see well. Yeah. Great.
It's a beautiful system. Congratulations.
Thank you.
I think I know the answer to this question, but I assume they don't eat frozen copepods. Does that have to be live food all the time?
Can you repeat that?
I'm assuming that they don't eat frozen copepods because that would be too easy. So does it definitely have to be live copepods that you feed them?
So I can give some frozen copepods, but it's not as efficient as live one, because Tino4 are not really good to... No, I will say it differently. They need to feel live food. Otherwise, if it's just like a dead particle, and also dead particle will sink really fast in the aquarium, and once the food is on the bottom, they're not able to catch it because I don't have tentacles like jellyfish, so they're not as efficient in captivity to prey on dead food.
Just as a follow-up, would it help if you co-fed them live food at the same time you were feeding frozen copepods?
I don't know. Normally, just for time management, I'm doing only one kind of food at the same time, but I could try.
So we have one quick question here.
Yeah, that's a nice way of doing the culture. What's the frequency of your species, and what is the spawning frequency of the same?
Daily. They spawn daily. And what was the...
The number of eggs per spawn.
Oh, it's very variable from the size of the animal and so of the quality of the animal. And it seems to see there is also a difference between the year. Even if I have a quite stable... so the conditions in the lab are stable, but for some reason, maybe they feel some like atmospheric pressure or just the circadian cycle. We have also some variation within the year. I will say one adult of 5 centimeters can easily produce more than 1,000 eggs. Yeah.
Thank you, Alexandre. Yeah. So now we have a tea time, yeah, for half an hour.
Sorry. All right, so we're just a little bit behind, so we're going to take 20-minute break. If that's the case, we'll meet back here at 11:35. Right. And then can Angel, Yanagihara, Miriam Paul, Sriram, then Matthew Moran, Kurian, Matthew, Abraham just come see me before the break? Please, thanks.
Hello, excuse me. These two persons who have sent us the posters, kindly report to me. Sedino Poso and Andrea Toso. If you really wanted to print your posters, please report to me. Then we will make arrangements. We missed three presentations in the desktop here. One is by Isam Sabah. Vasudevan Shankar and Amit Lotan. If you have the presentations, please come and load here.
Sometimes we're not ourselves. There's no one I can turn to. And I know all the feelings that we shared are in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. Moving on, we're moving on. I know times
Hello guys, more 2 minutes to restart. Okay. Hello, people. So let's go restart our our session. Now we have Subal Rowe that will talk about characterization of small-scale jellyfish fishery and its economic efficiency along the Odisha coast, northwest of Bay of Bengal.
Good morning to all. I am Dr. Subal Kumar Rao, scientist from ICS Central Marine Fisheries Research Institute. And I am here to present my research topic on characterization of the small-scale jellyfish fishery and its economic efficiency along the Odisha coast, northwestern Bay of Bengal. And northeastern region, if you see regarding the jellyfish fishery, and this is the first ever we have documented from this region. And as already our previous speaker also something similar topic they have delivered from the southeastern region of Indian coast, that is from Andhra Pradesh. If you see the global scenario, and there has been increasing demand and interest in consuming jellyfish as a potentially important marine resources, and altogether 38 species have reportedly been consumed by humans around the world. And globally, around 20 nations currently involved in fishing of jellyfish. And the majority of the commercial jellyfish fisheries focus on the species belongs to the order Rhizostomidae and class Scyphozoa. And mostly the consumption is mostly in the Southeast Asian countries. And China continues to be the major producer and consumer of the jellyfish. And coming to the Indian scenario, and even though India has started harvesting edible jellyfish dating back to 1984, but a very little information is known about the edible jellyfish fishery and its economics along the Indian coast. And currently, as my previous speakers already discussed, and if you see the only 4 species, that is Crambiana anandale, Orsini, and Catastylus parisi, and Rhophilema hispidum, they contribute to the jellyfish fishery along the coastal waters of India, mostly from Andhra Pradesh, Tamil Nadu, Kerala, and Gujarat. And if you see the economics, only the sporadic reports exist on the economics of jellyfish. And recently, only one catastylid jellyfish, that is Crambiana anandale, contributed to a small-scale seasonal fisheries along the Odisha coast. Therefore, when you reviewed the research papers, we didn't find any articles on such aspect. Therefore, we are prompted to characterize and document the jellyfish fishery and its fishing activities together with economic efficiency along the Odisha coast. And coming to the materials and methods, and we just based on our survey and from the fisher folk and the traders, and we have selected some learning centers, and we have done our survey and sampling, and we have collected the primary data, and mostly from the crafts and gears, fishing operation, fishing seasons, and quantity of oral arms for jellyfish landed, and value of oral arms. And if you see, like, we followed the random sampling methodology for data collection, and we also surveyed and interviewed the jellyfish processing plants and local traders, and data on also operating cost and returns also we have collected, and economic performance of fishing techniques was also performed. And this is the figure. You can see the first one. This is my sampling location, and along the Odisha coast. This is the 5 landing center where the jellyfish are landed, and these are some of the photographs. You can see there is a here also only fishermen, they bring the oral arms, and the umbrella they used to discard it back to the sea. And you can see the second photo. It was like the one of the photo for the sourcing, and where the it comes multiple species. It's bycatch. And coming to the result and discussion, and these are the more than 18 species of jellyfish of recorded along the Odisha coast, and it's including my works also. Yeah, these are some of the photographs for the jellyfish along the Odisha coast. And coming to the detailed specification of the crafts and gear and fishing operation, and these are the details. I'm not going to details. And the only very important thing is fishing season. It is happened to during the month of December to April. You can see the in Andhra Pradesh, which is different. This starts from after April only. So probably there may be some kind of migration, because once it is appearing in the winter along the Odisha coast, then after that is appearing in the along the Andhra Pradesh coast. We don't know exactly why it is appearing like that. Why not this same time period? So there may be a requirement to study on such whether any migration is there, any yeah, there is a need to do such aspect. Only we have done gillnet. Our study is based on the gillnet only, gillnet fishery. And we also collected the specimen also we brought to our laboratory. We have done some of the analysis, some little biological aspects we did. And the month-wise, the details of the table showing the bell diameter range, mean depth, all the details, sex ratio, maturity stages. And we also did some of the length analysis so to get the preliminary. And it is our future work also will be going to study in details their biology. And coming to the processing of the oral arms of Crambiana anandale, this is the same procedure which was followed along the Andhra Pradesh coast. Here also the same procedures. I'm not going to in detail. It's already talked by our previous speakers. And these are some of the photographs, the step by I have presented here, after from the collection from the landing center, how it is transported, then to the processing units, or the different steps of it followed, and finally the final product is packed and exported to the via mostly the Chennai to China. Yeah, this is the coming to the cost and return analysis, and from this table clearly indicate that the net operating income is about rupees 5,664, And if you see the catch per trip, it is on an average 577 kg. And very interesting thing, if you see the capital productivity with operating ratio, it is like more than 5, that is 0.5 here, that which indicates that fishery is economical viable. That means it can provide a like a good support to the our small scale traditional fisher. And if you see the price realized, it ranges from rupees 20 to 25 per kg of oral arms. And the operational cost details here also I am showing the rupees per trip. And this is the, if you see the like input cost, the highest contribution by the crew wages, that is around rupees 5,665, followed by the fuel cost, that is 1,899. And as a conclusion, I'd like to conclude that the jellyfish fishery from India or from this particular is not yet explored. And if you see the global marine fish stocks which are declining, and if you judiciously exploit these jellyfish for a sustainable manner, can provide an additional income and alternate livelihood to these small scale fishers. And the present study revealed that only oral arms of jellyfish are processed using a salt and alum treatment. As already some of our previous speakers, they told alum is toxic, it's not good for health. So it's a requirement that there should be an alternate method to process these oral arms. And like fishermen, they are discarding the umbrella to the open sea. So how best like awareness should be created to like process this oil, that umbrella also, so that additional income can be taken by the fishermen. And the efforts at baseline information which will support the development of appropriate handling practice, initial stabilization and harvesting techniques, as well as the promotion of edible jellyfish as a potential food item in the country. Yeah. And I'd like to thank my director, Dr. A. Gopalakrishnan, ICS CMA for providing all necessary facilities and support during the study period. I also give a big thank to my PI of this project, Dr. Sarvanam sir, for including me in this project so that I could able to contribute something to this project, and all the staff of my Puri Field Center who helped me both in the field and laboratory and finally the fishermen who are the major stakeholder. Without them we cannot, it's a very difficult to achieve the whatever the result we could show here. And these are my references, and thank you.
Thank you so much. So, time for questions. Start here. After that.
Thank you, Subal. My question is, initially you must have seen the invited lecture where they were showing like how the factory ships are used for the harvesting and processing and related aspect. In your presentation, it was indicated that the operational cost is less than $100 US. It's typically a small scale fishery, and the major cost of fishing goes to the wages or the labor what is involved. And it seems to be there is a lot of abundance. Jellyfish blooms are happening everywhere, so there is abundance of the resource. The operational cost it's very less.
Yes.
What is the main lacune which is hindering the progress of jellyfish fishery as an industry?
Yeah, problem is there availability of blooming of jellyfish. It is not there throughout the year. Some year it will be available, some year it will not available. And also if you see the raw material, when a processing unit is established, there is a continuous supply of the raw material is required. As to a continuous export of the product. There is also a problem. Only only 5 months you will get. After that, fishermen they are not getting. So that may be the one of the reason. And another things most of the product they are using alum, and sometimes the target country and all there is standards are there. So sometimes it may be problem for the the assignment can be cancelled on that may be the. And there should be more hygiene should be practiced, and awareness is also a requirement is there. And even we can tell the fishermen that we can harvest, but unless until there is a well established processing units and the continuous supply, it cannot be achieved probably.
So there is a need for capacity building in this area.
Yes, sir. Yes,
so what are the initiatives taken for this?
We have just we'll do, sir, in future.
Thank you, Mr.
Yeah.
Thank you. One more question.
John Nishikawa from Japan. Thank you for interesting talk. And my question is there any differences on selling price between both species? The selling price.
Selling price per?
Selling price difference in
The
selling
price to sell.
between species.
Oh,
Four
no,
species,
for your kind information, only one species, that is Crambionella anindale, is is having commercial value, and only species that is processing and things are practiced. None of the other species.
Okay, in East Asia, the selling price is different with
Yeah.
species.
Yeah.
So I just curious. Thank you.
Yeah.
Last one, Jamil.
Thank you very much. So I think you agree with me that sustainability has a very main pillar of thinking of circularity. I wonder where all those umbrellas go.
They are just discarding back to the sea.
Oh.
They on board they are practicing, because it will, if they are bringing with the umbrella, it will be like more space will be like on board, it require more space. That is the reason. While on board itself, most of the 90% of the cases, it is on board only. They are like removing the oil lamps and they are throwing back to the sea. That is the practice I have been observed.
Thank you.
Thank you.
So thank you very much.
Thank you.
So now it's my time. Yeah. Hello everyone, again, more one. So we're here to talk about a really interesting event that occurs in South America, and some consequence of this event or something like that. So the title of my presentation is Blooming of Craspedacusta Jellyfish in Brazil, revealing the enigmatic evasion with potential danger ramifications. So cool title, yeah. So now we are moving from the sea to the land, because we are talking about freshwater material that, in fact, we have some limitation when we are talking about the species of freshwater cnidarians, because normally we are not so interested or something like that, because these animals are normally so small, so tiny. So normally we're much more interested in very, very huge jellyfish that we can dive together and something like that. We recommend some guys here to dive. It's pretty cool. But in fact, we have at least two really interesting groups in freshwater. One, you know, Endocnidozoan, that is a parasite group that's only related to the fish and other groups. So it's pretty cool. And another one relates to Hydrozoan, that's the focus of this presentation, in fact. Recently, we published an inventory, a review of freshwater species from Neotropic area. And it's become really evident that we have some problems to record the animals from there. Because we have some information from specific points, especially when we have a lot of people living there, of course. But we have a huge area, it's a red area, but almost nothing know about that. So it's really important. Of course, we know much part of this is Amazonian rainforest. We know that we have some problems to collect there, but it's important to go there. We have some universities in this area, so it's possible to sample in this area in general. Nevertheless, the most part of these records is related to Hydra. It's not the others freshwater Hydrozoan. That you know, Hydra is not related to have, at least that you know, a jellyfish. So the other groups that occurs a kind of jellyfish is related to only one genus, or the most important genus that we know is Craspedacusta. Related to this genus, Craspedacusta, we have some
different records from South America, especially from Brazil. But in South America, we have at least 5 countries with records of Craspeda custa. So we have in Venezuela, we have in Brazil, we have in Argentina, Uruguay, and Chile. So most of these records, except from Brazil, most of records are related to the natural places. So rivers, natural lakes, or something like that. However, in Brazil, this scheme is completely different because almost all records are from artificial systems. From the beginning, in the almost one century ago, our records are only from aquarium, fish tank, artificial lake, artificial reservoir. Only 20 years ago, we start to record these animals in a regular place, in a natural place. So it seems so strange for the general discussions, at least. So, our new facts. Recently, we found several jellyfish, Craspeda custa, in a very small town, Ariranha do Ivaí, the name of the place, in the south. Oh, come on. So funny that the microphone is still working. I will keep my time. I'm boring the other guys because of the time and my time. So, let's go. So, in this very small town, we found a huge group of jellyfish in a tilapia farm. Yes, it's not an artificial system, in fact, because it's a dammed river, but it's more or less so. So the occurrence of this jellyfish in this area is not so uncommon, but the consequence was really strange, because in this tilapia farm, this jellyfish probably kill everything that was here in these tanks. So in this tank, it was huge tanks. So killed around 12 tons of tilapia fishes in this area. During this mess, we are calling to sampling some jellyfishes in facing the fish farms that are not so happy, of course. We got some specimens and brought to the laboratory and start to understand the animals. Was really cool because it was possible to sampling the animals just putting a cup glass in the lake and take away, because that is completely full of jellyfishes, and in preserving ethanol just to check at the lab. All specimens were measured, photographed, and the kinodome evaluated. And after that, we conducted our molecular analysis, regular one, Sanger, classic one, to find the sequence of CO1 to identify the material. In general, the morphology is the regular one for Craspeda custa, common. But the more relevant data is all specimens are female. We never found a male in that material. So we reviewed more than 100 specimens, so all female. So, and the kinodome is the regular one with the heterotrochus, microbasic varieties. So the size is the regular one from 8 to 14 millimeters. The molecular data shows a really interesting point, because our material is not so close with material from Canada, but exactly the same. There is no single basis of difference from the material from Canada, probably because of fluorine. Yeah, you do. But we have no idea why. But this material from a natural system or something like that is completely equal from the material from Canada. So it's very related to other material from China, but with some difference, but completely equal from the material from Canada. So, in short, we reached that this material is in fact Crespidacrusta sowerby, so the unique species really accepted for this genus. So there is no evidence to a new species or something like that. However, the most important point for our discussion here is related to impact in the farms, the fish farm, because at least up now, we have no idea the impact of this kind of freshwater jellyfish in this system, in this artificial or natural systems to the fishes, because we saw a lot of examples in marine systems with really interesting or important impact in from jellyfishes to fishes in marine systems, but in the freshwater is the first, at least as we know, is the first data that we know that occurs something in the fishes, especially killing the fishes, and then having a problem to the farms. So it's completely, you know, as Jamili told you, talked to us, it's completely different when we are involving different people, especially non-academic people, especially in this kind of discussion, because after this event, the fish farmers ask for our government the refund of the price of the fishes. So there is a politician system together. It's a lot of information rolling out at the same time. So it's completely, it's really complicated to extract the real fact. When we start to discuss, we have one amount of money, and then after 2 weeks, this money raised for 10 times. So it's really difficult to extract the real information. But in fact, we saw the tilapia was killed in that lake, at least. And probably because of these animals, because they are blooming in so huge density that can just extract the oxygen in this area. So probably that's happening in this area. So now we are creating a system, at least an outreach system, to try to monitor this kind of occurrence, especially in the fish farmers, to understand if it was only isolated event or it's happening in different points, but no recorded up to now. Yep. Thank you for your attention. So you have questions, please.
Yeah, this is an opportunity to ask some question to the chair. He was prompting questions to all of us. So feel free to ask some questions.
Thanks, Sergio. Interesting thought. Maybe I missed it about your phylogenetic tree. Which marker was that?
CO1, yeah. Because the database of this genus is only based on CO1. We have the other sequences, but it's not possible to do something relevant yet, up to now, at least. There, yeah.
So I'm not sure if I also missed it, but what is your guess or best guess what caused the bloom for this?
Probably it's because of the rise of the temperature in Brazil, because we are facing some problems related to that. No, we are not only us, but the world in general, but we are facing some really huge problems on the temperature, and problem the amount of fish in these tanks, because the quantity of the fishes in that tank was pretty huge. It's not common in general fish farmers, so probably is something related to that.
Thank you very much for a very interesting observation. So my question would be, maybe I missed it, it's very refined or kind of confined to certain areas that you find this freshwater jelly, and it's a non-indigenous species. So are there any efforts trying to eliminate or eradicate, the jellies in the areas and ponds where you found them before it's kind of spreading and gets out of control?
Yeah, exactly. The only method to remove everyone is to dry the lake. Yeah, in fact, the recommendation of this kind of the procedure of recommendation is to dry the lake to restart the culture. In fact, so it works apparently because it's almost impossible to find the polyps. You know, this polyps is too small, so it's really difficult to look in to find in the lake. So it's not possible, I think. Go.
Do you have any plans to do an eDNA survey to see if you can find Crespida costa in other places?
Yeah. In fact, we are doing that exactly that now. We're trying to create a kind of system in all states of Brazil to doing some points of eDNA to trying to find these animals. Not only Crespida costa, but the other freshwaters cnidarians, but especially for Crespida costa. One question, last question. Yeah. Mike, you killed me.
Can I go?
Where?
Yeah, I was wondering about the sex determination because it's been found in many populations that they are either all male or they are either all female. So do you think it's like genetic sex determination or it's maybe temperature related or is that known at all? Maybe someone in the audience?
I have no idea. Probably, I think it's related to the invasion because there is a lot of information related not for Crespida costa but the other species that the invasion occurred by the polyp. The polyp is is female or male, and probably that occurs in Brazil. Only the female polyps appears there, and so the all specimens is female. In every record from Brazil, when we have the data, all the data are female. So up to now, so probably it's the same. I don't know.
Okay, thank you. Is there any other question? No. Okay. Thank you,
Thank you so
for
much.
taking us from marine to freshwater. We have the next presentation coming up.
So now we have Hankumar Sugumar to talk about cubozoan blooms in interaction with commercial fish production activity along the coastal region of Balghat district, Maharashtra, Northern Arabian Sea, India. Please.
So very good afternoon to all. Today I am going to discuss the cubozoan blooms, how it is interacting with the commercial fish production activity. It will include both capture side as well as the culture forms also. During 2022-23 years, we came across these two blooms in different locality in same districts. So it is eastern part of Arabian Sea and it is northwest coast of India, mainly the Maharashtra state. This coastal line is almost 720 kilometers and this particular Palghar district is contributing almost 20% of the total marine fish productions of that state. So it is very important to work on these blooms. So main fisheries operating in this region is dole net fishery. It is a tide influenced the bag net fishery. It is mostly they are targeting the high valued fishes, mainly bag pomfret, silver pomfret, pinnate or non-pinnate shrimps. So this dole net fishery is contributing almost $47 million to this Maharashtra state. So this cubozoan blooms are having major impact on their fishery, commercial fishery ground. So through questionnaires, we have almost interviewed the fishermen from the experience of 5 years to 40 years experienced fishermen of different age groups. So we have first asked the fishermen whether this species, by showing some of the photos, to confirm whether this species is cubozoans or scyphozoans. Then later we have enquired what kind of the impacts. First one is fishery closure. So in a month, they are going to the sea for 26 days. Almost in a year, 8 months, they are going into the sea. Based on that, so due to this, cubozoan blooms, mainly box jellyfish, Chiropsides butangi. So 12% of the fishing days is going absent due to the heavy blooms, and fish net clogging almost covering 24.6%, and 40% of the fishing gear was getting damaged due to releasing these blooms back to the waters. And peak seasons we have observed is to April to May and September to November. So we have intuited that what is that bloom, whether this bloom is almost lost 30-40 years, whether this bloom is already there in that same fishing ground, or whether it is increasing over the period or decreasing over the period. So we came across that some of the fishers, they agreed that every year it is increasing 42% and decreasing 18% of people are, fishermen said it is decreasing, and some of the fishers, they said there is no change in the bloom. Every year we are observing this bloom during these peak seasons. So these are the species, Chiropsides butangi. So in commercially valid species, during the catch, apart from that fishery closure, almost 45 to 68% of the catch belongs to the fishes, and butangi is covering 30 to 54% of the whole catch is contributed by butangi. Due to these things, they are facing very difficult in sorting the fishes and prawns during the encounter. Due to that, they are forced to discard the fish biomass back to the sea, almost at the rate of 12.56 to 18.96 kilogram per hour. So we have estimated the bloom biomass based on this map showing the green and blue colors. These are the commercial fishing ground. So in that fishing ground, almost 200 to 300 fishing nets of dole net is operating at the same time. During that period, so per square kilometers, how many fishing nets has been operated. With the help of fishermen, we have given the log books. Due to the log books, we got the points, lat-long points, and particular lat-long points, how many fishing nets, how many numbers of fishing nets they are operating. Based on that, they will soak the net for 4 hours. After 4 hours, they will haul. So in that 4 hours, how much net in that net, how much jellyfish biomass they are getting. So based on that, we have raised the value, and we have estimated that almost 1,300 kilogram per kilometer square to in yellow region. In blue regions, we got 652 during the peak fishing season. Next one, another interaction is its semi-intensive shrimp farm, where we came across the cubozoan. Another one is mangrove box jellyfish, Tripedalia cystophora. So this main blooming season is during October to December, and due to that bloom, that Pineus vanami farmers cannot able to stock their seeds. Once they are stocking the seeds, immediately the seeds are dying, so they have stopped the seeds. Due to that, 3 stocking cycles of each cycles 80 days, they couldn't able to stock last year. That main intake is to Vaitarna Creek, where the bloom from the sea it's entering to the fish farms. So these are the maps. The red dots are showing that commercial shrimp farms, where these farms have got these blooms of Tripedalia cystophora. So how it is entered? So immediately after the southwest monsoon, that the sea salinity is less than 25 ppt. During that time, this Tripedalia cystophora bloom is it's blooming, and the main thing is immediately after the southwest monsoon, the rainwater runoff, that coastwater is heavily loaded with nutrients, and plus maybe because of that particular fishing ground is more of pinnate shrimps. So due to that, more larvae and high nutrients, it may, and immediately after the monsoon, the temperature also increasing from 25 to 30 degree in sea surface temperature. Due to that, it's triggering that bloom, and bloom is entering through the creek. So from the creek, it's entering into the shrimp farms. So this is the species, Tripellia cystopora. We have done the samplings. This is a semi-intensive aquaculture farms where they are not following any water filtration system, proper water filtration systems. So we have done the samplings, and we have given some advice to the farmers. So you go for proper water filtration systems and chlorinations for the water intake tanks, and make the inlet pipe treated with, if it is possible, you make the treatment with chlorination. Otherwise, you can remove the inlet pipe, go for the new one. And sluice gate should be properly guarded with the proper mesh size, so that we can restrict that the bloom larval to enter into the commercial pond systems. We ask them to go for ploughing the bottom, and each and every time after every cycle, and sun drying is we have recommended for every cycle. So thank you. These are other gelatinous blooms we have come across those areas in Maharashtra coast. Thank you.
So thank you. Some questions? Yeah.
Hi, that was a very interesting talk.
Yeah.
What depth are the fishermen pulling up the nets from?
Yeah, they are operating from 10 meter to 40 meter depth. 10 meter to 40.
And the jellyfish, so the cubozoans they're finding, are on the bottom? They're pulling up from the bottom? Or
No, it is 1 meter above the surf, from the bottom. And after the bloom, the jellyfish coming to the surface. So it is the tide influenced bagnet fishery. So due to that high tide time, it is automatically entering into the nets.
Okay,
So it is spread across the water column.
Okay, thank you.
Thanks a lot for this nice talk. I was wondering, in the survey you mentioned that most fishermen actually complained that it causes a damage in the fishing gear. What kind of damage is this?
So damage, first thing is, once their fish net is clogged with the jellyfish, they are forced to cut down their cordon. So they have to cut. After that, some of the times while they are hauling the net itself, it is get busting. So these kind of damages, they are often they are getting these two damages.
Thank you very much. Thank you.
Yeah, thank you.
Sorry, we'll have one. We'll have one more.
Yes.
Thank you, Ramkumar, for the good presentation. My query is, like, generally when they go for coastal aquaculture activities for the Vename, they will have secure systems by which they allow the water in, and how the jellyfish happens to go in such bulk quantity into the farming systems?
Sir, actually in that area, they are not using any water filtration system. They are giving feeding to the streams, stocking streams. So, but there is no as such mesh size. Mesh size, that what they are using is more than 400 micron size. So in the sluice gate, and more due to the heavy current, it is get turned out also some of the times. So most of the times, and the same inlet water inlet pipe is acting as a outlet also. Due to the gravitational force, they are releasing the water back. So main thing is the poor management in water filtration systems, and let the inlet pipe filtration gate. That is the main thing. So other than they are giving the feeding other things. That is the things. This last year only, first time they have noticed these blooms. So now we have given some advice. Now they have started looking into some of the management practices they have started. So it's what we have recommended.
Thank you. Best of luck. Thank you.
Thank you. Thank you very much. So now we are coming to the last presentation of this session. Is Miriam Paul Schreeman. She will talk about stakeholders' perception on jellyfish blooms and effects on marine fisheries in Kerala State, India.
Hello.
I'm Miriam Paul Sriram. I work for the ICR Central Marine Fishery Research Institute. My colleagues and I took up a very basic survey for understanding human jellyfish interactions, basic engagement in identifying the issues affecting about 191,000 marine fishers seasonally. They have encountered these problems year after year. And so this is it? Yeah. Okay, thank you. Well, the target responders were marine fisheries stakeholders, from active fishers to vendors. They have a consummate experience in encountering and dealing with jellyfish. The perception analysis was performed on data obtained through a structured interview-based survey of approximately 360 respondents, about 60 stakeholders from each of the 6 maritime districts of northern, central, and southern Kerala. These were Malappuram, Thrissur, Ernakulam, Alappuzha, Kollam, and Thiruvananthapuram district. And the methods used was a weighted questionnaire. We drew inspiration from the works of Reed et al. 2009 and Ackerman and Eden 2011. And for designing a questionnaire with objective and subjective questions on jellyfish blooms and its deleterious effects on fisher livelihood, perceptions were noted on the diversity, seasonality, intensity of swarms, disruption of fishery, spoilage of catch, avoidance of swarms, reasons for proliferation, intensity of jellyfish stings, and remedies which were gathered. Now, I will go on to the exact details of the questions that were asked. We asked 6 questions on negative impacts created by jellyfish swarms on fishing. The first was, is it required to travel further for fishing on increased number of hauls due to jellyfish swarming? The answers were rated from an absolute no to a positive response. And the answer for this question was mostly sometimes, and also towards the more in agreement with the question. The second question asked was, is time taken to sort fishes affected by jellyfish not increasing, or a small increase, or large increase? Again, the answer was sometimes. But the most encountered answer was sometimes. And also, many fishers responded positively to this question, that there is a large increase in the time taken. Do jellyfish affect the quantity of fish caught? The options were not decreasing, or slightly lower, or slightly, largely decreasing. And again, here the answers were ranging from sometimes to a large decrease. How often are the nets clogged by jellyfishes? Like Ramkumar had just said, this is one of the major problems encountered with fishers. Here the answer was a very strong affirmation. Yes, the nets are clogged by jellyfishes. Do jellyfish interrupt fishing? The answer again was temporarily yes, and sometimes to a greater extent. How severe is the pain due to the sting of the jellyfishes? Here it is very interesting. The people mostly answered that it is just a mild problem, but some definitely said that there is a strong problem. Perceptions on jellyfish blooms. These questions, we asked 5 questions. Well, how does climate change affect the jellyfish blooms? Did they have any understanding of that? We asked whether increased temperature in seawater, which accompanies increasing atmospheric temperature, was causing increased or decreased jellyfish blooms. The answer is that they understood that yes, there is a strong increase in jellyfish blooms as accompanying the global warming phenomena. We also asked the increase of habitats. Do they know about the increased habitats by building seawalls in coastal areas, whether the polyp phase or jellyfish get space to hold on to and multiply. And the answer that we got from them was they had no proper understanding of this particular phenomenon. So the answers were mostly no. We asked if they knew about jellyfishes being invasive species brought in mainly through shipping. Again, the answer, they did not know about this. The answer was no, mostly. We asked about increased nutrients in the sea, the large-scale exposure of nutrients from land to the sea, which results in increase in the number of phytoplankton, and thereby a number of increase in jellyfishes. Here, they did have some knowledge about this phenomenon. They did understand that increased nutrients do increase phytoplankton and thereby increasing the jellyfish in the sea. We also asked if overfishing can lead to a shortage of fish that feed on jellyfish and a decrease in the predators in the food chain. Here again, they had quite an understanding of what the ecosystem that they fish in. They did say that the answers were mostly sometimes yes, and ranged also to positively yes. Now we asked for solutions on their problems. First, we asked if some kind of treatment is required for jellyfish stings. And here we found that most of them consider jellyfish stings as something that is which they can deal with easily. They did not really ask for go in for hospitalization or seek medical attention for their jellyfish stings when they occur. We also asked, can the harm caused by jellyfishes avoided by adopting special fishing methods? The resounding answer was no, there is no solution to this particular problem. So I'll summarize the results. The negative impacts of blooms on fishing. Traveling time and net hauls can obviously be increased, have obviously increased. That is 50% opined sometimes, and 39.3% said it is something normal. Catch sorting time, definite increase, 60.3% said there's a large increase. Decreased fish catches, 38.3% said there's a slight dent in fish catches, whereas 53% said there's a large decrease. Clogging of nets, they said is quite normal. 70.67% said yes. Fishing interruption during swarming, 41% said temporarily, and 55% said completely. Jellyfish sting during operations, minor inconvenience is what people said, but some did say, 51.6% did say there is severe problems caused by jellyfish stinging. Perception of causes, climate change, major cause which is understood. Overfishing is not fully able to connect to the phenomenon. Coastal underwater artificial structures, limited understanding of jellyfish cycles. Increased nutrients, some basic awareness of pollution is there, therefore they were able to identify this. Innovation through shipping, limited knowledge on such aspects. What did we gain from asking these questions to them? 99% said there is no need for special medical attention. They instead rely on self-treatment using kerosene oil, cooking oil, seawater, or mud. 91.67% believes that there is no solution to this to the harm that is caused by recurrent swarms. That is, there is no special fishing method that can be adopted. There is a general consensus among fishers that although various species are distributed throughout the region year-round, swarming usually occurs during after the second monsoon and going on increasing till the intensity of the summer as the summer proceeds. Blooms generally normally have the arrival of are at the arrival of the summer monsoon time. Cyanea, Lycorrhiza, Netrosoma, Chrysora, Crabionella, Acrometus, and comb jellies are the main swarming species in the surveyed areas. Finally, we come to the conclusion that we do need awareness campaigns to spread the word among the fishers. That in Kerala, the vernacular term used for jellyfishes is chori, which means irritation or scratching. So the fishers do have a rather negative perspective of jellyfishes. It's only from 2013 onwards when the one particular species, Craminella orsini, started being harvested for edible purposes and exported, did the jellyfish, did the fishermen actually perceive a positive perspective to jellyfishes? So what is the way forward that we are planning on? Just a moment. Comparison of pre and post perceptions after holding awareness campaigns. We also have gear-wise and district-wise data which we will assess further. This is only a very preliminary analysis of the data we have. And we will attempt to find solutions using indigenous technical knowledge and current science. Thank you.
Thank you, Miriam. I have time for only one question. No? Here? Only one question?
Thank you for your presentation. My question is related to the possible positive impact, your last words. There were in your questionnaire no answers, open answers about positive solutions such as exploitation of jellyfish. Do you think to make something to increase the awareness about people about the real exploitation at the local level of the local jellyfish that blooming in India?
Well, the perceptions that we were asking for was, would the fishermen be able to find out any kind of a solution, a fishing method by which they can reduce the quantum of jellyfish caught or something like that. But they said, most of them said that the answer is no. They were not very positive about finding solutions. But we did encounter one or two fishers who did say something about agitating nets and squeezing the nets in between and allowing the jellyfish to float on top. And that was a response from a very small group of fishers. Perhaps if we can spread awareness and ask them itself for solutions and sort of point them in a direction that there can be solutions, maybe they can come up with answers. We don't know. We'll have to find out. So we will have, somebody had said, somebody had presented on polyp management. Maybe we can think of such things in future to be implemented in India also. Thank you.
Thank you very much, Miriam. Thank you very much for everyone. Now we are closing our session, and now we're moving to session 2.
Thank you, Sergio, Grinson, and Rafi, and hello, please. It's a time to honor the chair and co-chair. Yeah, it's a time to honor chair and co-chairs. I invite Dr. Vijayakumar to honor them.
Thank you. All right, so I'd like to welcome Angel Yanagihara as the chair for the next session, and also to welcome Miriam Paul Sriram as a co-chair, and Kurian Matthew Abraham as our rapporteur. Please come up to the stage. So our next session is bioinspiration and then venomation, and I'll hand over to Angel to run the session.
Thank you very much, Mike. We have lost a few speakers on this session. Unfortunately, they are not able to travel, but I'll kick off the session with cubozoan and venomation mechanisms, models, and management. And I appreciate the opportunity to present. Thank you to the organizers. This is a topic near and dear to my heart. I've spent pretty much most of the last 26 years studying cubozoan envenomations. These present a serious medical urgency and can result in deaths, principally in areas of the Indo-Pacific. Cubozoa comprise over 40 species, and there are two extremely medically relevant families. Shown here are chirodropid, the larger animal with the 4 corners and up to 15 tentacles per side, Perpedalia, and the Alatina alata, which is a species we have in Hawaii. Shown in the center is a child that survived being stung, and this is in shallow nearshore waters, so it is a serious health burden for folks in principally in the Philippines, but other parts of the Indo-Pacific as well. If you can start the video, please. Sir? Yes. So this is a time-lapse microscopy movie showing what happens to whole, freshly drawn whole human blood. And what one sees here are obviously the red blood cells, but in the center are platelets and then a few white blood cells. So over the course of just a few moments, what you saw was that normal healthy cells, red blood cells became crenulated, then they swelled, and some became ghosts. At that point, you have loss of hemoglobin or hemolysis. At the same time, the platelets also aggregated and become swollen and ruptured, and the white blood cells became activated. When I started this work, the pet hypothesis in the field was that there was a silver bullet ion channel that was to blame for the deaths. So as a biochemist, I went about to look at the venom, and as we do, using HPLC, I separated according to size, and then I took each of the fractions and looked to see what kind of phenomenology would occur. What we saw, as with the previous movie, was that there was one fraction in particular, the small fraction that you can see about D2, and I don't know if I have a pointer, right after the main first peak, would comprise the rapid death as well as the hemolysis that you just saw in the movie. So I proceeded then to look at a number of different cubozoa venoms and found the same phenomenology. So I decided to focus in on that and look at the mechanism of action and pathophysiology to see if that could explain these serious injuries, including acute cardiovascular collapse and what is called Irukandji syndrome, which is another life-threatening sequelae. Looking then at just the small 42 kilodalton peak, which I don't have a pointer, so it's frustrating me, that in it of itself was able to recapitulate what I just mentioned to you about the time course to death in a mouse. Sorry. There we go. Okay. Okay, so that peak in and of itself was able to recapitulate the entire phenomenology. So what we did was to treat red blood cells and to do negative staining, and what one sees on the surface is something very similar to streptolysin O and bacterial porins, in that there is a monomer that can self-assemble and form a stable rivet-like pore in the surface of a cell. And in this case, a red blood cell, but it is a promiscuous porin and can bind to the surface of numerous cells. When one does the injection of the full venom from various cubozoa or the isolated porin, I was surprised to see that there is a conserved mechanism of action, and this basically what happens to the animal is you have a loss of ventricular contraction. So these are time series Doppler readings of the heart muscle itself. At the same time, with copper leads, you can measure the electrical conductivity system of the heart. We see that the conductivity system is spared, but the heart muscle stops to contract. This is classical, what's called hyperkalemia, and that is an increase of the plasma potassium. And I won't quiz you on this, but if you remember the Nernst equation, basically if you have a higher level of potassium in the blood plasma, the cardiomyocytes can no longer beat. The good news is that this is reversible. So it isn't a toxin-directed toxicity of the myocardium. It's a transient loss of the ability to beat because of a transient elevation of potassium. And in fact, that hypothesis was borne out with subsequent work, which is beyond the scope of this quick 12-minute overview talk today, but I'm happy to chat with people about more in the details. But what we found then over the course of these 2 decades is that this conserved mechanism of pathophysiology is found again and again amongst various members of the Cubozoa family that we've looked at, both chirodropids and cryptids. So if one looks basically at this porin binding to membranes, forming these pores, immediately one can have the loss of potassium and then subsequently hemoglobin. At the same time, this can happen in white blood cells to lose histamine and cytokines, and platelets to lose cytokines and catecholamine. So I will show in the next few slides basically a conserved mechanism of pathophysiology that really goes to explain both the acute cardiovascular collapse and various chirodropid stings, as well as the slower, less venom dose Irukandji outcome. But to just take a moment now and to consider what we've found with regard to this porin, it is a monomer that must self-assemble as a ring of pearls, if you will, in order to form this rivet-like pore on the surface of the red blood cell. And interestingly, as I mentioned before, this is very similar to anthrolysine O and streptolysine O, bacterial approaches to toxicity. In terms of the kinetic sequence, though, what one has at the beginning, though, before the loss of hemoglobin in the form of a ghost, the ghost cell formation, is the immediate loss of the small ion potassium. And because red blood cells have about 120 millimolar potassium within them, the lysis of a few, just a certain portion of the red blood cells in the body is enough to tip the plasma potassium level over 5 millimolar potassium, which sends you into what's called pulseless electrical activity. Now, what we found is that this is a temperature-dependent phenomenon, and so that if one treats this venom or the purified porin in various conditions, there are different outcomes. So at 37 degrees, you have functional pores being formed rather rapidly, whereas at 45 degrees, 45-minute pre-treatment, one does not see this formation of active pores and very low amounts of hemolysis. That's not the same as complete denaturation, which would be 100 degrees with detergent and SDS. So these data basically show that, and this is published. But interestingly, when you talk about the toxicity of the venom, the HU50, the amount concentration of the venom required to lyse 50% of the red blood cells, you see that it becomes more potent or left shifted at cooler temperatures. And this has been borne out time and time again, which is a big warning I want to give in terms of the first aid management about ice that I will return to later in the talk. Whereas, in contrast, exposure to heat, even skin-safe, rather hot but still tolerable, 42 to 45 degrees centigrade, renders the venom less toxic, and higher doses are required to cause hemolysis. More interestingly, once the full sequence of the porin was determined by Nagai et al., we found that there was a calcium binding domain. So we thought that perhaps one could interrupt this by competitive inhibition using divalent cations. And I went through a whole series of those and found that in fact, copper gluconate at very low concentrations and zinc at higher concentrations could do this in the absence of heat. So this became the basis of a now fully granted US patent, and this product line, this work was all funded by the US military because there were career-ending stings amongst combat divers because of various cubozoan envenomations. So this has now been in use and is publicly available for 8 years. To review then the mechanism of pathophysiology, if you will, is this fast highway at higher venom doses. So basically, stings by chirodropids with larger mastigophores, larger tentacles can rapidly result in this amount of porin into the body, which quickly leads you to the pulse's electrical activity and death. Smaller venom doses, even by chirodropids, can lead to catecholamine surge and cytokine storm, which I don't have time to get into the weeds on this, but happy to chat with people in depth if you're interested. And there's more to the story than the porin. These venoms also contain metalloproteinases, lipases, and small molecules. And I'm currently doing constellation pharmacology with Toto Oliveira's lab, and we're looking at the peptides in the small molecule of portions of these venoms. And there, if we look at lumpers versus splitter kind of point of view with regard to the biochemistry, is quite a different story in the small molecules, but they both share this very potent pore-forming protein, the porins. Okay, so kind of going quickly again, in terms of envenomation management, one wants evidence-based management tools. And so in order to do that, of course, models are very important. One of the areas of current controversy in the field is the first aid application of vinegar. So I'm going to discuss that in a minute. But we've also looked at various biochemical based assays to look at hemolytic assays. We've kind of discussed that already, and I've shown you the mouse pathophysiology, but we've looked now at inhibitors and various first aids approaches with regard to ultimately in a piglet, anesthetized piglet time course assay. So just a quick moment, and happy to chat with people further a little more leisure, but vinegar. So published papers have shown that intact tentacles from Scyphozoa, when exposed to vinegar, can have discharge. And folks have extrapolated that to say, well, therefore, the vinegar cannot be a good first aid. The problem with that is that unlike chirodropids, in which, in fact, folks, victims do exit the water with tentacles adherent to the skin, Scyphozoa are delicate tentacles that quickly fall away. And so what's left on the skin are actually undischarged nidae. And so when you do the experiment with undischarged nidae that no longer have afferent, efferent innervation from the tentacle itself and the sensory systems, it's a very different outcome. So with regard to exposure to water after vinegar, there is no rupture, even from Scyphozoa nidae, whereas exposure to saline, which folks are now promulgating as a first aid rather than vinegar, out of the fear that vinegar will cause rupture, these nidae are still competent to sting. And I have to go quickly, so I'm just going to kind of show some of the work and happy to discuss it later. But basically, it's not over when it's over, so until it's over. So at 1 hour after the treatment, ice looks good in the first hour if you do 45-minute ice pack. But at 15 hours, this red is no treatment. Ice is far worse versus heat. So hot temperature is a far better first aid. So we also have done pig skin assays, applying live whole tentacles from chirodropids, and you can see with the naked eye the damage. And then this technology that's based on the copper gluconate is a game changer. In anesthetized piglets, we've done the same work, applying the tentacles and then looking at various approaches. And so here's your vinegar rinse with a hot water pack, so it's better than the control. Saline with ice is far worse than the control. Vinegar rinse alone is insufficient. Saline is also insufficient and makes things worse versus the copper gluconate technology. So to prevent further venom injection from undischarged nidate firing and to inhibit activity, here's a paper that's published, and happy to chat with you further about that. And just quickly, in terms of the big picture, I do a lot of work in the Philippines, Indonesia, and other places in which we do a collaborative effort. Ask the question, where are these problems occurring? What's the field ecology? And then the biochemistry, and then the evidence-based care. So I see the Jellyfish Blooms Conference as a unique opportunity to gather the stakeholders together from all these different areas. Thank you for your attention.
Can we have a quick question for her? Jill?
Angel, thank you so much. That was so fascinating. Hi, it's me. I'm over here.
Where are you? Oh, there. Okay.
So first of all, I mean, you know I'm a huge fan of your work, and that was just wonderful. And I was wondering, for people who've already been stung and are experiencing cardiac distress, are the traditional treatments for hyperkalemia, which I think is calcium gluconate, are those effective? Is that known? Intravenous administration of treatments after a severe sting and in the event of cardiac distress?
Well, actually, lives have been saved in the Philippines by just application of CPR and rescue breaths. So the kidney itself can clear out the plasma potassium, and this is a very different presentation than dialysis type of, lack of dialysis type of hyperkalemia. Any other questions? I promised Mike I would not go overtime, so I better not break my promise. Thank you very much for your attention, and I'd like now to introduce our next speaker, Vasudevan Shankar, and will give us a talk on dynamics of jellyfish swarms, unraveling the intricate influence of coastal ocean parameters in the southeastern Arabian Sea. Thank you.
It's a big screen. Okay. Yeah. Yeah, thank you, ma'am. Okay. Good morning, everybody. First of all, thank you. And today we are looking at dynamic of jellyfish swarms and unraveling the intricate influence of coastal ocean parameter in southeastern Arabian Sea. So as we know, what is the background of this basic jellyfish from polyps to medusa. So it was lived in millions of years ago, and its life cycles, sexual and asexual stages, and we can able to see wherever in the oceans from it is a sorry. Okay, and this is a major drastic for our fisheries and tourism, and even and other vice versa. So this is the aim of the investigation. Sorry, I'm not on a biology background, so that's why I'm just a little bit struggle for telling these things. And aim of the investigation is to unraveling the intricate influence of coastal ocean parameter in the southeastern Arabian Sea. So this is my study area, and which is located in eastern Arabian Sea in Cochin, Kerala, west coast of India. And so we are onboard survey were monitored multi-dated over 2018 and 2019 period. And what are the parameters we are studied means which is temperature, salinity, surface current, and meridional wind component, and other phenomena of upwelling and downwelling we can study. And this is a methodology, basic methodology. The data occurred from HICOM model output. So, and correlate with that jellyfish catching data, and relationship between the bloom and temperature and salinity, and how the Ekman pumping was Ekman pumping associated wind stress influenced during upwelling and downwelling phenomena, and time series of temperature, salinity, surface current, and influence in the bloom dynamics. And this is a thing, just I am telling, first figure, red color shows the jellyfish catching in multi-dated period over 2018 and 2019. And this is a spring inter monsoon 2018, and this is summer monsoon, southwest and northeast monsoon. This is 2019, summer southwest and northeast monsoon. And red color shows the jellyfish catching, and this one shows the wind stress parameters, and B which shows meridional wind component, and D sea level anomaly. This is sea level anomaly, and sea surface salinity, and Ekman pumping, and Ekman transport, wind stress curl, and finally SST. So how these parameters influenced in this correlate in jellyfish catching during the days. In spring inter monsoon we cannot get any jellyfish catching, and even summer monsoon and northeast monsoon we can see the peak. So these days, particularly in bloom jellyfish bloom, in blue color shadow mark zone, it shows in the 2018 Kerala flood season. During the time, it was in more upwelling period. This period, but this is downwelling during downwelling in northeast monsoon, and upwelling and downwelling is the more influenced in bloom dynamics. And this wind stress is the positive and negative values. Positive wind stress and negative wind stress, what is that means in coming to the following slide, I will tell you elaborately. And this is the this is meridional wind component. Positive value means upward direction is the positive, and negative is the downward direction. So upward is the northward movement. It is negative value means which represent the southward movement of the wind current. And sea surface salinity. So this is sea level anomaly. So sea level anomaly, positive value and a negative value. Positive value normally happen, the water push toward the offshore, push towards the sea means the water level increased, and the level decreased means it shows to the upwelling signal. So these particular places showing in upwelling. And D is the sea surface salinity. Salinity wherever the bloom, so that time we can able to see the decreased trend. The salinity decreased during the time of bloom dynamics. And Ekman pump. This is Ekman pumping. So Ekman pumping, positive and negative. So Ekman pumping is nothing but it is a push the water towards downside and upward directions. So negative Ekman negative pumping. So always in the ocean, jellyfish bloom was more intensity during the time in wherever we can get negative pumping. And Ekman transport EF. So this is Ekman transport. So sorry for the interrupts. And Ekman transport, it shows a zero symmetrical line. So a little bit up positive Ekman transport shows the more catching of the catching time. So it is a symmetrical line. So negative, it was in particularly in the flood time, it was shows negative. So let me come to the following slides. What are the recent beginnings? And this H. This is a chlorophyll. This is chlorophyll concentration during the period. So chlorophyll not that much concentration the bloom dynamics, and wind stress curl. So negative wherever the bloom catching, so that where we have to see negative values of the wind stress curl. So these parameters how we influenced in this dynamics. So these are things. So positive wind stress lead to upwelling period. So where the wind pushes surface water, allowing nutrient-rich water comes from the beneath to surface. This nutrient enrichment promote the growth of phytoplanktons and source for the jellyfish. And this positive influence ocean current aiding to the transport of both jellyfish and their prey. This can lead to the aggregation of jellyfish in specific areas, contributing to the formation of blooms. At the same time, negative wind stress associated. So here we can see the negative wind stress. This negative wind stress is associated with the condition that typically suppress upwelling. So this time naturally reduced nutrient supply, so lead to decrease the nutrient availability and may impact the productivity of the marine ecosystem in this region. And northward movement of wind may influence surface current, transporting jellyfish and the prey to the specific region. This transport along the positive wind stress induced upwelling can lead to aggregation of jellyfish, contributing to the bloom formations. Upwelling associated with the negative sea level anomaly. So I already told that negative sea level anomaly and favorable wind condition so lead to upward movement of the nutrient-rich water from deep water to surface. That decreasing trend of salinity combined with other favorable environmental condition may contribute to the proliferation of jellyfish by creating suitable condition for the growth and reproduction. The jellyfish blooms are observed during a period of negative wind stress curl. It suggests a unique environment condition that favor further proliferation. And this is the temperature and temperature, salinity and density longitudinal plot of vertical variation. And these two for the non-catching time. A part of other time is completely catching during the time of jellyfish catching. So it was an upwelling signal. Thus, the thermocline layer, it was shows towards the uplift of the directions in coastal areas. So this shows to the upwelling signal in that particular time. When the time of we can catching more. So that time it was an upwelling signal in 2018. So in this signal, so it was the same signal shows in that way, but here we can get more jellyfish catching due to the downwelling time. So the signal shows all the things. And here in salinity, the same, here the low salinity were not mixing, that much mixing. So here we can able to see the stratification, some more mixing zone in that particular catching areas. And other areas, it was less mixed depth area. Waters was not that much mixed, so mixing was mixed very less. The same situation we can seen in the happen in 2019 also. So that is the time during more pronounced jellyfish catching. And this whether due to the factor upwelling or reverse discharge, it can influence the distribution of abundance jellyfish. Some species are more tolerant in varying salinities, while others are more sensitive. So in particularly in Cochin coast is located in Cochin backwater, so it was more influenced from the river discharges. And this time negative Ekman pumping can contribute to water column stratification. So that we can see in this figure in the stratification levels. And where surface water becomes less mixed with the deeper waters. This stratification may influence the vertical movement of jellyfish, allow them to stay within a specific depth ranges that are conducive to their feeding and reproductive behaviors. And as we know, the Ekman pumping, what is that? Vertical movement of water caused wind-induced Ekman transport, which is net movement of surface water towards the 90-degree direction, right angle to the wind directions. Offshore transport. This wind caused surface water to move away from the coast, creating a horizontal transport known as Ekman transport. This transport lead to the deficit of water near the coast, contributing low level of sea level. And upwelling dynamics. As the surface water moves offshore, nutrient-rich water comes below to replace in the surface. This process enhances vertical mixing and nutrient supply in the upper layer, benefiting marine ecosystems. And offshore movement of water results in a temporary decrease in sea level near the coast. This negative sea level anomaly reflects the physical displacement of water away from the shoreline during upwelling time. So during the time upwelling, it was suppressed upwelling, upwelling. So our parameters positive Ekman pumping tend to suppress upwelling, and also negative wind stress associated with the condition that typically suppressed confirm that upwelling. Leading to reduced nutrient availability and in surface water. This can lead to decrease in nutrient availability near the surface and may impact the productivity of marine ecosystem in this region. And this is this plot shows represent the surface current, and red color shows the northward movement, and green and other blue color shows in southward movement of the surface current. So upwelling is associated with offshore surface current. Wind that drive upwelling causes surface water moves away from the coast, leading to upward movement of colder and into its deep layer. As a result, there is a typically offshore transport of the surface water. So during upwelling, offshore transport of water can create temporary decrease in sea level near the coast, resulting negative sea level anomaly. So by the time only we can get in southwest summer monsoon, particularly jellyfish intensity is jellyfish bloom, but intensity is very less. But rest of the northeast monsoon during downwelling, intensity is more in the bloom period. So while upwelling is generally associated with the negative sea level anomaly due to offshore surface currents. And come to the summary of findings. What in a positive Ekman pumping occurs when the wind blows same directions as the movement of surface water, as we know, then a 90-degree angle of the wind directions. So the positive Ekman pumping while the wind is blowing southerly directions. This means that the wind is causing surface water to move from north to south. The resulting vertical movement water is upward. This upward movement can contribute to lift nutrient-rich water, which is associated with the process such as upwelling. But this has enhanced nutrients. But negative wind stress is associated with the condition that normally suppress upwelling, leading to reduced nutrient availability in surface water. This can this can affect the productivity of marine ecosystem. At the same time, in northeast monsoon, negative Ekman pumping is northerly wind, which means move surface water from south to north directions. So it is negative Ekman pumping is accompanied with the positive sea level anomaly. It indicates the combination of factors causing a temporary sea level rise near the coast. A positive level anomaly can result in the accumulation of water due to factors such as convergence of surface current. This condition is associated with the suppression of upwelling, resulting in low nutrient level. This also affects the productivity of marine ecosystem in this region. So both that phenomena, upwelling and downwelling, seen in the nutrient level deficit the nutrient level. So when the time of nutrient deficit, the jellyfish can come to the surface water. So in let me compare to that southeast monsoon, the nutrient deficit is low because of suppressor of upwelling. By the time jellyfish bloom happen, but intensity is low. But at the same time, intensity is more in northeast monsoon, completely nutrient deficit time. So it can come to the when the time of means we can able to see that period. Nutrient deficit time now. So by the time only the bloom has happened by our thank you.
Thank you very much. Thank you for that nice talk. Any questions? Okay, if not, we'll move to the last talk before lunchtime. Thank you very much once again. We will hear from Krishan Karunathurne, sorry about that, jellyfish fishery in Sri Lanka.
Good afternoon, ladies and gentlemen. I am Krishan Karunathurne from the Department of Aquaculture and Fisheries, Vayamba University of Sri Lanka. Let me to present about jellyfish fishery in Sri Lanka. Most of the Asian people know, but other people perhaps don't know what is Sri Lanka and where is situated. It's a tropical country, island, situated nearby the southern tip of India. Two major monsoons affect that one, and the northeast coast is affected by northeast monsoon during December to February, and southwest monsoon affects the southwest coast during May to September. We don't have a delicacy for jellyfish in Sri Lanka. Therefore, in Sri Lanka, value of jellyfish is 0 or negative value, negative because of the hazardous nature. Due to exportation value, we have identified a good potential considering a high valuable group of species. Jellyfish fishery is considered as an extra opportunity to support the livelihood fishermen, making the value for bycatch species. So far, there is no any study has been conducted on jellyfish fishery in Sri Lanka. As we found in a separate study, there are 2 species which are exported from Sri Lanka. One is Crambiorella orsini, and another one is Labdomyrus gracilis. Crambiorella orsini is exported from the south east coast, and the Labdomyrus gracilis is exported from the north west coast. As there is no study on jellyfish fishery in Sri Lanka, so we have attempted to conduct a questionnaire-based survey from 2016 to 2020, and sample frame used to collect cost and return data from 2 coast areas of Sri Lanka is like this. And furthermore, we collected some production data and export data from Sri Lankan customs with the permission. Results. So firstly, we have identified the locations where the temporary processing plants activated along the Sri Lankan coastline during the last 2 decades. The Kirinda and Puttalam areas are the places where jellyfish processing plants were active in abundantly. A ball-type jellyfish fishery is a group activity with mechanized boats in the sea of the southeast coast, while the white-type jellyfish fishery is done by individual fishers by using non-mechanized boats in lagoons located along the northwest coast. In both of the cases, scoop nets are used to catch these jellyfishes. We can identify 5 key steps in processing. So bills and oral arms of both the species are separated and washed, processed in separate tanks, and they are sorted. The 5 major steps are cleaning, first curing, second curing, sorting and packaging. However, within the steps, there are some variations among these 2 species. As you can see this graph, the Crambiorella production has been carried out in 2007, 8, 10, and 17. The highest production was reported in 2018, which was about 1,200 tons, and the least was about 50 tons in 2010. The major markets for Crambiorella of Sri Lanka is Vietnam, China, Thailand, Taiwan, Maldives, and India. As you see in this graph, the production of Labdomyrus gracilis has been done in 2008, 11, 15, and 2017. The highest production was reported in 2011, and the least was in 2008, which was around 11 tons. And the markets for Sri Lankan lobotomyrmetis gracilis is Taiwan, Vietnam, and Singapore. You can see the flow of jellyfish products, imports, and supporting services among the key stakeholders of jellyfish value chain in Sri Lanka. There are two paths from fisherman to the buyer. The first one is from fisherman to processor directly. The second one is from fisherman to processor through an intermediary collector. In most of the cases, the intermediary collector involves a value chain. Fishermen harvest jellyfish and deliver them to intermediary collectors within 2 to 5 hours. Intermediary collectors receive them and wash them and deliver to processors. They are the exporters as well, to processors within an hour, and the processors receive them, process, package, deliver to the international market within 7 to 30 days. Here you can see the cost and returns per kilogram of jellyfish through the supply chain of Sri Lankan jellyfish fishing industry. Here the production is also mentioned for two species. Capital A and B are respectively arms and bales. Here TC is total cost, GR gross revenue, and NI the net income. So however, I'm not going to explain this one further in detail. Not only pros, but there are also cons in this industry. Some are regular health issues can be observed in jellyfish handlers, and they damage to mangrove cover to build jellyfish processing plants, and breeding sites are provided for mosquitoes by the abandoned jellyfish processing tanks on the beach, and some broken tanks can make the shoals unpleasant, and there are some bad smell as well. So our current jellyfish fishing industry cannot be expand further as we think. So we have suggested to harvest 2 more species in Sri Lankan waters. They are Cambion masticifora and Hopiloma hispidum. We have introduced 2 new fishing grounds as well, and also rather than exporting jellyfish in bulks, so we are recommend to send them with value added products. So I'd like to conclude my study. Sri Lankan jellyfish fishery is a highly seasonal one, and 2 species are exported from southeast and northeast coast of the country, and this industry is important for the country's economy. More attention should be paid to minimize the adverse effects of the fishery, and also there is a potential to harvest 2 more edible species from Sri Lanka. So I would like to acknowledge Dr. Lucas Broth, Mr. Ajahn Rajsurya, Dr. Siddiq, and the stakeholders of Sri Lankan jellyfish fishing industry for providing us with relevant information and literature. This work was financially supported by the National Science Foundation of Sri Lanka. See, these are some references I used in the study. Thank you very much.
Thank you very much for that wonderful talk. Are there any questions? If not, I have a question about the handlers. What is their chief physical complaint? Is it itchiness or what do they report?
Yes, itchiness.
Itchiness.
Itchiness,
And
yes.
do they have any remedies that they use or?
Actually, they use some traditional remedies, but as they mentioned before, they don't much consider about the jellyfish attacks.
Okay. Yeah. Very nice. One last call.
Yes, I also have a question.
Oh yes, I hear you, Connie.
Thank you very much. So you said that there's a problem with with the bad smell of the degrading jellyfish. So could you maybe collect the jellies and have a dumping site for that offshore instead of having that on the beach?
Actually, when producing jellyfish, especially Lobonomatis species, there's a bad odor. So they don't dump jellyfish here and there. The only thing is that, so when processing the jellyfish, especially in the first step, when soaking and washing the jellyfish, so there's a bad smell.
Okay, thank you. Any other questions? Okay, if not, thank you very much. Oh,
Thank
sorry.
you.
Was there?
Thank you for your
One
nice
question?
presentation.
Yeah.
Yes. There is some chance that a jellyfish can be consumed at a local level in Sri Lanka. There is feeling for Sri Lanka people to eat jellyfish or to exploit jellyfish some way.
Actually, there is no any delicacy for jellyfish in Sri Lanka. So the entire house is exported to another country.
Yes, but there is some willing to consume jellyfish at the local level. There is not.
I don't think so.
Okay.
Because our tradition is somewhat different, like this, like in India.
Okay. Any more questions? No. If not, thank you very much.
Okay, thank you very much.
Thank you, Chair and Co-Chair. So let's honor the Chair and Co-Chair with a memento. I invite Professor Shin Yue to honor them. Thank you. Thank you very much. There are a few announcements Professor Biju Kumar will tell you.
Yeah, just before the lunch, few quick announcements. And one is those who feel sleepy, there is a tea stall working till 5 o'clock. Okay. And in the tea stall, you will also see the newspapers hanging. Okay. In the villages of Kerala, see, one of the common sight is local tea shops. And Kerala is something unique as far as India is concerned, because this is the only state which achieved literacy, 100% literacy much before. And our health standards are almost equivalent to the health standards of the Europe and USA. And also it is actually a playground for the third generation issues, because we started the first techno park to export software. Rest of India followed later. So there are a lot of uniqueness as far as Kerala is concerned. But something which never changed is these kind of tea shops in the villages, where the people assemble, still read newspapers, printed newspapers, okay, and enjoy the tea. And that is why, that is how the morning life in Kerala starts in the villages. So this is a reflection of that, and you can have the free tea from there. And the only thing is, the lady Nachma, you tell them what is your requirement, whether it is tea or coffee, whether it is stronger or lighter, whether it is with milk or without milk, and she will prepare it individually and give it to you. Okay, so you can enjoy the tea. That is, just to explain what is actually there. And the second thing is regarding photography competition. And that is a photography competition, sorry, it's not a competition, photography exhibition, which is arranged in the art gallery. Art gallery is just near the entrance. Okay, entrance of this entrance to the craft bazaar. So whenever you are free, you can go and visit it. And there are some classical photographs displayed there. And then Mike was telling me about the revised schedule, and you will already I have put it in the group, WhatsApp group, the revised schedule, because we made some of the changes, because there are some of the Israeli friends and Chinese friends are not presenting. Unfortunately, they could not come. And so we have revised it, and tomorrow morning you will also get a printed copy of the revised schedule in the registration desk. And some of them who have actually registered here on spot, you fill in the details, please. You go to the registration desk and fill in the details, including your email. It is missing there. And those who have demanded posters printed here, posters are ready in the registration counter, and then you can collect it. And those who are presenting afternoon and tomorrow or day after tomorrow during the lunch break, you can load the presentations here, so that immediately tomorrow and day after tomorrow we can start presentations. Thank you. Welcome to the lunch. Anything else, Mike? Yeah, for the evening tour, we have received the requests, and we will be starting from here just after the scheduled presentations, and few people opted for the mall and rest for the Varkala. So we'll start just after the completion of the scheduled presentations. Thank you.
Okay, so then we have an hour scheduled for lunch, so I think we take that, right? So we'll see you back here at 2:30. That'll still mean we get finished by 5:15, 5:30. And then we're looking for people who will, like senior researchers, who will help us evaluate posters for the poster competition. So please come volunteer to me or to Bijou for that, and we'll orient you for that tomorrow afternoon. Okay? All right, enjoy lunch.
Talk. So I welcome Dr. Mike Dawson and
16 different partners to think about all the.
Thank you so much. Thank you for that very interesting talk. I was wondering if you have tested jellyfish as an actual.
I talked to you about jelly forecast.
Of polybuminal and
In Kerala State.
16 to 2020.
എന്നിട്ട് ഇവിടെ നിന്ന് ഓട്ടോ വിളിക്കുന്നതായിരിക്കും നല്ലത്. എന്നിട്ട് ആ കോവളത്തുനിന്നേ ഓട്ടോ കിട്ടും. ആ ലീലൻ്റെ അവിടെ പോവാം. സ്പീക്കർ UPS ആക്കണം കേട്ടോ.
aware that many of these microbes that have been found in association with jellyfish can be pathogens. For example, it has been shown that several species of jellyfish were associated with fish pathogen, Tenacibacillum maritimum. I think we heard some talks about this gill disease in salmon fisheries. And there are quite some studies showing that it could be, in fact, caused by this microbiome. And the jellyfish could be a natural reservoir for this pathogen. Well, when we read through this literature, I also had to be a little bit critical on the methodological approaches that were used. Of course, we need to be aware that this is a span of like 2 decades of research, and very different techniques were available at different time points. But there were very different sampling approaches. Analysis was mostly done on the level of bacterial community composition. These studies were using different resolution, methods with different resolution, different protocols to extract DNA or to construct DNA libraries, different sequencing platforms, and most critical, different primers to amplify 16S rRNA gene, which makes them really difficult to compare. And there is also limited number of studies available that would actually look into the function of jellyfish microbiome. Couple of metagenomic studies, but this only provides insight into the functional potential. And on top of it, there is a vast diversity of jellyfish that remains to be explored as a host for microbiota. So this is unfortunately from 2019, but I'm trying to follow this literature, and not much has been done ever since. So basically, the floor is yours. Or maybe we need to convince microbiologists to start to be more fascinated about this host, not so only about sponges and corals. Okay, so now we move to something that is more of my topic. And usually when I speak at microbiology conferences, I always need to convince people about jellyfish and why they are important, and convince them about the fact that they bloom, and the blooms are massive, and I need to explain the life cycle. I don't need to do all of this here, probably. And we are also all aware of the last estimates of the total global mean gelatinous zooplankton biomass standing stock in the pelagic ocean, which in fact represents around 40% of the global phytoplankton biomass. So it's a substantial and much overlooked source of organic matter for marine microbes as well. Recently, some studies have been published that also imply that jellyfish could be important vehicles of carbon export to the ocean interior. So there are even estimates that they could contribute up to 40% of total global particulate organic carbon export. So again, when I will look into jellyfish as a source of organic matter for marine microbes, I will divide my talk in 2 parts. First, we will look into jellyfish mucus, and then into jellyfish detritus as potential source. But why do we care about marine microbes so much in the water column? So here I feel the need, I need to convince you that this is important, and despite their small size, they play a major role in marine ecosystems. But just briefly, so in every milliliter of seawater, there is around 10 to the 6 bacteria. Well, despite their really small size, due to their great abundance, they basically contribute to up to 70% of ocean's biomass, according to the last estimates. They are super small, even smaller than average, more famous family members like E. coli. So they are only around 0.6 micrometer in size on average, but they have very large surface area to volume ratio, which basically gives them an exclusive access, together with the fact that they are equipped with machinery that is needed to degrade and remineralize the biggest global reservoir of carbon, which is the soft organic matter in the ocean. So this is almost exclusively accessible to marine bacteria and archaea. So as said again, some studies have emphasized that jellyfish could be an important component of the biological soft tissue pump. What does it mean? So this is the concept of biological carbon pump that probably we are all aware of now. So every organic matter that is produced in the surface of the ocean and gets also transformed here and consumed, blah, blah, blah. So eventually starts sinking down here into the twilight zone and then into the deep ocean. Here, the fate of the sinking particles, it's basically tailored by heterotrophic bacteria and archaea. So if we would like to understand what is happening and what is the fate of jellyfish organic matter in the ocean, we really need to understand how microbes are interacting with this type of organic matter as well. So we need to understand, are they efficiently remineralizing it here in the surface, or is it sinking down to the deep ocean where it is sequestrated for quite some time? And this is also the way to basically keep the CO2 away from the atmosphere. So these are our oceans doing for us. Majority of people is not aware of that major role. Yeah, there's a famous cartoon of the sinking particle. You have like a particle, and then there's also a plum of nutrients behind it. So there are also bacteria jumping on these dissolved compounds that are leaking from the particle when it's sinking and working on it. So also we need to be aware that there are different, of course, compositions of marine food webs along the water column. So different microbes can populate different depths, and they are equipped with different metabolic machineries, and they are probably doing this process at different rates and so on and so forth. So I looked into the studies that try to understand the jellyfish decay rates, because this is crucial to understand if we want to incorporate them into the biological carbon pump or biogeochemical models. And there are, again, really few out there. Don't get me wrong, I really appreciate the effort. I'm just trying to emphasize what I think we need to address in the future. They actually use very different experimental designs. So they are, in fact, studying different fractions of organisms decaying jellyfish matter. They have been done only on limited amount of jellyfish species and in limited number of ecosystems. So if we really want to understand that, we need to make more effort on top of it. There are only few studies that have designed experiment to actually study the microbial degradation of jellyfish biomass, and they actually measure parameters that can be directly linked to microbial growth, like abundance, production, respiration. So we also need to make an effort there. We need to talk a little bit about organic pool in the ocean, which is actually a size continuum of dissolved and colloidal molecules and suspended and sinking particles. And I said again, these dissolved and colloidal molecules here are exclusively accessible to marine bacteria that, however, sometimes need to excrete extracellular enzymes to chop down these really complex molecules, make them small enough to cross the cell membrane. But they have the machinery to do it. So when I wanted to understand how different are, in fact, different jellyfish-derived DOM pools, and we are here talking only about the DOM, so the dissolved organic matter that it's inside or excreted by jellyfish. We conducted leaching experiment, which means that we dissolved either jellyfish mucus or jellyfish biomass in artificial seawater, and we followed in time how much nutrients and inorganic matter is released per milligram of this material, to find out that, in fact, jellyfish mucus has a higher C/N ratio as compared to the organic matter that is encapsulated in jellyfish biomass. Beside that, there is about between 1.5 and 3 times, where is the pointer, more of DOM and inorganic nutrients in jellyfish biomass as compared to mucus. So these two pools are very different also from microbial perspective. Microbes really like usually low C/N ratio because it indicates proteinaceous character. And especially in nutrient depleted environments, they like a lot of juicy organic stuff to build up their biomass. So let's focus on what is known about interactions between jellyfish mucus and marine microbes first. In order to understand that, we would also need to understand jellyfish mucus release rates, which are, to my knowledge, largely unknown. Only some very old studies are available. We would need to know the stoichiometry of jellyfish mucus, which is also only known for few species. And we would have to know better the composition of jellyfish mucus. And in recent years, there has been some studies also providing insight on the level of individual proteins that are there, because the composition of organic matter determines which microbes and how they are going to remineralize it and transform it and back to inorganic constituents. There have been only few studies, as said again, studying the impact of jellyfish mucus on marine microbes, but they all came to a similar conclusion that jellyfish mucus is mostly respired by microbes and they don't incorporate these compounds to build up their biomass. Usually we say that this means that this substrate is not juicy enough for bacteria. So they only use it to maintain their basic metabolism and not to build up their biomass. We also estimated recently bacterial growth efficiency of these communities, and it's quite low. So what does it mean? It means that this carbon from jellyfish that is consumed by microbes is lost from the system because it's respired and it goes with CO2 out of the system. And it's lost for other members of marine food web. And then finally, when jellyfish come to the end of their life, we know that jellyfish bloom can decay massively, rapidly. Some jellyfish blooms decay en masse. So at this point, there is a large impulse of organic matter that, as we've seen, it has a low C/N ratio, is quite rich in DOC, so dissolved organic carbon, nitrogen compounds, and so on, and becomes available to other members of marine food web. Of course, these jellyfish carcasses or detritus can face very different scenarios. They can be degraded or consumed, fragmented. They can even sink intact through the water column, which has been shown for some system and coined jellyfalls. But here we will focus on this potential scenario that jellyfish detrital DOM is remineralized by planktonic microbial communities. And why we think this is an important or likely scenario? Again, because of the characteristic of this organic matter pool, but also because of the fact that we, in our leaching experiments, have shown that immediately 50% of this organic matter is composed of dissolved organic matter compounds. So it means that instantly half of this is available to heterotrophic bacteria only. And this is composed of high molecular weight, but usually compounds, but usually microbes are equipped with machinery to chop them down to more simple compounds. So during a typical jellyfish decay bloom, we have quite substantial impulse, as said again, of DOC, TDN, amino acid, but also importantly orthophosphate. And this is quite important for nutrient poor environment or phosphorus limited environment, as our study ecosystem, the Northern Adriatic, is. So it means a big perturbation for the system. So in order to understand this response of ambient microbial community to this kind of enrichment and perturbation environment, we conducted jellyfish detritus enrichment experiments. We wanted to simulate the decay of jellyfish bloom in an enclosure. So we mixed detrital jellyfish matter with ambient microbial community in a 10-liter enclosures. We supplemented the jellyfish enclosures with concentration of jellyfish organic matter in a concentration that actually resembles a typical jellyfish bloom. So we tried to be reasonable. And then we also, of course, had unamendment controls. And then we followed the growth of bacteria. We killed the first experiment after bacteria reached late exponential phase of their growth. And then the second experiment only after bacteria entered the decay phase of their growth. And then we followed many different bacterial parameters like their abundance, the respiration and production of specific bacteria populations using specific microscopy-based methods. And then we applied metagenomics and metaproteomics to really get into what is happening into the microbial processes. And then we also followed many different chemical parameters to understand, first of all, how is this organic matter consumed by bacteria and what are the end products of microbial degradation. So we learned that this material is very labile. It was consumed in less than 2 days, basically the whole thing, most of proteins, amino acids, and almost entire jellyfish DOC pool by quite simple consortium of bacteria composed of Pseudothermonas, Halteromonas, and Vibrio, which are otherwise not so abundant in the water column of our system. And they represented more than 90% of metabolically active jelly-OM degraders. We seen that using a microscopy approach, coupling fluorescent in situ hybridization with different fluorochromes that allows you to see which cells are respiring and which are producing. And these bacteria were growing really rapidly, much more rapid than otherwise we know for coastal microbiomes. And they were characterized by really high bacterial growth efficiency. What does it mean? That unlike in jellyfish mucus, in this case, jellyfish was not only, bacteria was not only respiring jellyfish-derived material, but was also incorporating it into their biomass. This means that it was not lost for the system, because these bacteria will become a food for a grazer, or it can lyse and release organic matter into the ocean. So it's still inside the ocean interior. We also measured that microbial processing of JellyOM resulted in accumulation of some amino acids, but also, very importantly, of inorganic nutrients. And we saw this consistently in many experiments we conducted throughout the years. Accumulation of ammonia and accumulation of orthophosphate, which means that, again, in oligotrophic regions, this can have a large impact on functioning of the ecosystem. If it's a phosphorus-limited system, then you have an impulse. This can induce, for example, the growth of phytoplankton. All right, but we were not happy still, so we wanted really to dig inside the metabolic network that is operated by these microbes to consume this complex material. And we applied proteomics. As said, we looked into the endoproteomes. This is a fraction of proteins that is either inside bacterial cells or attached to bacteria. And then we also looked into the exoproteomes. These are the proteins that are excreted outside bacterial cells, usually enzymes, extracellular enzymes. So this allows us to have an insight into the, again, composition of community, which largely confirmed what we saw with the microscope. So there were, again, Pseudothermonadaceae, Althermonadaceae, Vibrionaceae, and Rhodobacteriaceae, composing 90% of metagenome assembled genomes. But this was also reflected in the composition of proteins. So basically resembled, like, really well what we recruited. And then we did a lot of very complex analysis to come to this lovely cartoon where I can explain what I think it was, or what we think it was happening. So despite this consortium was very simple, but very different from the one that is usually present in the water column. So the taxonomic composition after a jellyfish bloom decay in the water column is changing rapidly and substantially. They were like occupying, these four guys occupied completely different niche. So there was Pseudothermonas who did a very energetically costly thing of producing extracellular enzymes, excreting them, and chopping down the collagen. On the other hand, Althermonas was working on the carbohydrate fraction, excreting enzymes that can chop down the complex carbohydrates. Really interestingly, that Vibrio, despite having here, the pointer is not working anymore. So Vibrio had genes for all these enzymes, but didn't spend energy to produce them. So was only producing and synthesizing transformers and was feeding on the public good that were produced or released by other. So I like to call it a cheater in the system. And then there was also this poor alpha proteobacteria then down, which was synthesizing a lot of proteins for defense, because it seems to be that there were some antagonistic interactions of other bacteria towards this population. So what we learned was that decaying jellyfish blooms are inducing a very specific chemical and microbial metabolic fingerprint that is very different to the one that is usually associated with decaying phytoplankton blooms. So interactions between decaying phytoplankton blooms and bacteria have been addressed and studied extensively, really like deep. So it's one of the first studies that is really dealing with another blooming species. So this means that usually in marine environment, bacteria is more used to phytoplankton-derived organic matter. So then comes decay of jellyfish bloom, and everything is changing. So this can also, again, change the functioning and biogeochemistry of marine systems. We also have shown that decay of jellyfish bloom can be associated with enrichment in extracellular collagen-lytic bacterial proteases. So these are the enzymes that were excreted by Pseudothermonas to chop down the collagen. Besides doing that, these are also known virulence factors in human and marine organism disease. So they can have an impact on marine ecosystem services. And then on top of it, beyond this study, we are also providing new insights into the niche partitioning and metabolic interactions within the bacterium consortium when they are facing a complex pool of organic matter. Thank you.
Thanks, Tinkara, for a really fascinating talk. Do we have any questions for Tinkara? Yep. Jamila?
Thank you very much, Tinkara. I really enjoyed it. I think I have two questions. So one is about your observation if viruses also playing a role when it comes to bacteria-virus interaction.
Mm-hmm.
And the second is that bacterivore plankton might also play a role after the post-bloom decay.
Bacterivores? Yeah.
Yes.
Yeah. Mm-hmm.
Yeah. So what was your
yeah. Some viruses, I'm not usually studying viruses, but I did literature research and nothing has been done. There is no virion of jellyfish available. I mean, there has been something done on ctenophores, correct me. So I think Mia Prepart did some studies on some bacteriophages there. I know that, for example, this jellyfish, this jelly OM degrading community was in my study basically killed by viral attack. So after 24 hours, the whole population of bacteria dropped because of the viral attack. It was like a textbook kill the winner hypothesis. So basically, this means that the winning bacterial community or population gets attacked by a virus, and basically it kills the whole population. No? Very much like in human. And those that are feeding on bacteria, so grazing on bacteria, no, I have not looked into that because we were doing a microcosm. So I'm trying to exclude other members of food web because then it becomes even more complex. But that's my next step, to include other stages. Thank you. It's a question there.
Just wanted to ask, almost similar, right? Have you noticed any sort of marine fungi in that community? Because usually there's a lot of this bacterial fungal interaction, and I'm just wondering if they play a role in the decay.
No, I have not looked into that, but that's a hot topic in marine microbial ecology, fungi. I did accidentally cultivate some when I was doing also some cultivation, but I then passed it to my colleagues who are doing fungi research, and I'm not sure what has happened. But it would be super interesting to look into that as well. Yeah.
Thanks for the really exciting talk.
Thank you.
I wondered if you were comparing and contrasting to the same kinds of things in pelagic tunicates like salps, doliolids, and pyrosomes. I don't know how much has been done about them, but considering that they don't often bloom at the same time in the same place, and the effects that might have would make another nice review paper.
I am not sure, was this like a joke that I'm making a lot of review papers, or? Well, to my knowledge, there has been some activity there. I know that there was a study recently published on the microbiomes of pyrosomes. There are some groups focusing on that. Deep sea, no? You're a deep sea guy. No, not much more than this. I don't even think that there are any studies of the deep sea jellyfish and microbial interactions. So I think, Doug Lindsay, right? We should explore that. I need to talk with you afterwards.
Okay, well, we might leave it there so we can stay on time. So thanks very much, Tinkara. Okay, I'd like to welcome to the stage now Serafin Jeeson, who's going to be talking to us about the thermal influences on the life cycle and recruitment of the upside-down jellyfish, Cassiopeia, in a tropical shallow embayment. Thank you. Oops, sorry, got the honorary.
Thank you, Dr. Tinkara, for the nice presentation. So I invite Professor Jayachandran to honor Dr. Tinkara.
Thank you for that. Okay, Seraphim, come up.
Can I have my, is that it? Okay. So a pleasant afternoon to each and every one of you. My name is Seraphim from the Philippines. So it's a pleasure to be talking in front of you. So it's literally, I'm standing upon giants of my fellow colleagues. So I'm here to present our paper on the thermal influences of the life cycle of the upside-down jellyfish, Cassiopeia spp, in a tropical shallow embayment. As we all know, climate change is a recent topic in the recent decade, specifically on global warming. So predictions indicate that increasing sea surface temperatures will have various effects on different biological and ecological systems, notably in our case, gelatinous zooplanktons. Contrary to common assumptions, the association between global warming and the increased occurrence and abundance of jellyfish blooms have not been fully understood yet. Current extensive research and reviews have revealed that responses will vary among species and populations, and even within the same species across varying geographic regions. While a significant body has been focused on the temperate species, there is noticeable scarcity with knowledge regarding to population dynamics in the tropical region. So organisms in this tropical region are said to be living within or close to their thermal threshold and having adapted to a narrower and stable temperature range. So this study focused on a population of upside-down jellyfish situated in a very shallow embayment in Maribago, Cebu, Philippines. Though this population is morphologically the same, it actually comprises of two species, Cassiopeia mayeri and Cassiopeia colinensis. The habitat is characterized by a rocky sandy seagrass bed subjected to a very low tidal variation of 0.15 to 0.65 meters. The in-situ temperature measurements taken last May 2016 has revealed a range of 28.7 degrees to as high as 34.4 degrees, with an average of 31.9 degrees. So in this area, there is notably medusas are found all year round, with females with brooded embryos in their central oral arms. Interestingly, despite their year-round appearance, there is substantial variation in size, frequency, and abundance each month. Notably, there is higher abundance of smaller size medusa, less than 6 centimeters, which are occurring during and after the northeastern monsoon, which brings colder winds from Siberia. So this study focuses on investigating the responses of this tropical upside-down jellyfish to a very narrow range of warm temperature. Specifically, we wanted to check or assess larval settlement rate from the sexually produced planulae larvae. At the same time, examine sexually reproductive responses of the benthic stage, specifically the strobilation and budding. We initially hypothesized that these responses will not vary across this very narrow range of temperature. As for the methods, we started off with collecting female medusas with visible pinkish to orange embryos within their oral arms, and then we isolated them individually and left them in the dark for 36 hours, after which actively swimming planulae larvae was then collected and pooled for succeeding analysis for Objective 1. And for Objective 2, a polyp culture was started to test for the strobilating and budding experiment. So our chosen temperature range from 27 to 35 degrees was based on the in-situ measurements taken, with 27 being the least warm and 35 being the warmest. So for the first objective, settlement, actively swimming planulae larvae were individually collected and placed individually in plastic containers. Before the start of the experiment, a preconditioned floating polystyrene film was then added. The entire experiment was set to 5 days with the following observation time points. So we also had biological and technical replicates. The percent settlement count was calculated at each time point, and an individual was considered settle when successful formation of the pedal disc and the 2 tentacular bud. As for the second objective, for the settlement and budding, mature polyps were isolated from the culture and then transferred to individual containers and was left to reattach for about 1 week in the dark. So after which, any unattached polyps or dead polyps were then removed from the containers. The entire experiment was set for 30 days. with daily observations. And the setup was fed with 3 times a week with fresh hatch Artemian nauplii ad libitum in order to saturate feeding with a 12-12 light-dark cycle. So we have also both biological and technical replicates. Since some of the polyps had died, so there was an uneven number of polyps per container per treatment. So attributes that were measured was the percent strobilating polyps and budding polyps per day. So all statistical analysis was conducted in RStudio or R and passed for. So for the results for this first one, we can see that as there was a significant impact between time, temperature for larval settlement, as we can see that as time progressed and as temperature increased, settlement also increased. Wherein, if you look at it, 35 degrees had the most increased number of settled numbers, followed by 33 degrees. While 27 to 31 degrees, there was no significant difference among this range. Notably, within the 5 days period, there was no 100% settlement observed in any of the treatments. At the same time, no mortality was observed. Looking at the 35 degrees planulae that were still alive, they had a very shrunken appearance. At the same time, they were moving or swimming sluggishly at the bottom of the container. While temperatures less than that, they were still actively swimming. So this enhanced settlement could possibly be due to increased metabolic demand due to warmer temperatures. As we all know that Cnidarian planulae don't have an oral mouth, so they rely on their embryonic stored energy. So the warmer the water, the faster the metabolism, the more there is need for them to settle and metamorphose into polyps so that they can start feeding. So this is the results of this study is also comparable with other species in the temperate area for Cyanea lamarcki and Chrysauria hysocelia. At the same time, in the Mediterranean for Cotylosa tuberculata, wherein faster or enhanced settlement was brought about by warmer temperatures. At the same time, it's also comparable to Cassiopeia samachana in the Florida Keys, wherein within the range of 15 to 33 degrees, there was no change in the settlement rate. So in this case, for this study, it's 27 to 31, there was no change. But there was a greater settlement rate for temperatures greater than 33. So for the budding and stridulation experiment, it was observed in all treatments except for 35 degrees. So a monodiscus was observed for stridulation, and budding accounted for single chain bud to multiple chain bud found at 33 degrees only. So looking at the cumulative count for each of the temperature range, we can see that there is an inverse pattern, wherein at more warmer temperatures, more buds were produced, while at lower temperatures, ephyra production dominated. Notably, one reason for the increased number of bud released in 33 degrees was the formation of chain buds in the base of the calyx, wherein as much as 3 buds were formed at the base. So looking at the ANOVA for the stridulation experiment, we can see that there is a significant difference between 27, 28, and 29 to 33 degrees. So there's no difference between 27 to 31, and 33 degrees had a lower percentage of stridulation. So this could mean that within this range, or basically the entire year round in the Philippines, stridulation can occur. More specifically on the cooler months during the northeastern monsoon, where waters are relatively less warmer. So this also agrees with the same studies in Cassiopeia andromeda and Samachana, wherein within this temperature range, stridulation was more enhanced. So at the same time, so we can see that in 33 degrees, stridulation was less. So it could mean that during the summer months, wherein it's way hotter in this shallow embayment, so stridulation might be arrested or limited during this time. For the budding results, we can see that there is statistically no difference among the 4 temperatures. But visually looking at the graph, we have more percentage of budding polyps that are found at 31 and 33 degrees. So this could possibly mean that within this range, since all polyps had budded, so budding can possibly occur all throughout the year within the shallow embayment, but most specifically during the warmer months. But there's still more study that can be done. But in contrast to that, for Cassiopeia andromeda in the Red Sea, the researchers have found that budding was more prominent in cooler temperatures at 17 to 18 degrees compared to warmer temperatures of 20 to 30 degrees. Looking at other species like Aurelia aurita, wherein they are known to exhibit varying responses at different geographic range. So there was enhancement of budding at warmer temperatures at the Baltic and Mediterranean Sea, while the opposite was found in Taiwan, where in cooler waters, budding was enhanced. But really looking at it, they found that in the Baltic and Mediterranean Sea, it says more warmer temperatures, but it's technically the cooler temperatures of Taiwan. So they still move around the same mean of 20 to 21 degrees. Although in my study, mortality wasn't part of the objective, so I can like to present this without a rough statistical exam. We can see that for the first 4 temperatures, 27 to 33 degrees, they more or less have the same survivability rate. But looking at the 35 degrees, mortality dropped to 100% about the 15th day. So in my observation, the cause of mortality was a form of an eversion wherein the polyp would flatten itself and then spill open its guts. And then, I don't know what happened. Eventually, it would lead to the polyp being unable to feed. At the same time, disintegration. So this was found all over all treatment. So in conclusion, I would say that there is enhanced settlement at more warmer temperatures, leading to increased benthic recruitment during the summer months from March to May in the country. At the same time, strobilation and budding can occur all year round within the range of 27 to 33 degrees. But each of this asexual trait might increase or decrease during specific months. At the same time, I'd like to point out that for the polyp stage, there is a survival threshold for 35 degrees and greater, and that strobilation might be limited at 33 degrees or more. So I'd like to say that this Cassiopeia in this country, or in this part of the world, are insensitive to small thermal variations from 27 to 31, but temperatures greater than this, the polyp stage or even the larval stage can become sensitive to their behavior already. So this study is without its limitation. At the time of collection, no molecular analysis was done. So initially we thought it was only one species. So it could be a source of variability within the data. We also had a smaller sample size due to constraints in resources and in the facilities. And of course, I had a smaller observation time for settlement, 5 days compared to other studies which had like 50 days or 200 days longer. And at the same time, a limited observation time for the benthic asexual traits. At the same time, I also lack a in-depth examination of the mortality data, so I still have to consider that. At the same time, there's a lack of more robust ecological and population data on this species. So with that, I'd like to recommend more extensive baseline data with all Scyphozoan species within our region. At the same time, to explore the lower thermal limit for these tropical species, and more studies on population dynamics and how they are being driven within the region. At the same time, of course, with that, you have to study their reproductive biology as well. So I would like to thank the following people for the support of this research. At the same time, the University of the Philippines to support this travel to India and making me talk to each one of you. Thank you.
Thank you, Seraphin. Do we have any questions?
Great, thank you. Excellent talk. Do you ever have issues with low oxygen levels in these areas, or is it pretty well oxygenated? And how might that affect the results of your experiment?
So is this for the settlement experiment or for the strobilation and budding?
Either in the natural system, is there low oxygen there, or is that not an issue in this part of the world?
Well, I think for these species, since they're living in a tropical seagrass bed, and at the same time they have the for the medusa, they have the photosynthetic symbiont within them. So I think oxygen production is not an issue for them. Yes.
Thank you.
Another question up the back there.
Very nice work. Similar work we are doing on Cassiopeia samchana. Okay, we proved via the molecular also. My basic question is just to understand the concepts, because we exhibit the same kind of strobilations and budding of the same samchana in Indian condition down southern part. My question is two questions. First question is, did you observe any kind of strobilation polyp or any kind of effery release in the wild where you collect this sample, that is the seagrass beds. Similarly, what we have seen in our condition, where Samshana is mostly a mangrove jellyfish, there also we have some kind of release and polyp settlement over that, the mangrove crop roots, etc. That is first question. Second is, when we collect the adult brooders from the wild, because little while back we are discussing with the Henry, what exactly seen in the condition is, so the polyp, generally the Samshana adult have a brooding eggs. So this species, what we observed in the controlled cemented tanks, the effery, that means post-effery, when it is geotactic settlements, all the post-effery, it's found into the oral arms, like some kind of parental behavior. We were discussing whether it is sudden release without any stage, like without stropulation. It found inside the oral arms of, when we shake the animal brought into the beaker, immediately we have different stages of post-effery found inside the animal.
What we might do, sorry, because we're going to be running out of time here.
Okay.
We don't want to hold
My
the other
understanding
speakers.
is
Basically, if you two could hook up perhaps afterwards and you can continue the conversation there. Okay, thank you. Thank you very much.
Okay, thank you so much.
Okay, so our next speaker is Marta Mamoni, and Marta is going to be talking to us about the influence of photosymbiosis in Cassiopeia zamachana regenerative success. So, extending the theme of Cassiopeia. Thanks, Marta.
Okay. Good afternoon, everyone. I'm Marta Mamoni, a postdoc from Texas A&M University in the Milietta lab, but today I will present an experiment that I did during my previous postdoc at Penn State University in the Medina lab on the regeneration of Cassiopeia zamachana. Sorry. So in general, regeneration can be broadly described as a restoration of lost body part and tissues. And we can have restorative regeneration that can include post-traumatic regeneration after injury, or we can have also the physiological regeneration that can occur during the life cycle of an organism, such like, for instance, for Scyphozoan, can be during budding. Most regeneration studies have been focused on model organisms such as Hydra and Hydractinia echinata, so hydrozoan, and some also on Nematostella vectensis, so class Anthozoan. In general, hydrozoan possess eye cell, which are hydrozoan stem cell. They are found between ectodermal cell, and they can create neurons, cnidocytes, gland cell, and germ cell. On the other side, we have Scyphozoan that they lack this eye cell, but they possess amoebocytes. Amoebocytes are thought to be involved in immunity, and also they are important for the establishment of photosymbiosis. And there are few studies on regeneration of Scyphozoan that are mainly morphology-based. We have some studies on Aurelia, where this mechanism called self-repair was observed by Abrams et al. 2015, and basically after an injury of an ephyra, what happens is that instead of regenerating what is lost, the ephyra reorganize existing parts and rebuild the radial symmetry. Few more studies have been focused on the upside-down jellyfish, Cassiopeia zamachana, which is symbiotic. It's a tropical jellyfish found in shallow water ecosystems and is characterized by a developmental symbiosis with dinoflagellates of the family Symbiodinaceae. There are some studies on polyps regeneration by Curtis and Co. in 1974. And here what they did was to make some cuts in the polyp. And overall, they observed that polyp can regenerate missing tentacles or part of the hypostome. The stalk, the decapitated stalk, could regenerate the head, but the head couldn't regenerate the stalk, and instead was making buds. Few more studies focus on different life stages of Cassiopeia. We have Ostendarb 2022 and Gamero Mora 2019. And in this case, they observed that regeneration of an entire medusa can take place as a consequence of an injury in the bell, suggesting pluripotentiality. So we started by thinking that by taking into account the fact that Cassiopeia lack eye cell, but possess amoebocytes. So we really wanted to see what is the role of amoebocytes, since they are involved in wound healing and symbiosis. And we think that using Cassiopeia xamacana as a model organism for regeneration can be useful to disentangle these two different processes. So on one side, photosymbiosis, and on the other side, regeneration. So we started by understanding how the presence of different symbiont species could influence regeneration in Cassiopeia xamacana. We used a clonal line of polyps, T2D, that are at Penn State University. After an acclimation period, all the polyps were kept at 25, 27 degrees, 35 salinity, and 12-12 light cycle. We fed the polyp daily with artemia, and we changed the water 3 times a week. And here we have 4 different treatments. We had the first treatment that basically we infected the polyp with the homologous symbionts, Symbiodinium microadriaticum. Then we have the second treatment. We infected the polyps with the heterologous symbionts, Breviolum pseudominutum. And then we have the so-called SYM treatment. So these polyps were already symbiotic, but we didn't know the species of the symbionts that they were hosting. And then we have the last treatment that are aposymbiotic polyps, so polyp without the symbionts. So after the acclimation and various infections, we decapitated the polyp. So we made an incision between the stalk and the calyx. And we observed regeneration for like 17 days. We took some daily pictures. We counted the buds that were produced from the head of the polyp. We look at the survival of the stalk that were regenerating, and also the regeneration. We also did some confocal microscope imaging, and then we used the pictures to count the symbiont afterwards with the cell counter plugin in ImageJ. We did some staining, the EDU staining, which is the 5-ethinyl-2-deoxyuridine. That is a staining that basically stain dividing cells. And we did 3 different time points, 6 hours post-amputation, 8 days post-amputation, and 17 days post-amputation. And last but not least, we also did a DNA extraction from the SYM treatment to understand which was the symbiont species that they were hosting. And we used Todd-Lajeunesse protocol. And here are some results. So overall, all the treatment regenerated, and regeneration started at day 4 and was completed by 14. And as shown by previous literature, the decapitated stalk could regenerate the head, but the head did not regenerate, and instead produced some buds, as you can see in the top middle figure. And then and some also strobilate, as you can see from the green arrow. And some stalk did not regenerate, and instead they died, and then they were characterized by overgrown algae, as you can see from the red arrow. And the DNA extraction from the SYM polyp showed us that they were also infected by Symbiodinium microadriaticum, so the homologous symbiont. So from the morphological point of view, we didn't see any difference, any influence of the dinoflagellate symbiont during stalk regeneration. And in the 2 treatments that we infected, the polyp that we infected, we didn't see any dinoflagellates migrating to the point of injury, or that were proliferating in the regenerating head. But in the SYM treatment that were already symbiotic for a while, we saw, as you can see in the last pictures, we saw some symbionts at the point of incision, and they were also proliferating in the regenerating head. Overall, we can say that by the end of the experiment, all the symbiotic treatments increased the abundance of symbionts. As I mentioned before, we also counted the bud that were produced by the head. So in the first graph, you have on the x-axis the different treatments, on the y-axis the number of buds per polyp, and in the second graph, you have, we group basically the aposymbiotic and, wait. Okay, so in the second graph, we have we group together the aposymbiotic and all the symbiotic treatments, and both symbiont species and the symbiotic state contributed to a significant difference in the bud count, and overall, like the SIM treatment produce more buds. Then we decided to group the status of the stock in no change, so no regeneration and no dying. Then we have the dead one, and then the dying with the sign of degradation and regenerated. So in the first graph, graph C, you can see on the x-axis the different treatments, on the y-axis the proportion of the polyps, and the SIM stock had overall more regeneration and lower mortality, contrary to the aposymbiotic one that had higher mortality and lower regeneration. Then again, we group together the aposymbiotic and all the symbiotic treatments, and we saw a significant difference between aposymbiotic and symbiotic for living versus dead polyps. And in this case, living we group together regenerated and no change. And we also saw a significant difference between aposymbiotic and symbiotic polyps for regenerated versus non-regenerated polyps. And in this case, non-regenerated, we group together, no change, dead and dying. Here's some EDU imaging. So unfortunately, we didn't see any difference in the number of location of the EDU labeled cell between the different treatments. Here I just put two like one treatment, and in pink you can see the microalgae, in blue is a nuclear stain, the Hoch staining, and then in green is the EDU labeling. So as shown by previous literature, polyps cannot regenerate the stock. So this means that either they lack the capability for regeneration, or they just prefer to allocate their energy in another way, for instance in reproduction. And bud production was higher in symbiotic treatments, and this suggests the importance of the photosynthetic energy that is given to the host by the symbionts. The SIM treatments were the most successful one in terms of regeneration, and once again these underline the importance of the photosynthetic energy. And the difference between the polyp that we infected with the Symbiodinium microadriaticum and the SIM that at the end also were infected by Symbiodinium microadriaticum suggests that the influence or regeneration is the degree, what is important is the degree of symbiosis, so the number of symbionts that were present at the starting point of the experiment. And in addition, we didn't see any difference between polyps that were infected with the homologous symbiont and with the heterologous symbionts, and these underline again that what is important is not the species of the symbiont that is hosted, but is the amount, the abundance of the symbionts that are present in the host. As I said before, regeneration started around day 4 and was completed by day 14 in most of the cases, while algal cell colonization in the regenerating head took a bit longer, and these indicate that photosymbiosis and regeneration are two independent processes. And the lack of increase in cell proliferation at the point of injury suggests that regeneration in Cassiopeia xamacana is not driven by cell proliferation, but rather cell migration. But I think we should do additional study. For instance, we can increase the time points of EDU labeling, perhaps doing one after 3 hours post-amputation, in order to better understand if proliferation really doesn't occur, or maybe if we just miss the time point. And then it could be nice to develop an accurate way to identify amoebocytes in situ. If you want to read more about the paper, I left here the citation. And currently, I'm at Texas A&M University, and I'm working, I'm doing RNA extraction to build a transcriptome of a control, which is an intact polyp versus a regenerating polyp, and that you can see here from the picture. And based on the transcriptome data analysis, we would like to do some whole mount in situ hybridization. And with that, I would like to thank my previous PI, Monica Medina, and the Medina Lab, Penn State University, and Euromarine for the funding, and then different labs at Penn State University that help us with the microscopy, and all the people that help us with the manuscript. And I would like to, I'm happy to take any questions.
Thank you. Do we have any questions for Marta? I've got a quick, oh no, we've got one here, Mike.
Thanks, Marta, really interesting. Hey, so you say that you think that the change in budding is driven solely by the energetics. Yeah. Do you think there could be other signaling being involved?
Can you repeat, sorry?
Yeah, you recorded a difference in the amount of buds produced related to the symbiont's presence or absence.
Yeah.
And so, and you attributed it to energetics. Yeah. And so I'm wondering whether you think that there could be other signaling involved. So it's not purely an energetic evaluation, but there's other relationship going on.
Yeah, because the head cannot regenerate, so I would be interested also to do the transcriptome of the different parts of the stalk and the head, and then compare if there are different genes that are involved in the different processes. Because it's still regeneration, it's like a physiological regeneration, the budding, but still the head cannot regenerate the stalk. So there is something similar, I think, but also different. But I think transcriptome would help us to know more about this.
Thank you.
Yeah, thank you.
Okay, thanks, Marta. We might move on. Yeah. Okay, thank you. Okay, so I'd like to welcome Kentaro Suzuki, and Kentaro is going to talk to us about the environmental factors affecting the population dynamics of moon jellyfish Aurelia caerulea in Ise Bay, Japan.
Hi everyone, I'm Kentaro Suzuki from Japan, and today's my talk is about environmental factors affecting Aurelia outbreaks. So as you may know, Aurelia species look like this, and with a size up to 30 centimeter, and they distribute globally and feed on zooplankton. And Aurelia species frequently show outbreaks, and their outbreak can affect coastal food webs and damage fisheries and power plant operations. These are the typical metagenic life cycle and also the conceptual population dynamics through their life cycle. The Aurelia can greatly increase in number through both sexual and asexual reproduction, as polyps produce ephyra which further grow up into medusa. So the asexual reproduction during polyp stage has been suggested to be quite important factor of their outbreaks. Besides the mortality of Planura, the mortality rate of ephyra is suggested to be quite high, like more than 80% in the first 20 days. So the interannual variations of ephyra mortality rate could also affect the intensity of their outbreaks. The possible causes of Aurelia outbreaks has been suggested, like global warming, which can boost their growth rate, and eutrophication, which can also boost growth rate and provide hypoxic condition Aurelia may prefer, and the increase of artificial substrates provide additional habitat of polyps, and the decrease of fish stock means the decrease of predators and competitors against Aurelia. The migration from adjacent areas can also increase the number of Aurelia, but most of these possible causes were estimated from laboratory experiments, and what is going on in the sea have rarely been validated. So we need quantitative analysis based on time series population dynamics. However, there are only a few time series data about the population dynamics of jellyfish because most of them are non-commercial, and there are also challenges of sampling, such as patchy distribution and net clogs. But there are only a few time series data. Those data suggested that jellyfish abundance may fluctuate with around 10-year periodicity. In Japan, there is a 9-year time series data in Ise Bay reported by Hamada 2014. And this data set is kind of unique because he reported both medusa and polyps population dynamics. So in the report, what? The medusa abundance, the blue points were correlated with polyp abundance in the previous winter, which produced ephira, so orange dots. So such unique data set enables us to analyze stage-specific relationship between the abundance and environmental factors. So in this study, with the data of Hamada from Isebe, we aim to analyze and discuss the relationship between Aurelia abundance and environmental factors to understand the causes of the outbreaks. There are two features of this study, and the first one is to focus not only on Medusa stage, but also other stages. And the second one, we treat the climate indices as environmental factors, as well as more direct variables, such as temperature, because Robinson and Graham suggested the North Atlantic oscillations and other climate indices were related to Aurelia abundance in the Gulf of Mexico. So this is, So the Isebe is located middle of Japan, and the bay is a semi-enclosed bay with large river inflows at the innermost part of the bay. And the, the Hamada reported the medusa and polyp abundance from 2003 to 2011. The relative medusa abundance was estimated from the intruded amount of medusa into 6 power plants at the innermost part of the bay. And polyp density was observed in the innermost part of the bay by scuba diving in the previous winter. With these data, we estimated the survival rate after ephira release until they intrude to the power plants. So the figure shows the relationship between the polyp density in the previous winter and medusa abundance, and the dashed line is a regression line. The data above the regression line means there were more medusa than predicted from the polyp density, and vice versa. So in this study, we assumed the variations of the residuals from the regression were derived from variations of survival. We collected environmental data like river discharge, SST, SSS, and chlorophyll A. And for the climate indices, we choose Southern Oscillation, Pacific Decadal Oscillation, Pacific North American Pattern, and Arctic Oscillation as the potential environmental factors affecting their population dynamics. And with this data, we performed a simple multiple regression analysis to evaluate or estimate the environmental factor affecting polyp abundance, the survival rate, and medusa abundance. At first, I show the relationship between polyp abundance and environment. For polyps, we analyze the potential environment in previous summer to winter when polyps asexually reproduce. Among the potential environmental variables, PDO, the Pacific Decadal Oscillation, in previous summer best explains the polyp density. The PDO negatively correlated with SST, but the correlation between SST and polyps were much weaker than PDO. The PDO is reported to affect not only SST but also prey abundance. So this result can suggest that the combination of SST and prey abundance affect the asexual reproduction of polyps. Such relationship between PDO and population dynamics have been reported for other marine organisms such as regime shift of anchovy and sardine ratio in Japanese waters. Next, survival rate after FIR release. The FIR are liberated from Strobila in winter, and the Medusa usually intrude to the power plant in early summer, so environmental factors from winter to early summer affect their survival. Excuse me. So the survival rate showed negative correlation with river discharge in January-March when the Aurelia are Ephyra or young Medusa, and against river discharge in April to June when they are Medusa. Compared to these two periods, the river discharge in January to June better explains the survival. High discharge causes high water exchange between in the bay and outside of the bay. So the high river discharge could flush out Aurelia out of the bay, lead to the higher mortality. Finally, we discuss about the Medusa abundance. The Medusa abundance is affected mainly by polyp density in the previous winter and survival rate after FIR release. So to estimate the contribution of polyps and survival on Medusa, we calculated standardized partial regression coefficient. The polyps showed higher coefficients, so that means polyp contribute more on Medusa, but the coefficient of survival rate is not so low, so the survival should be considered as well for the outbreaks. The PDO in the previous summer affected their asexual reproduction during the polyp stage, and river discharge in January to June affected their mortality after FIR release, and the combination of these two explained 80%, I think it can be pretty high, of the interannual variations of Medusa abundance in Ise Bay. So this study suggests the summer PDO affects the asexual reproduction of polyp through temperature and play, and also the river discharge in January to June affected their mortality after a FIR release. And this study also suggests the importance of, of the mortality for the outbreaks, besides the well-considered asexual reproduction during polyp stage. Thank you very much, Dan Hart.
Thank you. Kentaro, do we have any questions? Yep. You next, Dougal.
Thank you for the interesting presentations.
Thank you.
And I would like to ask how many percent of polyps or polyp strobylate for the the liberating of ephira?
Excuse me.
How many percent of polyp can produce the strobylation? I mean,
you mean the proportion of the strobylation among the polyp? Actually, I use reported data, and I don't think they observe the percentage of the strobylation, unfortunately. But from this data, actually, we calculated, yes, okay, yeah, this one. Actually, we calculated the survival rate, but this value could be, how can I say, the result of the survival rate and also the proportion of the strobylation and also the number of the disc on the strobylation. but this value was correlated to the highly correlated to the river discharge, and that can mean those like strangulation rate or the number of the disc on the strangulation is not so important stuff for their population dynamics, and the mortality is, I think, much more important stuff for the population internal variation of their population dynamics. Does it make sense?
In the East Bay, right?
Okay.
East Bay, right? It was East Bay, the study area.
East Bay,
right?
yes.
And the strangulation is generally occurred in the late autumn or early spring?
January, it's in January and February.
The high correlation with the Pacific decadal oscillation, that in itself probably is not the cause, but what do you think is, like, the anchovy are linked? So is it the number of anchovy larvae around?
I don't think the number of anchovy is not directly related to their population dynamics, but just I think the temperature and the prey abundance could be the reason for the correlation, I think. But we need more data to validate that.
Okay, thank you. We'll move on. Thank you very much, Kentaro.
Thank you.
It gives me great pleasure to introduce the chair, Professor Kylie Pitt. Over to you.
Thanks, Mark. Okay, so I'd like to start off by acknowledging my collaborators here. So this work couldn't have been done without the team from the Marine Parasitology Lab at the University of Queensland, my colleague Pablo at SeaWorld, and also note that this research project was inspired by Joanna Brown's PhD on parasites in jellies, which she finished a few years ago. So this idea that jellyfish are trophic dead ends has now been overturned, and we know that lots and lots of different predators eat gelatinous zooplankton. But all of the methods that we use to try and look at predation on gelatinous zooplankton have limitations and biases. So traditionally, we've used things like gut content analyses, so effectively just looking at what's in the gut to see if we can identify gelatinous material. But of course, gelatinous material is digested very rapidly relative to other prey, and it's also very difficult to identify. Now, metabarcoding can really help with the identification these days, but regardless, gut content analyses just provide a snapshot of what the animal has eaten over the last few hours. So biochemical traces are really useful in terms of offering a time-integrated analysis of diet. So they tell us what an organism has been eating over periods of weeks to months beforehand. However, they are very limited in that we can't actually work out what the specific species of prey is. So we can usually work out a general group of prey, but trying to work out the individual species is a lot more problematic. And advances in camera technology are really exciting because we can now put cameras on all sorts of different animals. So these are things like turtles and penguins, and these are revealing some really novel predators of gelatinous zooplankton. But of course, there's only certain animals that we can actually put cameras on. So things like penguins are great because we can get the penguins back and the cameras back. Okay, but there's lots of predators for which camera technology just doesn't work. So ideally, what we need is a method of identifying predators of gelatinous zooplankton that is a time-integrated method, so it's not just a snapshot, and that also enables the identification of this actual species of gelatinous prey that's being consumed. And this is where parasites might be really, really useful. So many endoparasites, so these are things like flukes and tapeworms, they often have multiple hosts in their life cycles. And quite often, the different stages of the life cycle pass from one host to the next via predation. So things like Digenean trematodes are a really good example of this. So these are parasitic flukes that have 2, 3, and sometimes even 4 different obligate hosts in their life cycle. And here's an example of a Digenean life cycle that includes a gelatinous prey. So here we've got Trichuris, a fish. Okay, we know that these mackerels eat a lot of gelatinous prey. They host Monascus filiformis, which is a type of Digenean trematode. The fish is the final host in the life cycle, and they host the reproductive trematodes. So the trematodes reproduce, they release their larvae. The larvae then swim and occupy a bivalve mollusk as the first host. Then inside the bivalve mollusk, the parasites turn into Cercariae. The Cercariae then burrow out of that host, and then they burrow into the second intermediate host, which in this case is Liriope, a hydrozoan. And they develop into what we call the metacercariae in the hydrozoan. And then the definitive host, or the final host, gets infected by the parasite when it actually eats the second intermediate host. So this is evidence, if you like, of predation by Trichuris on the hydrozoan. So digenians are going to be most useful as trophic tracers when the parasite-host relationship is really species-specific. Now, identifying the metacercaria stage is really, really tricky if you're just using morphology alone, and this is because they don't have the adult reproductive characteristics that are usually diagnostic. So for this reason, we actually need to use genetic sequencing to reliably identify them. So this is where the relationship or collaboration with the Marine Parasitology Lab really came into the fore. So they have been working on parasites in fish for over 40 years, and they've actually sampled more than 4,000 individual fish and from over 300 different species of fish, often within Australia, but also in international areas. And they've identified over 140 species of fish trematodes, and they've got their genetic sequences available for many of them. So the aims of this collaboration was to identify novel predators of gelatinous zooplankton by comparing the genetic sequences of the metacercariae found in the gelatinous zooplankton to those in the adult digenians found in the fish. We also wanted to just assess the basic diversity of digenians infecting in gelatinous zooplankton, and also the specificity of the host digenian relationship. And also just to close the life cycle on some of the digenians by identifying the intermediate hosts. So to do this, we sampled a lot of gelatinous zooplankton. So we sampled 587 individuals from 29 species of Cnidaria, Ctenophora, Thaliaceans, and heteropods. And samples were collected in the coastal waters in southeast Queensland, but also onto oceanographic voyages, one that just went in and out of Brisbane and sampled southeast Queensland waters again, but offshore, and another that cruised from Hobart up to Brisbane, and so allowed us to take samples along the east coast. And this is how we sample them, just using nets, so either just nets off the side of the boat, thanks John for helping out there. On the ship we use the bongo nets, but we often just saw lots of gelatinous zooplankton on the surface, so we also just leaned over the side of the boat with a very big net and scooped them up as well. So we had to extract the digenians alive from the hosts. And this is what a Hormifera, a type of ctenophore that's infected by digenians looked like. So all of those little dots indicated by the arrows are digenians. They're actually, in the transparent species, they're actually very, very easy to see. So we extracted the digenian metacercariae from the live jellies, and it's a little like trying to pull a grain of sand out of egg white, and doing that on a moving ship can sometimes be a bit tricky. And we then took the ITS2 and COX1 sequences for them. And then the sequences of the metacercariae were compared to the sequences of adult digenians from the database in the Marine Parasitology Lab, and also to relevant sequences on GenBank. And I guess the first conclusion is that digenians infect a lot of different types of jellyfish. So here we've got a list of taxa for which we had sampled more than 10 individuals, so had a reasonable sample size. And if we just look at the cnidarians, 2 out of the 3 species of cnidarians that we comprehensively sampled were infected. All 7 of the hydrozoan species we looked at were infected. 4 out of the 4 ctenophores that we looked at were infected. We didn't find any in the 2 species of SELP that we looked at, or in the 1 heteropod, although we know from the literature that those species that we were looking at do actually carry digenian infections at some time. The rates of infection vary a lot among taxa, so the dark blue represents the number of individuals in which we found the parasites. So things like Oldersladia magnificus, a large hydrozoan, had about an 80% infection rate, as did the Scyphozoan Chrysora pentastoma. Catastylus mosaicus, we didn't find a single digenian, and Eutemia and Liriope, other hydrozoans, had fairly low rates of infection. And if we look at some of the ctenophores, again, infection rates range from about 80% down to about 10%. Okay, so Digynians confirm some of what we knew were predators of gelatinous zooplankton. So here we've got Protistium, which hasn't yet been identified, or hasn't been assigned a species name, but this one species of Digynian was found in 2 scombrids. So scombrids are really well known for eating gelatinous zooplankton, and we found the corresponding Metaceriae in 3 species of Cnidarian medusae. So in this case, the relationship isn't very specific. The Digynian can infect multiple final hosts or multiple intermediate hosts. But it does tell us that these scombrids are probably feeding on these types of Cnidarian medusae. Digynians also confirm some plausible predators of gelatinous zooplankton. So here we've got Kumara braei, and this species of Digynian was actually first identified in Monodactylus argenteus. And it was only when we did the study that we finally worked out that Pukia fulcata is the intermediate host in this life cycle. Now, Monodactylus tends to feed on invertebrate epibiota and also on zooplankton. So it's actually quite plausible that it could also be feeding on things like Pukia fulcata, but this was the first time that that had actually been documented. And then we've got a case where Digynians identified what we think are some novel predators of gelatinous zooplankton. So Beryl Dong, a PhD student at the Marine Parasitology Lab, had just described this brand new species of Digynian, Opicanodes opistheporus, and she'd actually identified it in 12 different damselfish hosts from the Great Barrier Reef. And her paper was about to be submitted when we got some of our sequences back, and we went, hey, look, we actually found the intermediate host, which were ctenophores, and we actually found this parasite in 3 species of ctenophores. So we know that some damselfish do eat zooplankton, but some of the species that she found the parasite in hadn't really been known to feed on zooplankton, and certainly not gelatinous zooplankton. So this probably is some novel or new predators of gelatinous zooplankton. What's really interesting here, though, is that all of the ctenophores that we sampled were south of the Great Barrier Reef. And in fact, the Bolenopsis that we sampled, we collected off Tasmania. So this raises some really interesting questions. Is this parasite just really widespread, and perhaps we just haven't sampled enough fish around Tasmania to know that it also occurs down there as well? Or perhaps some of these ctenophores are actually being advected south on the East Australian current. So maybe they originated up on the Great Barrier Reef and are being advected further south. So these parasites can also be used to ask and potentially answer some really neat ecological questions as well. Okay, so gelatinous zooplankton host a really rich and diverse endoparasite fauna. Digynians in some gelatinous zooplankton correspond to parasites that infect fishes that we already know prey on jellies, or for which predation on jellies is plausible. But in other cases, the Digynians indicated potential novel trophic relationships. So we think that parasites are really useful for tracing predators of gelatinous zooplankton, but there's actually a lot of work that we really need to do in this space to confirm their use as a tool. So the specificity of the relationships is often unknown, okay? We don't know what we haven't yet found out, okay? So determining specificity can be quite tricky. We also don't know how long the parasites live within the host. So quite often it's periods of weeks to months, but this hasn't been confirmed, certainly for the parasites that we've been looking at. But if we can get in some information on that, it'll be really useful for telling us things such as, potentially the time window in which the predation occurred. And it could also be useful for looking at things like ontogenetic shifts in the diet of the predator. Okay? And there are also other questions. Does variation in the prevalence and the intensity of the infection in the fish reflect predation rates on gelatinous zooplankton? So if the fish are really heavily infected with the parasites, does it mean that they're eating more of these gelatinous prey? So overall, we think that parasites hold a whole lot of potential to be really useful indicators of trophic relationships involving jellies, and they're another tool that we can add to the toolbox for elucidating these trophic links. Thank you.
Thank you, Kylie. A very interesting talk. Any questions? Yes.
Hello. I'm working on Digynians too in Italy, and I have a question. I checked for Digynians in all the species of jellyfish. The prevalence is like 100% in Italy. But now I was looking in fish to find the definitive host, but I never found any Digynian. But all the fishes that came to me in these preliminary analyses were adults, so commercial size. Have you found any differences in terms of size of the fish? Because that sometimes some species are more live some periods of their life, maybe the juvenile phase, in association with some type of jellyfish. So maybe small juvenile have more because of this association compared to adult one that maybe prey on, how can I say, better prey.
Yeah, interesting. So I'm surprised you haven't found any digeneans in the fish. So that's.
I found some
Oh, you found.
digeneans, yes, but no one of what we found in jellyfish.
Oh, okay, I see.
So
Yeah, I mean, I guess when they're associating with the jellies, I mean, a lot of the fish that associate with jellies as juveniles do also eat jellies, so that's a good way in which they might get infected. But that's also indicating predation, I guess. No, I mean, some of the species of fish that we looked at, so Monodactylus, for example, definitely adults. So that indicates, I think, more like a true predatory relationship rather than being incidental predation when they're associating as juveniles. And also, I think the lifespan's something to consider there because, you know, the lifespan of the digeneans is probably on the order of weeks to months rather than years. So I do wonder whether an adult fish would still retain the digeneans that it's been infected with as a juvenile. I'm not sure. Yeah.
Okay, thank you. Maybe I'll ask something else later.
Sure.
Thank you.
Thank you for your talk. I was wondering if it also could go both ways, because here you looked at fish as the predators, but could the parasites be passed on by jellyfish feeding on like fish larvae, for example?
Well, typically the fish are the definitive hosts, and I guess you can look at that by determining what life history stage of the parasite that you're looking at. I'm not a parasitologist, but my understanding is that the vertebrates tend to be the final host in the life cycle. Yeah.
Okay, thanks.
One at the back, Luis.
Yeah, super nice talk, Kylie, thanks. I was wondering about your intensity ranges, like how is the intensity in the samples you had? Because apparently you have a very good a wide diversity of animals, but is the intensity similar in them? And then just quickly also on mixed infections, did you have many in which you had different species of?
Yeah, so our intensity of infections probably about 18 to 20, I guess. But I mean, you know, it varies depending on what size animal you're looking at. So mostly we were sampling quite small things, so hydrozoans, that sort of thing. I think it's less than what I read in your abstract with what you see. And second question was, sorry?
About mixed infections.
Oh, yeah.
Then it's completely related to the trophic, right?
Yeah.
So if you have two different parasites in the same
Yes,
host.
we did. Yep. We did have some incidents of that, so, yeah.
Are there any other questions? One, Dougal.
You were also recording the sizes of the individuals of each species that was parasitized along with the parasite load.
Yep.
And so you can compare to the size of the mouth of the fish and other things like this.
Yes, absolutely. So, I mean, often the fish are just eating bits of the jelly. I mean, it depends upon what species of fish it's grazing on. But things like Monodactylus have got really small mouths, so they're probably just taking bites out of Pleurobrachia.
So, yeah, Pukia.
Pukia, sorry.
The parasites are embedded quite deep in the mesoglea, and Pukia you can almost drop and they bounce, so it would be really hard to peck bits. So that was exactly what I was thinking of when thinking about the sizes.
Yeah, that's right. Look, they weren't always that deep. They were pretty variable where we found them in Pukia. Sometimes we even found them in the tentacular sheaths. So yeah, I think it's definitely possible that they could be that things like Monodactylus could be extracting them from Pukia. So.
Okay, we'll accept one last because this is before tea. So there's a gentleman over there.
Great, thank you. Excellent talk. Do you think that these parasite infections could be a potential mechanism for ending jellyfish blooms, like if they're density dependent, or
Well, from what we saw, no, because I think they have basically no effect on the jelly. So not these digenians; they're so tiny. Louise is going to talk about some higher infection rates, so he might have some different ideas. But certainly with what we saw, I would be very surprised if these parasites were having any effect. And look, the digenians seem to have very minimal effect on the fish hosts as well. So they've got it sorted. They don't kill their host, which is quite clever. So.
Thank you.
Okay, with that, thank you very much, Kylie. This brings an end to the first half of this session, and we have a tea break, Mike, of how long? It says 30 minutes on my sheet. Okay, 30 minutes, people. I don't have a watch. Kylie, what is the time now?
It's 10 past, so
10 past 4.
Yeah.
There we go, people, 22. Please do not be late.
Okay, everyone, welcome back to the last session for today. We're almost at the end, and just 3 talks to go. So I'd like to welcome Rias Abdul, who's going to come up to the stage now. Hopefully Rias is here. Yes, here he is. Good. Come on up. And Rias is going to be talking to us about evaluating environmental influences on Acromitis flagellatus jellyfish blooms in southwest Indian backwaters and estuaries. Thanks, Rias.
Okay, thank you. Good evening to all. I am Rias Abdul. I am from the University of Calicut, Kerala. Today, I am going to present one of my research. Title of my presentation is Evaluating Environmental Influence on Achromatid Flagellatus Blooms in the South-West Indian Backwaters and Estuaries. As we know, jellyfishes are the very adaptable, incredible creature in the world. We did lot of work on jellyfishes related its importance, its manners, and its other activities regarding jellyfish. Jellyfishes are the key components of many of the estuarine aquatic system. The high population of jellyfish in the estuarine waters can alter the food web. Increasing population of jellyfish will change our ecosystem and it affects our ecosystem badly also. It also reduces the food source for fishes and other vertebrates. With the increasing anthropogenic invention and the climatic change in the estuaries, the number and impact of jellyfish create a lot of problems. Jellyfish blooms occur seasonally or randomly. They appear and disappear responses to environmental changes. Today, we are discussing about a jellyfishes. It's living in backwaters and estuaries. That is, Achromatid flagellatus is a small, conspicuous, less studied, easily recognizable rhizostome jellyfishes belong to the family Catostylidae. In India, the blooming of Achromatid flagellatus create a menace for fishery by clogging the staking nets and hindrance to the aquaculture activities. Jellyfishes blooms and their dynamics have not been studied in detail in India. More specifically, details of species involved, seasonality, and impact on commercial fisheries. Coming to the major objective of my study, to document the jellyfish blooms and their dynamic in southwest Indian backwaters and estuaries, to understand the relationship between jellyfish blooms and hydrographical parameters, to study the socio-economic impact caused by jellyfish blooms, especially the Achromatid flagellatus in the backwaters. Coming to the methodology, jellyfish abundance was recorded in pre-monsoon, that is from February to May, and post-monsoon season, that is November and January, from 2016 to 2019. Abundance were measured through using visual count and net count. The visual count was done in 3 into 3 meter areas. In the same area, we are chosen for the net count also. We have chosen 12 stations in the south-west coast of India, especially in Kerala. The abundance we have measured by the number of medusa per 9 meters square. We checked the hydrographical parameters, water quality data that were collected monthly, water temperature, salinity, that chlorophyll A, pH, dissolved oxygen, nitrate and phosphate are recorded seasonally. Alkalinity was checked using titration method, standard titration method. The statistical analysis was performed, that is principal component analysis was performed to understand how abundance of jellyfishes is influencing on the season. Environmental parameters, namely salinity, dissolved oxygen and silicates were orthogonal with the abundance of jellyfishes in the principal component analysis. The statistical analysis were performed using the software PAST 4.10. These are the images of jellyfish, that is Achromatid flagellatus bloom in Kerala coast. Coming to the result, the seasonal abundance of jellyfishes bloom, that is from 2016 to 2019, jellyfish bloom is increasing. And in the graph, we can clearly see that in 2018, that in pre-monsoon, jellyfish's bloom is more. In pre-monsoon season, here, jellyfish's bloom is more compared to the post-monsoon season. The abundance of Acromatus flagellatus is predominant during monsoon season in the northern part of Kerala, that is Kannur, Kasaragod, that region, and bloom were more during pre-monsoon in the southern part of Kerala, that is in Kochi, Alappuzha, Kollam, and Trivandrum. The hydrographic parameters noticeably variation in post-monsoon and pre-monsoon season. In 2016, water temperature increased from 29.55 degrees centigrade in post-monsoon to 30.14 degree in pre-monsoon. Not much variations have been noticed in salinity in post-monsoon and pre-monsoon, but both of the season, the salinity is suitable for jellyfish's bloom. That is around 20 to 25 ppt is suitable for Acromatus bloom in Kerala coast. Chlorophyll concentration was higher during post-monsoon and its declined during pre-monsoon. Nitrate was high in the post-monsoon season and declined sharply in the pre-monsoon season. pH was highest in the pre-monsoon than in post-monsoon. Dissolved oxygen sulfate and phosphate not show any specific variation in our analysis. The principal component analysis, we can clearly show that the component environmental parameters such as pH, temperature, nitrate, and chlorophyll have a positive correlation with the jellyfish blooms. The multiple regression of jellyfish abundance and environmental variable, here we can clearly see so that the temperature, chlorophyll A, nitrate, and pH have a good correlation with the jellyfish bloom, that is Acromatus flagellatus bloom. Coming to the impact caused by jellyfish bloom, Acromatus flagellatus along our coast. Acromatus flagellatus causes a severe nuisance to the local fishes and fisheries of Kerala by clogging the fishing net. It's a serious issue in the backwaters. The backwater fishery is not much developed in India, but the clogging of this net or other activities or other menace cause lot of income loss in traditional fishers. Jellyfish sting irritate the fishers during fishing and cleaning operation activities. Some of the few reports indicated that bloom of Acromatus flagellatus also cause severe menace or severe problem to mussel farming in the estuaries of northern part of Kerala, especially Perna viridis culture. Coming to conclusion, the study recorded the bloom of Acromatus flagellatus from the various estuarine waters of Kerala from 2016 to 2019. More blooms were noticed in the pre-monsoon season than in the post-monsoon season. Abundance of Acromatus flagellatus was more in the estuaries of northern part of Kerala during post-monsoon season. At the same time, in the southern region, the blooms occurs from the pre-monsoon until the first set of monsoon. Environmental parameters such as temperature, chlorophyll A, pH, and nitrate significantly affect jellyfish abundance. The relation between the jellyfish blooms and the environmental parameters not only on reason for jellyfish bloom. So we need a detailed study on origin, distribution, life cycle, ecology, trophic, and impact on estuarine ecosystem and services. We need to study more about impact of blooms on commercial fisheries and larval development of fish species for our sustainable fisheries. I sincerely acknowledge Kerala State Council of Science and Technology and Environment and University of Kerala. In addition to that, I thank my guide, Professor Dr. Biju Kumar. He given an opportunity to do with his guidance. Thank you very much.
Thank you, Rias. Do we have any questions for Rias? Connie?
Hi there. Can you hear me? Okay. Just wondering about, you said about the mussel farming that it had an effect, jellyfish had an effect. Was that just in terms of operations, or were the jellyfish actually affecting the mussel stock, do you know?
This is not a serious issue here. It's a very little bit of farming of mussel, that is pernaviridis is going on. That culture people, especially the women, they are said that that interact or the hindrance to the cages and that farming areas, and it's causes serious death of mussels that they are told. Yeah, so seriously affected. Yeah.
Thank you very much. Very interesting and nicely presented talk. So I was wondering, do you have any idea about the settling sites of the polyps? And do you also know from back in history, old fishermen records, if the incidences increased over the past 10, 15 years, or if this is a new phenomenon outside your 4-year sampling period?
Oh, you are asking about the polyp. Yeah, I did a study on their polyps and life cycle, and I got most of the stages of jellyfish polyps. So I am trying to do lot of work on life cycles of jellyfish. That only we can conclude how it's bloom here, what are the other parameters affect on their growth. So we will do a future research on life cycles of Acromatus flagellatus. It's also good for aquarium keeping also. We tried the aquarium maintenance of this Acromatus flagellatus, so we have a good future for that Acromatus flagellatus.
We've got a question from Mark up on stage.
Yes, thank you very much. An interesting talk. Have you stopped sampling? Is your study carrying on, or was it just that period?
No, it's going on.
It's still so that you're continuing to collect more data?
Yeah, needed to. This is only a preliminary study. We have to check the environmental parameter, how it's affect. This only I am tried this time. We will continue more research on the impact, trophic level interactions, and the life cycle also. About the
but I was meaning the collection of the time series.
Yeah,
so the time series that you've established from the nets. Is that collection of data continuing?
Yeah, it's continuing. Yeah.
Mike?
Thank you, Riaz. I think you have several sites along the coast. Is that correct?
Mike?
Yeah, you have several sites along the coast which you'd sampled. Correct?
Yeah.
But I think you showed just the totals for each of the years. So do you find the same patterns happening at each of the different sites?
No. The pattern is different in different region. I said before, in southern part of Kerala, that is bloom is happened in the from January or February to March or April. In the northern part of Kerala, the bloom, now it's blooming season. That from November to December or November to January. That's a pattern of blooming is different from south, middle, and north of Kerala.
Yeah, okay. That's great. So if you were able to look at your local abundances versus the local parameters, you might get a little bit more power of trying to work out what's causal or not there.
Recently at the Hydrozoan conference in Bergen, there was a very interesting presentation where what they thought was the same species, which had its abundance peak at a different time of year, was actually 2 different cryptic species. And I wonder if you could maybe look at the molecular markers for those 2 populations blooming at different times to see whether they're really the same or if they're cryptic species or not.
Okay. In our pictures, you can see a lot of color variation in Acromatus. We also did the molecular studies from different regions of Kerala. We concluded that there is no genetic variations, all are same in Acromatus flagellatus. We concluded that all collections are Acromatus flagellatus. That's available in our coast.
So for every season, animals from every season you have done also?
Yeah.
Okay, thank you.
Okay, if we have no other questions, we'll move on. So thanks very much, Riaz.
Okay, thank you.
Okay, Okay, so we've now got Gregorio Motta coming up to the stage. So Gregorio is going to talk to us about the hidden gastrovascular system of the rhizostomes, so innovative methodologies of study.
Hello. Okay. So yes, as my title suggests, today I will talk about the new method we invented for the analysis of the gastrovascular system of rhizostomae, but we hope that it can be extended almost to every jellyfish. Talking about the order Rhizostomae, we know that this order is characterized by a more complex body anatomy compared to other jellyfish due to the presence of their massive manubrium over here. It's not working. To the massive manubrium, which their oral arms, which is filled with multiple canals and oral openings. We choose this species because despite these two species, Rhizostoma pulman cotyloryza tuberculata, are really common in the Mediterranean Sea, and despite they've been one of the most described jellyfish, at least for the Mediterranean, in fact, both species have been firstly described in 1778 by Macri. At the moment, there is no actual description, high-defined description about the gastrovascular system. In fact, what we have is this. On the left, this is what is now the most detailed description for a Rhizostoma specimen. This is from a Rhizostoma octopus, did by Russell in the 70s. While on the other end, the other picture is a scheme for Cotyloryza tuberculata made by Kickinger in 1992. As we can see, the umbrella is much detailed, but the description about the gastrovascular system in the manubrium is totally lacking. And this may be due because, as we've seen like yesterday and today, jellyfish science has changed over time, but the study of jellyfish anatomy always relied on the same techniques for centuries. So stain injections, external observation, dissections, and so these are the results that usually you can obtain. But these techniques are really limited by the thickness, the opacity of tissues, and we know that Rhizostomae have these tissues that maybe in adult are really thick, really opaque, so it's really difficult to see properly through. So on this base, what we wanted was to create a modern protocol for the investigation of the gastrovascular system of these species in order to get a high definition, a better definition of the details compared to the older studies. And then we also wanted to check the circulation inside this complex gastrovascular system in order to see if there is a peculiar physiology about the circulation of these organisms. So what we did, we sampled organisms from all around the Mediterranean Sea, but today we report only the data from the Adriatic Sea, so what we see in the box. We injected jellyfish with epoxy resin, then we waited for the resin to harden, and then we digested the tissue to reveal the cast. And after that, we wanted to integrate that with a micro-CT scan. A micro-CT scan is when your sample is hit by X-rays. Yesterday, a speaker told that no one ever did an X-ray to a jellyfish. We tried. And while the sample is rotating on a platform, multiple 2D layers of this sample are made, and then after that, with this stack of 2D images, you can process everything together to get what is called a 3D volume render. So what we obtained is this. This is how a rhizostoma is made inside. On the left, I put the Russell description, that is the most detailed one up to now, and this is what we obtained with our resin endocast on the left. As you can see, the resolution of definition of details is uncomparable compared to the other studies, while on the right is just the micro-CT scan of our resin endocast. Clearly, on one end, the resin endocast also, and much more the scan, can allow us to study hidden areas of the jellyfish that are impossible to watch with traditional methods. And also with the scan, for example, this central area, that is the remnant. Usually here there is, as you can see in the small box on the B picture, there is still the phyra mouth that is still open in juveniles, and then has been just described to close up. But then looking at our results, what is really happened is that the pore just not close up, but this tube is developing and then is connected with this multiple branching. So at least this is something different that we have found. Clearly, with the scan, you can mask everything you don't want in order to highlight the part of interest. But even more with the scan, what we can do is to get quantitative data from the software analysis scan. So what you see on the B is what is called a skeletonization, that is mostly a schematization that is usually done in geology, this kind of study, but thanks to other people, we can adapt their scripts, their analysis to our cast. And from this, you can have, as I said, quantitative data, for example, the length of the canals, the thickness of the canals, the number of branching, and also the oral pore, what is called the terminal ending, so actually the oral openings of the species. This is just graphical outputs of what you can obtain in terms of quantitative data about length, frequency of length, of thicknesses, of all the part of interest one chooses to investigate. And moreover, one interesting data is that Russell once tried to count the mouths on the oral openings on rhizostoma, and he said that there are hundreds of them. But in this small rhizostoma, it was just 15 centimeters of diameter. We counted with the software 4,000 openings. So it is 10 times more at least. Also, the resin endocast has been a sort of inspiration for other analysis, because in the Russell, all the channels are seen as a huge single canal. But what we can see here, for example, in the red square, the laser is, now is working, no, it's not working. Like this one is the sort of double canal that we found in position of the single canal. And so we asked ourselves why these two canal system and not just one. So that's why we wanted also to integrate that with the circulation analysis. Clearly, we also do some dissection to check, and what is really inside the oral arm of a rhizostoma is this figure-8 canal. So with these two openings separated by a slightly tight junction between them. So we went back to the traditional method, so with the stain injection, and we injected in the stomach of rhizostoma vital stains such as methylene blue and neutral red, and then we followed the circulation inside the jellyfish. What we've seen in the umbrella, that is schematized then down in the picture A, is that all the centrifugal circulation only occur in adredial canals, while the perradial and interradial canals are assigned to the centripetal circulation, back to the stomach. The perradial canals actually flew down and went down to the manubrium and connected to what we see to the double canal that I just showed you. And what was astonishing was the fact that only the outgoing flux from the jellyfish was only following the external double canal inside the oral arm and was expelled only by the external part of the oral pores on the oral arms, while the inner part never got stained. So we tried to do a combination of stain inside the stomach and stain outside the jellyfish. That is what you see in the left picture. And on one end, you can see that, with the pointer would be easier, but it's not. And you can see that the stain is coming down with the upper one from the external canal, that is the one coming down from the stomach, while on the left, there is the stain that is uptaken, but the inner mouth, while the outer mouth, that are the half part, are still totally clean. And so what we see that was astonishing was that, at least in rhizostoma, there is this differentiation of the fluxes with a differentiation of the functions of the oral openings. So we have some openings that are assigned only to the intake of water, or pumping in water, and other openings that are only for outtake. And this was astonishing because, always talking about jellyfish, there is this concept of the single pore that all flux in, all flux out, so that works in both directions. But in this case, at least for rhizostoma, this system could really resemble what we find in much more complex digestive system in much more complex organisms. So shifting to Cotylorizza, I don't have the scan for this species because bureaucracy time in Italy takes forever. And so I just have the resin endocast. This is the cast for Cotylorizza, sorry. We can see that much more different from rhizostoma is the number, for example, of the oral openings, so the termination are much more numerous. And also the oral arm is much more flatter compared to rhizostoma. Here we don't find that double circulation, that 8 figures, so well defined. The cast allowed us also in this species to find something never described. For example, these sort of bridge canals between the 4 oral arms is never been described before. We don't know at the moment what is used because it's so thin, connecting oral arms that are so huge, but maybe we will find a reason for that. And going back to the circulation, at least in the umbrella, the circulation was almost similar with the adredial canals that are the ones that start with the centrifugal flow, with a huge difference in terms of speed of the circulation. In fact, if in rhizostoma to fill all the umbrella, it took 15-30 minutes, to fill a umbrella of cotyloryza, it took hours. And we still don't know why. While going down to the manubrium circulation, what we've seen is that, like for rhizostoma, also in cotyloryza, only the external canal is the one that remains stained. It's not so clear in this picture, but below the blue canal that is highlighted on the upper part, there is the inner canals that is totally clean inside. And also we did some dissection after the stain was passed through the canal, and we can see that the external part, the external canal, also in cotyloryza, is the one that is ejecting the fluid because it's the only one that remains stained, while all those the thin layer that is on the right, that is the internal part of the canal, is totally clean. So also for cotyloryza, this double entrance, pass me the term, this more complex terms of gastrovascular system is present. Clearly, so concluding, on one hand, we know that all these traditional techniques were so limited for adults, for sometimes kind of species. Is not maybe a problem for Aurelia that is so transparent to address the umbrella, but when it comes to rhizostomy, there are really limitations. So on one hand, our endocast solved this limitation, as you've seen, to provide this three-dimensional information. And furthermore, it's really cheap and easy to reproduce. It's not so difficult to find, to produce an endocast like this. And the cost of the materials is like 20, 30 euros, so really nothing. It's different for the microcity data that clearly it can, integrating with that, we can give us all these quantitative data like the volume, the length, the thickness, the number of the canals, the look for inaccessible areas. This analysis is more expensive. It's like a couple thousand euros for our rhizostoma. But at least the endocast can really be produced everywhere. And also the good for the 3D render is the fact that we know how much difficult it is to send samples for the anatomy studies around the world, because you find samples, jellyfish that are damaged, there are missing parts, that are a little bit deteriorating, even if fixed. Once a scan is done, it can be really shared through the world without any issues of the transfer of the knowledge, of the information. Going to the physiological one, clearly this physical separation of the currents that had never been described before, with this differentiation of the openings, assembling much more complex digestive system, was for us at least astonishing in the first place. And shifting this structure to the physiology, maybe since this connection, this circulation can be continuous, because this opening with different function can really sustain a continuous circulation inside the jellyfish, this may be the reason, maybe on one hand can advantage these species in terms of predation, in growth, in fitness, can sustain higher metabolism. In fact, rhizostomy are one of the orders of the jellyfish that are much bigger in the seas. Maybe this system can facilitate then and sustain these sizes. And also, just to conclude, clearly the comprehension of the gastrovascular system and the circulation is fundamental if you want to understand the physiology and the position of jellyfish inside the trophic webs, because if you want to know how this jellyfish works towards the outside, so towards the trophic web, we also have to know how the jellyfish works inside. And so clearly having a complete picture is the best way. For this, I want to acknowledge Professor Massimo Avian, that shared with me his long-time knowledge about jellyfish anatomy and all he knows. Professor Terlizzi on the left, that has been my supervisor of my PhD, and all the other researchers that allow this product, this work to be done. And I want to thanks everyone else helped, and I want to thanks everything of you for the attention.
Oh, that is so cool. Any questions? Carolyn?
for your talk. I had a very practical question. How do you inject the resin in the jellyfish? Is it still alive? I was impressed how it went to already every canals on the 3D scan. So how do you technically manage that?
Has been like a journey of trial and error, because at the beginning, clearly all this specimen was formalin fixed. We prefer to use like a 10% to have the organism, the jellyfish, a little bit more stiffer in their tissues, because if you try with non-fixed formalin, non-fixed individuals, maybe the pressure of the resin can can dilate some tissues, and if you just do one hole inside the jellyfish and you put the pressure from the injection in the stomach, clearly all the stain, all the resin goes outside that hole. So we tried different densities, different concentrations of the resin, because they have to be fluid enough to spread everywhere, but not so much that falls out, and not too low, because if that, it can break the tissues. So it's like really a trial and error, and you find the magic recipe.
Okay, so you're the only person on this planet that can do it at your level, right?
Actually, we are two, because also Professor Ravian did it with me. So.
Okay, good to know. Thank you.
Before it passes over, can I just ask? Can we beg you to do a Facebook thing that you can share with everybody?
What?
Or a YouTube.
Yeah, we wanted to do the next step would have been also showing the jellyfish shifting clearly in a video to the cast, and maybe also showing maybe the circulation inside. But the problem for this kind of cast is the size of the virtual image, because for example this cast is around 30 gigabytes for the 3D cast, and so usually for visualization analysis you need 4 or 5 times RAM memory for normally process everything. So you need a computer that is really a working machine that is really strong. In fact, we collaborated with Electra, that are physicians, that has these working machines that are incredible. But that would be one of the next steps, if we find someone that can sustain this amount of data processing, because it's not so... The picture is easy to share, but at least my idea of the complete picture is heavy.
Okay, one last question.
Yeah. Hi, thank you. That was really good.
Okay, sorry.
So I just want a clarifying question. So if I'm imagining food going in, you said food or material enters on the
Inner part.
Inner part, okay. And then it circulates around through the stomach, then around through the outer part, and it exits through separate canals. So are the canals that are going in, are those more central or more peripheral?
The picture is, no, this is not my presentation, sorry. If you think of a jellyfish, the inner one are the one uptaking, and these that maybe have also sensor, because if you think that usually the oral mouth is in the center. So this huge part is the one that is assigned to the intake, with the one of the 2 8-figure canals, with one of the hemicanals, let's call them like this. This is pumping up the water to the stomach. Then from the stomach it goes around the umbrella, and just some canals from the umbrella go back to the manubrium in the external canal this time, and then is expelled by the external parts.
So cool. Thank you.
No, you're welcome.
Okay, thanks, Gregorio.
Thank you.
Okay, I'd like to welcome our very last speaker for today to the stage. So Samir El-Jabor, and Samir is going to talk to us about differential effects of PAR, photosynthetic active radiation, and UAV on Cassiopeia andromeda, jellyfish respiration, oxidative stress, and photosynthesis. Thanks, Samir.
Yeah, so good evening, everybody. Yeah, I am happy to close the session today, and I will try to be very brief. And yeah, so in this presentation, I will continue actually talking about the captivating worlds of jellyfish in general and rhizostomes. My colleagues, they preceded me about talking about the jellyfish, about the regeneration of the jellyfish, especially the Cassiopeia, focusing on Cassiopeia and the asexual reproduction of this. In this presentation, I will focus more on the contrasting impacts of different light types, especially the PAR lights and UVA lights on three vital aspects of jellyfish physiology, which are the respiration, oxidative stress, and photosynthesis. What I want, okay. Anyway, first of all, I want to introduce actually Cassiopeia. I know almost everybody now know Cassiopeia, but I wanted to highlight some of the roles of Cassiopeia in its environments. So when you see Cassiopeia from a macroscopic level, you see that the Cassiopeia is just what's going on. It is always bumping, beating like this, and it was found that by this action, actually, no, even this does not work. I don't know. Do you have, sorry, pointer? Or? Here. Okay, so by bumping, by this contraction, the concept contraction and relaxation, the Cassiopeia, this movement actually pulls the water in the pore, in the sediments, and release it to the water column. So by doing this, it helps actually in enhancing the sediment water column exchange of a nutrient. And it's most obviously actually also this is the jellyfish here has this symbiotic dinoflagellates, which is the main role is photosynthesis, and photosynthesizing organism usually they oxygenate the environment actually, and they help in the nutrient cycling. So these two partners, the jellyfish and the dinoflagellate, actually they collaborate with each other. So as you know, the jellyfish provide the inorganic material or nutrients, and the dinoflagellates in return provide the photosynthate, which has been found that this photosynthate can be enough to support the whole life of the nutritional need of the jellyfish itself. And the second player in this presentation actually is the UV, is the light. So as you know, the sunlight is composed of the electromagnetic spectrum, but we will focus here on the PAR light. PAR and PAR stands for the photosynthetically active radiation, and UVA and UVB. And now I will focus, actually, I'm focusing in this presentation on the UVA, but I want to introduce that some aspects are different, really totally different between the UVA and UVB. Actually, in the previous work, we have worked with the UVB, and now we are continuing with the UVA to see its effect per se. So the energy content, the UVB is shorter wavelength, and so it has more energy content. And the abundance in the solar energy, the UVA actually could account for almost 90% of the radiation. And the water penetration capacity, so the UVA penetrates ways farther than the UVB. And the biological role of a UVA in contrast to UVB. Now, when we talk about the UVB itself, most of the biological aspects, effects, they are actually considered negative, like DNA damage and the reactive oxygen species initiation, and this so forth. So the UVA roles, they also share with the UVB the initiation of a reactive oxygen species, but also they have this role in activation of the photoactivation enzyme. So they actually help in repair mechanism of the reactive oxygen species induced damage of the tissues. And also, they can initiate lipid pair oxidations. Now, just to highlight that in the normal cells, when the cells is attacked by free radicals like superoxide or hydrogen peroxide or the other free radicals, the cell with the oxidative stress at the end, they will commit suicide through apoptosis or necrosis. So it's deleterious for the health of any cell, actually. So the objective of this study actually we asked the question, how does UVA combined with different bar levels affect the Cassiopeia jellyfish? And for this, we measured actually the growth and the oxidative stress, respiration rate, and photosynthesis, and these all to assess the performance of the jellyfish under these varying light conditions. And for this, we performed this experiment. We performed this experiment for 18 days, and the number of organisms, they were 6 organisms per treatment. So first, we begin with the low bar. So we treated the organism here with the low bar only, and here we added the UVA. So this will tell us if there is an effect of the UVA on the jellyfish. Similarly, here we use the high bar and the UVA. And for this, we measure these physiological the parameters. For growth, we measure the bell diameter and its mass as well. And for the respiration, we measure the electron transport system. This is in the mitochondrial level. And for the oxidative stress, actually, we took the biomarker of effect, which is the lipid peroxidation. And And for photosynthesis, to assess that, we measure the chlorophyll A content in the jellyfish. And here we come to the result and discussion. And so here, the first result, actually, we found that there is no significant difference in the mass, neither in the diameter of the jellyfish. And this means, actually, that the jellyfish, they grow. At first, I want to highlight that all jellyfish have shown significant growth. So they all grow, but there were no significantly different differences in the growth between the high bar, low bar, UVA, or non-UVA treated jellyfish. Here, I want to highlight that there was a significantly positive correlation, linear correlation actually, between the bell diameter and jellyfish mass, and this is expected, but here I presented here to show that they were actually in the linear phase. So what happens so the jellyfish were smaller and then they become bigger, so this is significant growth, just to highlight more. And the protein content, because usually in these enzymes, when we measure them, I always try to double check when I normalize it to body weight or to protein content, actually to avoid the possibility if that this organism actually is growing more by incorporating water or not. And we found that similar protein content. So in the following slides, actually, I choose to represent my data, my results, for the body weight, because it's easier to figure out from the first when you see it. But actually, I also normalized the results for the protein content, and they were exactly the same in terms of significance. So they are actually, two faces of the first coin in this case. So the second result to answer this question, does UVA affect the jellyfish respiration and photosynthesis? I want to highlight here, when we found that there is no effects of the UVA in the two-way ANOVA, we grouped out actually the low bar versus the high bar. And here we found that the high bar, the low bar, they are respiring more than the high bar organism here. Similarly, in the chlorophyll content, actually, we found that the low bar as well, they have more chlorophyll content. And this was obvious from the first week, actually, in this picture. Hopefully, it is obvious. So the jellyfishes in the left side, they became darker, actually, compared to the lighter ones in the right side. Yeah, but we found also interestingly that there is a positive correlation between the respiration and the chlorophyll A contents. So UVA actually did not modulate the PAR mediated respiratory or photosynthetic response. And the PAR intensity in this indicated that it is the main player shaping the respiratory and photosynthetic response. Now when we come to the oxidative stress and lipid peroxidation response, we found here that at the low PAR, with and without the UVA in the left side, they are almost not significantly different at all. Actually, the p-value was about 0.9 something. But in the high PAR, we found that the UVA, the lipid peroxidation, which is reflective of the oxidative stress magnitude here, was in the low PAR ways lower than the high PAR. And in both high PAR with UVA or without UVA, it was actively significantly higher than the low PAR. And we found that the interaction between them, the UVA and PAR, is highly significant. So this indicates that actually the UVA played a significant role in inducing the oxidative stress, particularly at high PAR levels. Yeah. In conclusion, but before I conclude, I want to revise this very common graph, which is correlate the performance of any organism to the environmental factor gradient. So in the middle, actually, we found usually the zoom or the zone of the optimum performance, where the organism is happy here and it reproduce and grow and do everything. Plenty of energy available for this organism at this region. But when we go in the other toward the maximum and the minimum, the organism enter the zone of physiological stress, where less energy becomes available for reproduction and more energy is being allocated to survival and maintenance and repair mechanisms. And when we go further, the organism will die because it entered the zone of intolerance. In this presentation, in this experiment, actually, we found the organism, all the organisms, they stayed in the green zone. And this clearly indicates that the organism were not stressed enough to enter the physiological stress zone. Yeah. So to conclude, the UVA has non-significant roles, if any, actually, in Cassiopeia physiology. The PAR intensity is the main determinant of a normal Cassiopeia physiology. And Cassiopeia is resilient to varying light conditions. And last but not least, I want to thank everybody who helps, especially Muhammad Hilmi. He was an intern from the university, from the National University of Singapore, and the Seymour team in KAUST University. And thank you very much for being patient to stay until the end and hear this presentation. Thank you.
Thanks, Samir. Do we have any questions?
Thank you, Samir, for the interesting presentation. I have a question. When you talk about low and high PAR, which were the actual value of the PAR, like in micromole of photon?
Yeah, I use actually the term low and high just for comparison. But low PAR, I used almost 100 micromole, and high PAR, it was 500. And to be honest, we wanted to go more in the aquarium, but this is sometimes very difficult when you use this LED to go down, because I use actually the quartz because this is UVA. I did not mention, but when you're using or experimenting with UVA, you need to use this quartz flask or beakers, and they were big like this. So always I need a distance at least to that I can catch them and bring them and change them. So this was almost the maximum to that we can reach.
I've just got a follow-up question there, Samir. So how did the PAR and UVA levels relate to what the animals actually experienced in the field from the position where you collected them from?
Can I ask you please to repeat?
Sorry?
Can you repeat, please?
Repeat. How did the UVA and PAR levels relate to what the animals were experiencing in the field? So when you collected them, did you measure those levels, and do you know what their normal levels are?
Yeah, actually. I mean the Cassiopeia in the Red Sea, we found them, I found them everywhere, even in the depth of 30 centimeters and, less. I measured these values, actually, they were related to the field, the UVA especially. I measured the UVA at depth of, if I remember well, at depth of 1 meter and at depth of 3 meters. But to highlight here, I mean the depth is not really standard or a rule of thumb because the water clarity affects the UVA absorption, and bar, as you know, it's totally different actually. How they relate, I will say they relate maybe, in the field, the high bar was almost, if I want to describe it in the field, I will call this high bar medium bar. Not the high bar, actually, because the high bar, it's really much. So I will say medium bar, but just I prefer to use high versus low bar for easier comparison.
Any other questions?
Yeah, so great talk. I was just curious, I think I just missed it. What size for the Cassiopeia medusa did you use? And because there's another paper I've read before, is that it's only the larger Cassiopeia that is able to sustain itself within its symbiont, while the smaller ones, they have to rely on the feeding to grow. So what size for the medusa did you use?
Yeah, actually the size I choose, and I would always choose actually, it's the size between 2 to 4 centimeters. Because this organism at this size, usually it grows linearly. Because if you choose bigger sizes, they will enter like another phase of growth.
Hello. Do you think the optimum will be the same on the polyp phase?
Actually, I don't know. The optimum of what you mean, the light?
The last graph that you showed, you talked about the optimum of the species, I think on the medusa stage. So maybe it can be the same also for the polyp stage, or not?
Yeah, I mean the last graph I showed, this is the optimum, and the minimum, this is like a general scheme for all organisms that for any environmental factor, there is like an optimum and minimum. And I showed this graph actually to show that this organism, they still in the green zone. They did not degrow, or they did not actually shrink, because jellyfish, sometimes when they are stressed, and we have shown that, in papers before, that they degrow fast when they are really stressed. So for polyps, I think they are really totally different from the medusa stage. So for sure, they will have different responses. Yeah, hopefully this answer.
Okay,
maybe.
one last question.
Hi, Samir.
Hi.
Here. Nice presentation. I was just wondering, in one of your graphs, you have indicated that high power reduces the chlorophyll, but in the low power, the chlorophyll was very high. So this is something like reverse to what we are finding in nature. So what might be the reason?
In the high power, usually the organism, they do not, there is plenty of light. So with little number of zooxanthellae and the chlorophyll content, they have enough energy. But at low bar, the intensity of the light, the energy that is found in the low bar, it's less. So the organism need to compensate for that by increasing the number of the photosynthesizing apparatus, which is, in this case, the zooxanthellae, actually. So it's like it is just like a compensatory response.
Okay, well, thanks, Samir.
Thank you.
Okay, so that's the end of the session. So I'd like to thank all of the speakers in the session today, and we'll continue it tomorrow. And I assume that Biju,
yeah, there is.
You got announcements?
Yeah. Our heartfelt gratitude to chair and co-chair and West Rapporteur for conducting this session nicely. We had an opportunity to honor the chair and co-chair, Kaylee and Gibbons, yesterday, and now we can honor the co-chair, Mr. Saravanan, with a memento. I request the chair to honor him. I request Kaylee to honor him with a memento. Thank you. Biju, any more announcement? Yeah.
Thank you for the long day today. Thank you all, the chair, co-chair, and the rapporteur. And thank you all for staying back so long. It was raining outside, but still we'll go. Immediately you can go. There are 2 buses which will carry you to Varkala, and there will be 2 persons accompanying each bus, and they will provide you with the number. Okay. Once you go to the beach, the Varkala beach is something unique. I'll tell you in brief. Varkala is geologically more important, and it's basically a Cenozoic lateritic formation, and we call it Varkala formation. And Varkala formation is globally famous geologically, primarily because it's the only laterite rock which actually faces the sea in Kerala. So it's a cliff, okay. And what you see there is definitely it's a tourist area, so you can enjoy the evening there. There are a lot of spas and restaurants, and then you can come back by 9:30. The bus will take you back to your hotels. Okay, enjoy the day. Thank you for. Tomorrow morning at 8:30, we'll start with the virtual presentations. Okay, thank you.
The bus is parked right outside our hall, so you need not to get wet. So we can directly, as early as possible,